Hi guys, welcome to Code Like a Pro. This is going to be a full course for beginners who want to start coding in Python. The goal is for you to know how to, not just to code with Python, but to know how to use Python to do more than just the basics. I want you to be able to do way advanced stuff with Python by the end of this video. So, by the end of this course, rather. For this course, we are going to be covering a lot of stuff. We're going to be starting with variables, data types. Then from there, we move on to the primitive data types, stock of strings, integers, booleans, and all that. Then we move on to Python conditionals, the operators. Then we go to the Python collections. We'll be talking about lists, tuples, sets, dictionaries. We'll be talking about functions, the lambda, the recursion. We'll do object-oriented programming. Then at the end of the course, I'll be taking us through two practical areas where you can apply the knowledge of Python that you've had. So I'll teach you how to generate dummy data for your projects. Then I will teach you how to do basic database manipulation, create, read, update, and delete. Like I said, by the end of this course, I need you guys to be grounded in Python. So, well, thank you very much. It's a long walk to freedom. See you guys. Welcome back, guys. So I'm on the Windows machine and we are going to be installing Python on this machine. So I'm on a Windows 11, but the same process goes for Windows 10. So let's get into it. Installing Python on your Windows machine. So um, take this out. Take this out. So the first thing you want to do is to download Python. Actually, just go to python.org. Yes, just go to python.org. Then in another browser, you can go to code.visualstudio.com. So the software we're going to be using to code for this course is called Visual Studio Code. So that's what we're going to be using. It is lightweight and it is available on most operating. It is easily accessible as well. So you can just download the stable build. Then for Python, we're going to be downloading this one, the Python interpreter. So okay, it has started downloading both of them, Python interpreter and VS Code. So these are the two things we are going to be needing. So this is going to be the Python interpreter that is going to be debugging our code. That is going to be interpreting the code. While this is what we are going to be using to write the code itself. So let's wait for it to finish downloading. Okay, so I have my softwares here, so I can just start installing what I have to install. So you are going to be installing the Python first before VS Code. So let's start with the Python. You click on it twice. You're going to be seeing this. Don't forget to add Python to path. It's very important. Very important. So you install now. You don't use customized installation. You can use this one if you know what you are doing. No problem. But just install this. This is just enough for what we want to use it for. So it's going to ask you to give for administrator privileges. Do you want to run this program and whatsoever on Windows? So just say yes. We are waiting for it to install. Okay, so the setup was successful. And now we are done installing Python, so we can close this and go ahead to install VS Code itself. So like I said, this is the Python interpreter. What is debugging the code? What is interpreting whatever lines of code you write? This is it over here, and this is the software that you are using to write the code. So now install VS Code. So you accept the agreement, click on next, create a desktop icon if you want. Well, I'd rather just go with every other thing as default, but if you know what you are doing on my personal system, I would like to add this to Windows File Explorer context menu, but for now, let's just leave it as that. Well, you can just create a desktop icon for easy accessibility. So just click on install and click on install. We'll wait for it to finish the installation. Well, if you are running this program for the first time, you might want to launch Visual Studio Code from here. But if you come back, like you shut your system down and you're coming back up from the Windows icon, from the applications menu, you will see your list of applications. The Visual Studio Code will be included. So let's finish. So it will launch Visual Studio Code at once. So this is my Visual Studio Code over here. This is my Visual Studio Code over here. So as you can see, um, okay. So okay, I think this guy had Visual Studio Code initially installed. Okay, he just updated it. So, but if you've not installed it before, normally you're going to be seeing a screen that is going to be asking you to choose your theme and your preferences. So just select whatever works for you. Then you start using your VS Code basically. So what you might want to do over after doing all this, the next thing you want to do is to come to the extensions tab and look for Python. Okay, so you install the one by Microsoft. You install, yes, this first one over here, the one by Microsoft is the one you're going to be installing. Python installation successful. Print just a basic program, maybe 24. Just a basic program. I can just save this and using this play button over here, I'll run it. You can see I have 24 over here. If I want to say maybe, whoa, you can see it's working all fine. So our Python interpreter is working fine and our VS Code is working fine. So feel free to play with your preferences. You are not restricted to what I'm using. So I just want you to be able to follow along. So thank you very much. That will be all for installing Python on the Windows machine. Bye. I'm on a Mac. Okay, so I want to show you guys how to install Python and VS Code on a MacBook. So this is a Mac device over here. The first thing you want to do is to go to code.visualstudio.com .visualstudio.com. When you get here, you download Visual Studio Code for your MacBook. I have already, so it is downloaded. It's on my desktop. Exit full screen. It's on my desktop already. Um, so this is my Visual Studio Code over here. So what do I want to do? Just click on it, and you can see it's verifying code. Um, okay, this is my VS Code up and running. Wait a bit for it to come on. Okay, so okay, so you can decide to choose your theme preferences. I decide to go with this, and you can see the change. This is what I'll be using. I love to use this. This is what I'm going to be using. Let me make it full screen. Okay. So after doing all this, the next thing you want to do is to come to the extensions tab and look for Python. Okay. So you install the one by Microsoft. You install, yes, this first one over here, the one by Microsoft, is the one you're going to be installing. If you're on Android, if you don't have access to a laptop or a desktop, you can go with your Android phone. On Android, you go to your Play Store, look for PyDroid 3. That is the name of the IDE you can use to code with Python on your Android phone. For iOS, if you use an iPhone, you can go to your Apple App Store, look for Pythonista or you look for Python box. Yes, that's the name of the. Those are two applications you can use to code with for code Python on your iPhone. So well, that'll be all for mobile setting up Python on mobile devices. We are going to be talking about comments. So comments, real life comments is what you use to label something or give reference to something, or you used to like give your opinion of something. Yes, that's the language to use in programming. Two reasons why you might want to comment your code is, the first one is for readability. Then you might want to use comments to label your code so that when you come back to the code, like some few years to this time or even months from today, you'll be able to juggle the code because it was properly commented. It was properly, I won't want to say documented. Let me use the word commented for now. Then another reason why you might want to use comments in your code is so that you might want to exclude some particular lines of code from running, because if you use a comment in programming, the interpreter is going to skip those lines you commented, or those areas that you commented out. The interpreter is going to skip those areas. So the environment is all set. Now, let me say this. So two ways by which you can do comments in programming. In Python, every programming language has the way you do comments in them, but for Python, the way you comment in Python is basically you using the pound sign. Anything you write in front of this, it's a comment. For example, if you say um, print, let me say print 12. So if I run this print 12 originally, you see what I'll be getting. I'm getting 12 over here. So if I should write a comment here, say this is a program to print 12. If I should run this, guess what? I'm still getting my 12. It is not executing this line of code. It's not executing this line. So since this is a comment, the interpreter will automatically skip this line, then it will go to the next one. As soon as it sees this pound sign, citing the pound sign, it just skips the first line, then it goes to the second one. Let's do something more practical. Let me say I want to create a program to add two numbers, just something basic. So I can say commenting first number x equals to 10, no, 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 no. Then second number x equals to 13. No, 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 no. It should be y equals to 13. Then I can say sum sum equals to x plus y. Then print, let me say show output. So print sum. So if I should run this, you can see what I have over here. It's giving me 23 here, as you can see. It's giving me 23. I don't know if there's a way I can make this. No, 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 no. Okay, I think this is fine. So it's giving me 23 here, as you can see. So that's to show you that it's working fine. It is ignoring all these lines of code. It is ignoring all these ones. So they are comment. This is what you use comment for. So another way you can write a comment is to use it is not a standard way to comment, but many people use it in documentation. Like it is not recognized in Python, but the interpreter will basically see it as a comment. It is multi-line string. So if you do something like this and you write anything inside, like I am a boy less. So if you should run this program, normally this is a multi-line string. This is a multi-line string. If you do something like word equals to a boy, so if you should print word, let me say I am not a girl. I what did I eat this night? It's salado rice. Okay. So if I should print this, you can see I'm a boy, I'm not a girl, I ate salado rice. You can see it's working fine, and you can see there's a new line here, then another new line here. So it's working fine. But the reason why it is showing here is because I assigned it to a particular variable. So if I didn't assign this to any variable, there won't be anything to print, obviously. So you can see the my code editor is already giving me warnings here that word is not defined. So that's the name error, I think. So if I should run this, you can see it's giving me the 23. It's not executing this one. So any comment that I want to put, I might just put it here. So let me put it somewhere here. So I might just do this and say this is a program to add two numbers. So parameters, I can say x first number, then the second one y equals to second number, then output sum, the sum of x and y. So you can see the way, if I should run this, you can see it's still giving me 23. So this is a comment. This is treated as a comment. Normally this is a multi-line string, but it's being treated as a comment. So you can see this, you can see this, and you can see this. This is x and y are variables. Sum is also a variable. So in one of the subsequent videos I'll explain all these things better, but for this video I just want to show you how you can comment your code, because you'll be needing a lot of commenting throughout this program and your journey as a programmer. So yeah, that will be all for this video. Thank you for watching, and see you in the next one. Bye. Alright guys, you're welcome back. So in this video we're going to be talking about variables. So what are variables? In its simplest term, it is the name given to the memory location where data is stored. It is not variable that is storing the data. The data is being stored somewhere, so the variable is the reference that you have to where the data is stored. So anytime you need the data, you just call the variable. Originally the data will be in your computer's memory or your server's memory, but variable is the name you can easily use to extract the data from your memory. And if you want to modify the data, you can also use your variable to modify the data as well. So that is just variable, and that is all about variables. So let's do some demonstrations. Okay, this is my VS code. Let me to no. Okay, I have variables.py. So let me close this. Okay, so in Python there are no standard ways, like standard definitions to create variables in Python. So every time you assign a data to a variable, you create the variable. So variables, for example, x equals to 12. You can declare a variable, say age equals to 14. You can declare another variable, name equals to halogen. You can declare a variable, say school equals to unilag. One of the advantages of coding in VS Code is all this coloring, all this linting. It helps you to code better because you know what is what. At least from what you can see over here now. From what you can see over here now, you know that x is a variable, age is a variable, name is a variable, and also school is a variable. So that is just from what you can see here. Now you have 12, 14, you have halogen, and you have unilag. So these are values. These are values and these are variables. Now, one thing you should know about variables is that there are different kind of data you can store in variables. Hence, our next video, data types. So we have variables and we have the data types. The data types are basically the type of data you can store, you can manipulate, you can work with in Python. So in the next video, we're going to be talking about data types. But for here, you have variables. Variables is the name given to the memory location where data is stored. So a variable can hold a value. It can also hold a collection of values. This is what I mean by a collection of values. Let me say people equals to. You can have a list of names. No. Okay. You can have a list of names. Say Dayo. You can have Adekunle. You can also have Henrietta. So this is variable referencing a value, while this is referencing a collection. Another thing you can reference for another type of data that the variable can hold is the object. So you can use variable to store a value, a collection of values, or an object. So sometime into the video you understand all these things better, but for now just know that variables, you use them to reference where data is stored. Basically, that is it. So in the next video, where I'm going to be introducing us to data types. So thank you very much. I'll see you in the next one. Bye for now. Alright guys, you're welcome back. So in this video we're going to be talking about data types. So basically the type of data available for you to work with in Python. So every programming language has their primitive data types. In this video I want us to talk about the primitive data types. We also have the collections too. The four data types that we're going to be talking about, we are going to be talking about the integers, the floats, the strings, and the booleans as well. So those are the four data types that we're going to be talking about. Now in programming generally, you have the numeric and the non-numeric data type. So the numeric data types, they are numbers basically. Then the non-numeric data types are non-numbers. So the under the numeric data types, so for Python we have the integers and the floats. Integers are whole numbers. Floats are decimal numbers, like floating point numbers. So integers, like when you want to store a kind of data that can be counted, that is where integer comes in. For example, the number of people in a place, or the number of something. Like if you count something, the number it amounts to, that is the kind of data integer stands for. But for the float, if you can't count but you can measure, then the float comes in. So that's the major difference between the two of them. For example, your weight, your height, that is float. Your body mass index, it will still be a float. So your account balance, if you check your account balance is never a whole number. So that is also a float. But if it is something you can count, like the number of something, of people in a place, the number of cars on the road, a lot of data like that, the number of supporters in a stadium, like something you can count, that is where integer comes in. But for the strings under the non-numeric data types, you have the strings and the booleans. So for the strings you have it's just a collection of characters. It might be a single character, a collection of characters. So for example, your name, your house address, your, because you can say number something something street, the town, the state, the country, and like that, and just etc. So that is basically what a string is, a collection of characters. It might be a single character too. A single character might be your grade, or your pay level or something. If they say your pay grade, you might be having your level. Your pay grade might be A, might be B, might be C. So like that. So basically that's what a string is. Now under the non-numeric data types too, we still have the booleans. The booleans is a boolean is a two-state data type. So two-state data type, as in majorly it's true or false, 0 or 1. So when you want to store a data that has only two sides to it, for example, admission status, admitted or not admitted, true or false. So That is all. Those are the four primitive data types that we're going to be talking about. We have so many other ones, but these are the ones you're going to be using in your everyday activity. So as a programmer, let me do a bit of demonstration for us. So um, my environment data types .py. Okay. So for the data types, let me use multi-line commenting. I told you that the first one is integers. Integer. The second one is what? Floats. The third one is string. Then the fourth one is boolean. So now I grouped all of them into numeric and non-numeric. So let me do justice to that as well. So numeric data types. So to make it, I want to make it more understandable. So let me indent this one. So for the non-numeric data types, you have this other one. So this can be 1 and this can be 2. And please don't forget that these are primitive data types. We also have the Python collections where you talk about the list, the tuples, the sets, and the dictionaries. But for now, we want to talk about the primitive data types. So integers. What does an integer look like? For example, age. I'll treat age as an integer. Let me say 14, or I can say number of students. Let me say 24. Or I can have something like purchase units. Purchase units, let me say 10. So you can see what I have over here. Purchase units 10, number of students 24. You can see these are examples of integers. So you can see example of integers. If I want to output any of the data that I have here now, I can just say print age. So if I should run this code, you can see I have 14, and the reason why I'm having 14 here is because age is referencing 14. So if I should bring in number of students here, so if I should run this, you can see I have 24, not 14, because number of students I have 24. But for the print function, you can say age comma number of students. It will print the two of them side by side. So you can see I have 14, then I have a space, then I have 24. So it's one of those things you can do with the print function. But since I've shown you examples of integers, now let me show you examples of floats. So floats. Say account balance. Account balance, I can say 55,000.65. So your account balance. So I can also say pi equals to 3.142. So I can say area equals to 154.00 if your radius is 7. Yes, if the radius is 7, then the area of the circle will be 154.0 or 0.00. So you can see the examples of floats as well. So let me say print area. You can see 154.0. It's rounding everything down to one decimal place rather. So if I say print pi and I run the code, you can see I have 3.142. So those are examples of floats. So for strings, so I can say name equals to let me say Samuel, Alexander. Okay. So this is a string. Let me say address. I can say um 1 stroke 2 pound road. Aba Abia. One of those things that VS Code gives you the opportunity to do is to do word wrap. You can see now that I'm writing something and it's exceeding the like my screen. I have to scroll like this to see the end of the line. You can use Alt Z on your keyboard to do word wrap. This is what we call word wrap. So Alt Z. Another way you can do it is go to View. You will see word wrap here. You can see. So if I should click it, you can see. But View word wrap. So I won't have to be scrolling outside of my screen to see what I'm working on. So you can take notes. It's one of those advantages of working in VS Code actually. So Abia State, then hometown. Yes. So I might just come here to print them. You can see I have Samuel Alexander here. Then address. Address. So just run this. Yes, you can see 1 stroke 2 pound road Aba. So hometown. Run this. You can see I have a posse over here. So my strings are working. Then finally the boolean. The boolean. Um, so for the boolean I have admitted. Can say true. So I can also do something like admitted true. Then I can do something like is smoke. So I can say false. Then I can say pass toxicology. I can say true. So if you want to store data as per with respect to a student's admission status, that will be true or false. If you are not admitted, you are not admitted. If you are admitted, then you are admitted. There is no other possible side to it. So if somebody smokes, you can either you are a smoker or not. So there's no sitting on the fence. Then we have past toxicology. If they check your blood sample, they either find implicating substances there or not. So that is just it. So and you can also print the results. Print. You see, it's giving me true. It's smoke. Okay, run this. You can see it's also giving me true. So everything here works. Everything here works. Everything here works. So that will be all for data types. So I'll see us in the next video where we are going to be discussing something else with respect to Python programming. So thank you very much. I'll see you in the next one. Bye. Welcome back, guys. In this, we are going to be talking about typecasting in programming generally. Typecasting is you converting from one type to another, basically. For example, you might get into a use case where you have to convert a string to an integer. we might get into a use case where the data available is a float, like a decimal number with decimal parts and the whole number parts, where you have to convert to the whole number itself. So typecasting, that is what you use it for, basically converting from one type to the other. So let me show us how we do typecasting in Python. So um, let me create a new file for typecasting.py. Okay, so I can close this. So I can have this one. So typecasting, like I said, is used to convert from one data type to another. For example, if I have let me say value equals to 3.142, and I want to get the type of data that value is, all I have to do, let me print the type of value. If I should run this code now, yeah, I'm running for the first time. So you can see one of the advantages of you coding in VS Code is you can see all the suggestions that's giving you variable value. It's a float data type. It's already even giving you here. So the type function too. So you can see the print function. It will give you. You can see, just hover over it. You can see the function and the what it does. So all this in-app documentation that we have will make your life way easier as a programmer. So let's continue. You can see I have class float. If I have something like let me say yes equals to maybe 4, and I say print type of yes. So if I should run this, so you can see the first one I'm having int, the second one I'm having what, float. But for one reason or the other, I might be given a value of 3.142, and what I need is a whole number. So I have to convert value to a whole number, which is an integer, before using it in my program. So for you to convert value to an integer, it's very, very simple. Let me print conversion. So it will give you some sort of demarcation in the output. So I can say print if you want to convert from integer to float, you use the float function, and if you want to convert from float to, use the int function. So if you want to convert from any data type at all to int, you use the integer. If you want to convert from any data type to float, you use the float function. So if you want to convert from any of these data type to string, you are going to be using the str function. So that is it basically. Like I said, if you want to convert from integer to float, from string to float, you're going to be using this float function. If you want to convert from string or float to integer, use this integer function. If you want to convert any of these to a string, use the str function. If you want to convert to boolean, you're going to be using the bool, the bool function. But people rarely use this, so let me just take it out. Now let us start converting this to. So if I should print let me say str, let me convert to string first value, and I run this. I don't like running. I rather just click on this because this takes a lot of time to run, so I won't be using that anymore. Okay, so you can see string str, then I bring in the value. It has converted it to 3.142. So normally the value of this 3.142 will be something like this. It will be 3.142. No. I said yes. That should be 3. Now, this is a string. This is a string, and this is a collection of characters, and this is way different from 3.142. They are not the same thing. They are not the same thing. Let me show you why they are not the same thing. If I should do an equality test here, print, let me say okay, let me say value equals to str. This double equals to, I will introduce it to us in a later video. So um, you can see this is value over here, 3.142. And as you can see, after conversion, I still have 3.142 here, but this is not equal, meaning that it is false because the type of this one is different from this one. You can see the type of value over here, which is directly above this one, is floats. But let me show you the type of this one. So if I should run this, you see what I have over here. This is a string. Why this is a float? So because I've converted it to a string already, so I, I can't consider it a float anymore because it have been converted. So you see the difference between the two of them. So that is how you use strings. So let me convert this years to a string. So instead of value, I have years. If I should run this, you see what I have. I still have string. So this is years over here. The first thing it will output, you can see it's an integer, but coming here, it is now a string. It is no longer an integer. So that is that about that. So converting from integer to float and float to integer. So converting from integer to float. Normally, let me say value is 3.142. For me to convert to integer, all I have to do is let me say integer value equals to int, then let me wrap this value in. So like I said, you use the int function. So this int function, you pass this value into the int function. Then after passing value into int, whatever it returns will be stored in int value. So this is a variable, this is a function. So you use this function to convert whatever you pass into it to an integer. So now let me print int value. Okay, int value. So you see what I have over here now? 3. It truncated the decimal part and gave me the whole number part. Basically, that is how it works. That is how it works basically. So that is that about that. So that is converting from integer value to from a float to integer value. So let's convert to converting. Let's convert this one to a float now. So you have float value equals to, let me say float. Don't forget I said use the float function. Yes. So let me print. Guess what? You see what I have now? This will be 4.0 because originally it is 4, but because I'm converting it to a float, it is giving it a decimal part, which is 4.0. And please, 4 and 4.0 are not the same thing. 4 and 4.0 are two different values. One is an integer, while the other one is a float. So that will be all for this section. I'll see you in the next one. Thanks and bye. Come back. So in this video, I'm going to be introducing us to the concept of IPO. So IPO stands for input process output. So a computer is an electronic machine that will accept data, process the data, then out of depending on the kind of processing that it does, it will give out information based on the input that it has received. So the processing is based on one or two algorithms, and algorithm is basically the steps you take to solve a problem or to get something done. So that is the processing. But IPO itself stands for input process and output. And in Python, in your journey as a developer, you are going to be doing a lot of input process output. So here in Python, I'll show you how to do console input. Then you, out of the console input, you're going to be accepting data from the user. Then you will do your processing using what you're going to be learning throughout this course. Then the output, I'll also show you how to do the output. Actually, I've been doing output before now. If you have been following the course as we have been teaching it, you have been doing output before now, but you don't know. The print function is actually what you use to do console output. So let's get into it. So let me create a new file and call it 5 ipo dot py. Okay, so basically this is input process output. And now for you to accept console input in, let me say, console input in Python, you are going to be using the input function. This is the function, and as you can see from VS Code here, reads a string from the standard input, which is this console over here. So like you write a program that will allow the user to enter whatever value they want to enter in the console. Then your program will read this value and do whatever it wants to do with it. So how do you use the input function? Now, don't forget, like we all know already, a computer is an electronic machine that will accept data, process the data. Now, before it can process the data needs to be stored somewhere. So basically, what you want to do is to read input from the user. Then, after reading the input, you're going to be storing it somewhere on your computer's memory, a variable. So you're going to be accepting the input, you save it in a variable, then you do the processing, then give the appropriate output. So input, I can say, let me say x, or let me say name equals to input. Now, if I should run this program, you can see it has not closed the execution. It is waiting for me to enter something. So I can say Chris, enter. There is nothing again to do after line 3. So what can you do with the data you now have? I can say print name. So what it does is, if I should say name equals to input, then print name. Anything I should give to my program through the standard input, it will read whatever I give it, save it in name, then show the output using the print function. This print function is what you use for output, basically. So this is not something complicated, trust me. It's very simple. So name equals to input, then run it. If I say Chris, you can see it's giving me Chris back. Let me put some sort of demarcation here. Print after input. So if I should run this code and I say maybe halogen, you can see what I have over here is what is happening over here. So halogen is basically me giving this data to name, then it will print after input, which is what it does here. Then whatever I have given it as the input is what is going to be giving me here, because that's what I want to print. So but one thing is that it is not always appropriate for you to just use input directly like this. If I should run this program and you are showing it to somebody for the first time and the program just is executing like this, the person might not know that they actually have to enter something. So Python is giving you the ability to put a prompt to your input function. So for example, let me close this execution. So input function, then you can put a prompt, say enter your name, enter your name. So if I should run this, you can see it is telling me enter your name, Chris. You can see after input, enter the name. You can see after input, Chris. But you can see that this is not looking too nice. So I can just put some few space in here. So just to make it look more professional. Well, professional is not the word, just to make it look nice. So if I should run this, I can say Alex, and you can see I have my Alex here. So basically that's how to use your input function. But one thing you should know is that when you enter your whatever value you enter through the standard input, Python is going to be reading it as a string by default. Python will be reading it as a string. So if you want to make use of integers, for example, let me comment all these ones out so they won't be executing. So if you want to make use of integers, for example, I can say x equals to let me say input enter first number, let me say, then y equals to input enter last number, Okay, so now let me say print x plus y. So normally this is supposed to be giving us, if I say 2 and 3, it's supposed to be giving us 5. So let's go and try it out. So run this. The first number 2, second number 3. It's giving us 23 instead of 5. So now one thing you should know is that in Python, the plus operator, this operator over here, this plus operator over here can be used for two things. It can be used for addition and concatenation. So addition is basically when you want to add numbers together. For example, when you want to perform, when your operands are integers, are numbers rather, it can be floats, it can be integers. So when your operands are numbers, that is the values you want to add together, that is when it becomes addition you want to do. For example, 2 and 3, or 2 and 3.5, or 3.5 and 3.5. Sure, you get. That is addition. But concatenation is when you want to combine strings together. For example, you have the first name, the last name, then you want to combine everything together to give the full name. That is concatenation. So what is happening here now is concatenation, because let us print the type of x and print the type of y. So if I should run this program now, and let me say 10 and 5, you can see that the type of x is what? str, and the type of y is also str. So I'm having 105 because normally what it's going to be doing here is going to be doing 10 plus 5, and this is going to be, normally should be giving me 15, but it is not giving me 15. It is treating this 10 as a string, and it is treating 5 as a string as well. So instead of 15, I'm going to be getting 105 because it is concatenating everything together. But what is the solution to this particular problem that we've encountered now with the input function? It is very simple. All you have to do is, since it is an integer that you want to work with, after accepting this input, you want to typecast. So how do you typecast? You can say x equals to int x, or y equals to int y. So if you should run this program now, enter first number, let me say 10, enter second number 5. You can see I'm having type of x as int, then type of y as int. So it is giving me the appropriate answer now, which is 15. So this is just it basically. If you want to, now you can see that we converted both inputs to integers. What if we wanted to use a float instead? What if what we needed was a float? So what you want to do is to say, do something like float, then float. So if I should run this, first number, let me say 2.5 and then 6. You can see I have the appropriate answer. Now do another thing you can do is to use eval, just to make your life way easier. Just evaluate. Eval is going to be checking the type of data it is supposed to be, and it predicts accurately. So if I say eval, then eval, makes my life way easier. So first number 2.5, second number 7, and boom, you can see it is evaluating it properly. This is a float and this is an integer, and both of them are eval. So this is one way you can accept inputs from, let me delete this, you can accept inputs from the user, then you process the inputs whichever way you want to, then you show your output. So, and mind you, instead of doing this, you can as well do something like eval, you open, then you close the inputs. So Alt Z. So line 8 spans through to the next one. So eval input, enter first number. You can see what I have over here. So this particular close bracket is closing this one, while this opening corresponds with this closing. So you can see eval. Then I can also eval here. open, then close. So instead of using coming here to write those two extra lines, you can just do away with them. Then you run your code. After running the code, what is the first number? Let me say 2.3, then 4. You can see both of them, it works just fine. So before we leave here, I have some exercises for us. So these are the exercises. I have some exercises. They are very simple ones. So write a program to accept user's first name and last name, then print the values as a full name. Then write a program to accept a number from the user, then increase the value of the number by 7 and print the output. Then write a program that will generate the value of pi. Pi is 3 point, is basically 22 over 7. So pi is 22 over 7. Well, so you can pause the video, try to work on these exercises. Then I'll see you in the next video where I'll be showing you the solution to the exercises. So thank you. Bye for now. All right. We are welcome back. So let's solve the assignments, the exercise rather. So let me comment all these ones out. Let me comment all these ones out so they won't be executed. So write a program to accept the user's first name and last name, then print the values. So very simple. What you have to do, let me write this comment over here. Then so accept the user's first name. So I can say first underscore name equals to um, let me say int. No. Since it is a string, I don't have to typecast, so I can just say input. Then I'll say enter your first name, leave some space, then um, to make it faster, then I can highlight first. Don't do this at home, please. So I'm just trying to save myself time. So what I did here was that I copied the whole of this. Since it looks similar to the next line I want to create, I copied the whole of this. Then I have last name over here. So after pasting the whole sentence here, I just selected this. After selecting this, I used Control D to find the next word that corresponds to this. So finding the two of them, you can see both of them are selected. I can decide to edit the two of them whichever way I want, but what I want is just last. So normally to be first, then I'll make it last. That's just it. So for me to output the full name, print, I can say first name plus no, comma last name. Okay, this is one way to do it. So enter your first name. I can say Chris Halogen, and bam, I have Chris Halogen. So another way you can do this is to use concatenation. For example, you can say full name equals to first name plus last name. So then you say full name. So you run this, let me say Alex, Chris, and boom. No. I made it. So you can just Alex, Chris, let me say halogen. So you can see what I have here, Alex, Chris, halogen. Let me run this again. This is not giving me the output I want. So Alex, I want to make it more obvious, Chris. So you can see the Alex, Chris, it is concatenating Alex and Chris, but it is not giving any space between them. The reason why the first one was giving me space is because for the print function, if I say print, let me comment this one out. If I say print 1 comma 2, naturally it is going to put a space between them. You can see 1 comma 2. If I say print Chris and halogen, naturally it will put a space between them. That is what is happening here. But let me undo everything I've done. So but if I want to say, if I should run this and I say Alex Chris, you see it is not giving me that space, because what I'm doing is I concatenated first name and last name directly. So what can I use to solve this? I have to bring in a space bar somewhere. No, no, no. You can see just a string that's a space bar. So the full name is going to be the first name, then the space bar, then the last name, the space character, then the last name. So if I should run this and I say Alex Chris, no, 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 no. Okay, let me say Xander. You can see what I have now. I have Alex Chris, then I have a space, then I have Xander. So this works fine. So let me comment all these ones out, then we solve the next one. Write a program to accept a number from the user, then increase the value of the number by 7, print the value. So write a program to accept a number from the user, then increase the value of the number by 7 and print the output. So this is very, very simple. All you have to do is to say, let me say number equals to, let me say int, let me use int, then input, enter a number, put some space there, then increase the value of the number by 7. Now if you want to increase the value of another value by 7, you can just do something like number equals to number plus 7, print number. Very simple. What I'm doing is that I'm going to be accepting a number, then anything I accept, it is going to be giving me as a string, so I have to convert it to an integer first. Then after converting it to an integer, anything the number is, I'll add 7 to it, then I will assign it to number again. So what I'm doing basically here is that I'm increasing the old value of number by 7, and I'm now assigning it again to number. Just if the user should give me 7, for example, at the end number is going to be 14. So let's try it out. 7, you can see I have 14. If I should run this again and I say maybe 10, you see I have 17. So it's working fine. Another thing you can do is to say number plus equals to 7. This is an augmented operator. So I'm still going to be showing us sometime in this course, arithmetic operators. So I will explain this particular operator too, but it works. So you can see 8, then I have 15. So I believe the second one is sorted out. Let's go to the last one. Write a program that will generate the value of pi. This is the simplest of all of them actually. So you can just print 22 over 7 and, and that settles it. So 3.142 whatever. But if you want to make it, you can say pi equals to 22 over 7 and you output pi. It works as well. You can see both of them works. So thank you very much. That's the solution to the solutions to the problems. So I'll see you in the next video. Bye for now. Basically, it might be a single character or a collection of characters. Like I said in a previous video, a string can be your house address, it can be your name, it can be the name of a location, it might be the name of a product, the product description. A string is basically it has a lot of examples. So without wasting much of our time, let's just get into it. So this is my VS Code. No, 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 no. So create a new file, 6 strings dot py. Don't forget the extension. So close this. Okay, so the string, a good example, let me say name equals to Alexander. So I have Alexander here. This is a string, and if I should print name, running it, you see I have Alexander here, working fine and good. And another thing you should know is that in Python you can use the single quotes or the double quotes. I can also do something like name, or um, let me say another, or let me say name temp. I'm looking for a suitable variable name, Alexander. So if I say print name temp, running this, you can see I also have Alexander. So let's do an equality test here. So you can see it is giving me true that name Alexander and name temp are the same thing. So that's just it basically. So Alexander then Alexander, the single quotes, the double quotes, both of them works. But if I should close this and I use this, it won't work. You can see the Python is already giving me two red lines under both of them to tell you that they are not valid statements. It will give me errors here. So you can see it's giving me an error, the syntax error. So just take note. You either open with a single quote, close with a single quote, open with a double quote, or you close with a double quote. Now, you can also print the string directly here, for example. So instead of having to assign it to a variable, you can just print it directly. It works as well. It works. So you can see I have Alexander here. It works just fine. So let me show you multi-line strings. I can say SA equals to multi-line strings, like I said while I was explaining multi-line commenting. So you can use single or double quotes, both of them will work just fine. So my name is Chris. So you come to the next line, I love Python. Then I am a student of Unilag. Then what else? I develop for WordPress using PHP. Then I love machine learning. What else can I say about myself? Um, okay, this should be. Um, I am I'm a boy. I beg. So I'm just trying to explain multi-line strings here. So if I should come here and say print, let's see. So you can see what I have over here. My name is Chris. Oh no, this space is not supposed to be here. I don't like the way it's looking like. So you can see my name is Chris. I love Python. I'm a student of Unilag. I develop for WordPress using PHP. You can see all of them multi-line strings. So they they work just fine. So this the next thing we're going to be looking into is indexing. So indexing is basically you getting the index of one of the characters that make up the string. For example, let me comment all these ones out. So let me comment them out. So I can say for indexing, let me say name equals to Alexander. I actually have a close friend whose name is Alexander, alpha male. So name is Alexander. Then for me to index, I might decide to index um the first character. Now indexing in Python starts from zero. Actually, in most programming languages, indexing starts from zero. So this element here is the zeroth index. So this is the first index. This element is at the first index, the second index, and it continues. So this is the last index. So that is to tell you that if I count all the characters that we have here, since the indexing is starting from zero, then obviously the index of this one will be the length of the whole string, which is the number of elements that make up the string, minus 1, since this is starting from 0. So if I want to index the first element, all I have to do is to say name, name, then I'll bring in this bracket, then I'll say 0. So this is me indexing the first element over here. Let me print the value of name. So if I should run this, boom, you can see what I have here now. I have E because I'm indexing this one over here. So moving on, if I want to index the fourth element, that would be 0, 1, 2, 3, and 4. So that would be 4. You can see I'm also indexing A. What if I want to index this D? So no, I made a mistake somewhere here. Z, Z. So if I want to index this D, for example, I can say 0, 1, 2, 3, 4, 5, 6. So that will be 6. So you can see I have my D, but you can see that Python gives us the ability to index from the left and from the right as well. So positive indexing is you indexing this way. Negative indexing is you indexing from the end to the back. For example, if you want to index this last character over here now, you can just say you are indexing -1, and if you run it, it's going to be giving you the last character R. So that is to tell you that this D over here, you can index R two ways. You can either say one, no, 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 0, 1, 2, 3, 4, 5, 6, 7, 8. So you can either index by 8 or by -1. So both of them works. So you can see it's giving me the R. If I want to index this D, for example, this is -1, -2, then -3. So -3. They all have their use cases, both positive and negative indexing. So we'll see as we proceed in the course. So that is how you index basically in Python. That's how you index your strings. It also works for lists, and I'll show us how we can use this in our list. So that is indexing. Now, if you want to loop through your string for one, you want to traverse the string. That's the language to use. You want to traverse the string. Traverse the string is writing your program in such a way that your program is visiting every single element that is in the that makes up the string. There is also a way to do it. So let me take this one out. If you want to traverse the string using a for loop, most people use for loops to traverse the string. So I'll still I'll introduce us to loops, and this for loop especially I will introduce us to it in a later part of the course. So for now I'll just show you how to do it. Let me say for character and name, you can just print the character. So if I should run this, you can see it's giving me Alexander. So that is it basically, for a way for you to traverse the all the elements that make up the string. One other thing you can do is you can say this is the character alt z. Don't forget, I like to use word wrap. Okay, so this is the character. So let me make it look more um, you can see I have this is the character ALEX, and it continues. So this is just me traversing the whole all the elements that make up the collection of characters. So this may not make sense now. It may not make sense now. When you get to for loops, you understand it better. But for now, this is how to traverse a string. This is how to traverse a string. So it's not It's not complicated at all, trust me. So if you want to look for the length of a string, for you to look for the length of a string, let me take this out. To look for the length of a string, all you have to do is to do len, then the string itself. You can pass the string in directly. You can also use a variable to pass the string in. Both of them works just fine. For example, I can say length of Alexander. Then let me print length of Alexander. Then you can so run. You can see I have 9 here. Don't forget that indexing starts from 0, but it will count everything the way you should, but indexing starts from 0. So this last index will be 8 or -1. So if you want to find the index of the last character, you can just do the length of the whole string -1, or you just use -1 directly. Both of them will work just fine. So this is me passing the string directly into the len function. So instead of passing the string, I can just say name. So I'm passing it as a variable now. So this variable has a value, Alexander. So I'm passing name directly to the string. It works. So run this. You can see it's giving me 9. It works just fine. So um, now this is name and this is Alexander. Another thing you might want to do is to test for membership. For example, you can want to test if X is a member of this whole string. Don't forget, this is a collection of characters. To check if X is a member of this collection, so you can do something like X in X in name. So let me print the value of this. Print X in name. So you can see it's giving me true. If I say A in name, you see it's also giving me true to tell you that A is a member of this collection. What if I say Z? What if I say Z? You can see it's giving me false here because Z is not a member of this particular collection here. You will get to use cases where you need to test for membership in a string like this. It works for list too, but for now let's just let's keep it basic. So you can also say not in name. If you should run this, you see it's giving me true because Z is actually not in name, and you can also, if you do maybe 7 not in name, it will also give you true because the character 7 is not in name. But if I add 7 maybe to the end here and I run it, it's going to be giving me false because 7 is now in name. So let me take this one out and retain the name. So another thing you might want to do is string slicing. String slicing. Slicing basically is, it helps you to get a portion of the string, like a substring of the original string. So what do I mean by a substring? So I have Alex. No, 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 no. Okay, I have Alexander. Now you might want to extract maybe only Alex inside Alexander, or you might want to extract only Xander. You understand? So if you have Alexander, you might need only Alex or Xander. So for you to slice your string, let me say sub string equals to name. Then at the end here, I'm going to be printing the substring. Okay, I'm going to be printing the substring. So name equals to Alexander, substring equals to name. Now if I should print this directly, it's just going to be returning Alexander for me because I've not sliced it in anything. So if I want to slice, I'm going to be putting the beginning, then colon, then the end. This is what I mean. If I want to start from the beginning, for example, I'm going to be saying 0, the 0th index, then the index where it's going to be stopping plus 1. For example, if I want Alex, so 0 is where it's going to be starting from. So 0, 1, 2, 3. So you can see that Alex is at the third index. But if I should say 3 here, it's not going to be indexing the x because the x is not inclusive. This ending part is not inclusive. So you can see I have ALE, but if I want to add the x, I have to make this one 4. So if I should run this code now, you can see I have Alex. I have Alex because I'm indexing from 0 to 4. Now, another thing you should note is that if you are indexing from the beginning of the string, you don't necessarily have to put anything here. You can just say colon 4. Python is smart enough to know that, okay, you want to start from the beginning, so it will still give you your Alex back. Now, let me say all I want is LEX, just LEX. Then, don't forget, you try to get the index of L, which is 0, 1. So, you are starting from 1. Then, X is the third index, but you know that X will not be included. So, you are going to be indexing this one, which is at 4. If you should run this, you understand, you have LEX. Now, what if you want to index Xander? If you want to index Xander, you can just say 0, 0, 1, 2, 3. So you're going to be starting from 3. Then you're going all the way to the end. So you don't have to put anything at the ending part. So you see, you have Xander. You have Xander. So another thing you might want to do is if you want to maybe you want to stop at D. So you can just look for the index of D, which is 0, 1, 2, 3, 4, 5, 6. So you can put 6 here. It works. You can see XEN. Oh no, 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 this is supposed to be 7. XEND. So run this. You see XEND, it works. Now another thing you can do is you can use negative indexing for this ending part here. It works as well. So this is -1, -2, then -3. So 3, -3. It works just fine. You can see what I have here. You can see what I have. So XAN. You're stopping at D. Okay, this will be -2. This will be -2. So run this. You see XAND works just fine. So that is all about string slicing for now. Let's take this one out. So there are some special functions that come with a string. Every data type actually has some functions attached to them. So for strings, if you want to convert the whole of Alexander to uppercase, all you have to do is to say name.upper. So if you run this, you see Alexander, everything is in uppercase. If you want to change everything to lowercase, you say name.lower. We have so many string functions. So you can see everything is in lowercase now. Everything is in lowercase. So if you have like some spaces at the beginning over here and some spaces at the end, if you print it originally like this, you're going to be having only the name. You can see it is taking these spaces and also the spaces at the end into consideration. So what you can do is you can say name dot strip. So if I should run this, guess what? It has taken away the spaces at the beginning and the spaces at the end as well. So that is it. Now another thing is that you might want to get some you might want to replace some portion of the string with another string. For example, let me take all these ones out. For example, this is Alexander, but imagine that you want to give if the name was supposed to be Alexandria. Do you understand? If it was supposed to be Alexandria, so you know you're in trouble already. So this is DER and RIA. So you might want to replace ER with RIA. Very simple. All you have to do is to say name dot replace, then ER comma RIA, and guess what? You see it has taken the er, the original er that we had. It has taken it away and replaced it with ria. So that is it basically. And since we have two e's that are here now, let us change all the e's to dollar signs. So let me say all the e's. I want to change it to dollar sign or dollar sign. So run this and waiting for it to run. You can see what I have over here. You can see what I have. So it's working fine. Um, so that is how you use the replace function for Python strings. So well, um, another thing you might want to be able to do is to split your Python string into a list, to generate a list from your string by getting portions of the string using a delimiter. Let me explain what I mean. I might want to do something like names equals to Chris, Alex, Samuel, and I want to generate a list of names from this string that I have over here. So I might just say names dot split. What delimiter am I using? A space character. So if I should printing this, I'm going to be having um, I have Alexander. Oh no! I'm making a mistake here. So I should be having names. So you can see what I have here. I have Chris, I have Alex, and I have Samuel. So that is me generating a list from a string. Instead of space, I might also use a comma here and use a comma. Put a comma here. Then instead of space, I'll use a comma. So I should run this. It still works. Now, the whole gist about this split function is that you use a delimiter here. Let me try to get a delimiter that might work. Okay, let me use E for example. If I should use E here now and I run this program, you can see what I have, Chris. You can see because that is where the E, I have one E here, I have another E here. So that is it. So you can see it's not looking nice. Let's just take it back to the comma and you can see that is you splitting it. So another thing you might want to do for a string is concatenation. Like I said in a while ago, I said concatenation is when you want to add strings together, when you want to append one string to another one, or when you basically want to join strings together. For example, I might have something like university, then off, then Lagos. So since all the operands involved are strings, this is going to be a concatenation operation. So I can say sentence, or let me use line. Line equals to this. So print line. You can see what I have here, University of Lagos. So you can see it's not really nice. So one thing I can do is to add a space before and after the off. So you can see it is giving me this space over here, then this space over here. So and if you don't want to put the space bar there, the space character rather, you might do something like this. So this works as well. So you can see plus. So if I should run this, you can see University of Lagos. It works just fine. That is concatenation. Now, another thing you might want to do with a string is string formatting. For one reason or the other, you might want to inject data into a string before making use of it, storing it, or showing output. For example, if you have something like okay, let me say name Alexander, then let me say age is maybe 25. Now I might want to do something like I might want to print a string like my name is whatever is the value of name, then and I am so years old. So if you want to print something like this, like you want to inject name into this, you can use string formatting to format this string to contain this data. Now, how do you go about that? You can say, let me say line. I love to use line equals to. You can do something. You can open a string. Now you put f at the beginning to show that it is a formatted string. There are two ways to do it, but this one is simpler. So let's go with this one. You can put f at the beginning to show that it's a formatted string. Then you say my name is name and I am no, this should be a capital I am age years old. Okay. So this is me injecting name here, then age here. Whatever is the value of name and age will reflect in the string. So let me take this one out. Then boom. You can see my name is Alexander and I'm 25 years old. Let me change this to maybe Samuel. Then if I should run this, you see my name will no longer be Alexander. My name will now be Samuel. So let me change this to maybe 13 years old. So you can see what I have. My name is Samuel and I'm 13 years old. So this is me injecting data into a string. So finally, for this string, we are going to be having escape characters. Now, escape characters are special characters that you inject in your string. It comes in handy. Let me do a demonstration for us. So, what if for this particular line now, I want it to be something like my name is Samuel and I am 13 years old. I don't want this. I want it to print my name is Samuel in one line, I'm 13 years old in the other line. Now, how can you do that? You can put an escape character backslash. An escape character is basically backslash and what the character is. So the three major escape characters that you're going to be using is the double slash, which is if you want to add a slash in your string, that's where the double slash comes in handy. If you want to add a new line character, then if you want to add a tab spacing. So I'm going to demonstrate the three of them using this string over here. So to keep the video short. So if I should do this, you can see what I have over here. My name is Samuel. Then I have, you can see that I'm using two backslashes here, but it's giving me one here. That is how it works. So if I should use new line, let me delete that space there so it comes out nice. If I should use the new line escape character, so you can see my name is Samuel and I'm 13 years old. You can see the new line over here. Then another thing, the last one will be the tab spacing. The tab spacing. So click on, you can see my name is Samuel and it's giving a tab spacing. I am 13 years old. It's time for you to do yours. I've been coding alone since. It's time for you to do yours. So I have some exercises for you to work on. They are fairly simple exercises. Actually, they are simple exercises. They are not complicated at all. So these are the exercises over here. Let me highlight the whole of this. Turn it to a comment then. And then these are the exercises over here. Boom. So write a Python program to calculate the length of a string, to count the number of characters in the string. These two are almost the same thing. They are the same thing. Let me just take this one out. So write a Python program to get a string made of the first two and the last two characters from a given string. So the user will be the one to enter the string, obviously. So to get a string from where all the occurrences of the first character have been changed to dollar sign. So except the first character itself. So then we have this, and yeah, that will be all. So thank you very much. I'll see you in the next part of the course where I'll be giving you the solution to all these problems. Thank you. See you in the next one. Welcome back, and let's get the ball rolling solving these exercises. So for the first one, write a Python program to calculate the length of a string. So how long is the string? So don't forget, let me say input data equals to input enter a string. So instead of using the spaces that I would normally, that is not so nice. So I would rather use the tab spacing. So then I'll just print the length of the input data. The length of the input data. So enter a string. Let me say Alexander. You can see I'm having 9. If I should homogeneous ideas, you see it's giving me 16. Works fine. So the first problem is solved. Then let's go to the second one. Write a Python program to get a string made of the first two and the last two characters from a given string. The first two and the last two characters from a given string. So let me say, let me first of all bring my question here, my problem rather. So let me say input data. Let me copy this one. Let me use it. Okay, so now the processing. I can say output equals to input data indexing the first two characters. So it will be 0 indexing 2. So that will be 0th and the first element. Yes. So I don't have to put this one actually. This 0 over here. Then plus input. No, this should be input data, not just input. Okay. So input indexing -3 till the end. Yes. So the -3 is going to be indexing -2 and -1. So print no output. Okay. So that is all about this one. So print the no run the code. Enter a string Alexander ALDER. Okay, this should be -2 since it is where I'm starting from. Please take note of that. Alexander. Yes, that's the correct output. So this is solved. Then we go to the next one. Write a Python program to get a string from another string where all the occurrences of the first character have been changed to dollar sign. So copy, come down, then paste it. Don't forget input. It's not by force that you use the same input data I'm using, please. It's not by force. So input data is input, enter a string, then tab spacing. Okay, so the first thing you might want to do is to get the first character. So obviously you can say first character equals to input data indexing 0, so you have the first character. So what you want to do now, output equals to input data dot replace. So you want to replace the first character with $sign, and that settles it. Print output, and boom, we are good to go. Enter a string Alexander. Something is wrong with what we did. Output is input data. Okay, yes, it's working fine. It's working fine. This is capital A, and capital A is not the same thing as small a. So let me show you what I mean. So capital A, I mean this A is not the same thing as small a. No. So if I should run this, it's going to be giving me false because they are not equal. They are not equal. Now you should know that this single equals to is an assignment operator, while this is a membership operator. You should know this is a logical operator rather. This is a logical operator. So you should know that this is used to assign variables or values from the right to the left. So but this is just used to find the equality between two values. So please, you should take notes when we treat operators. You understand these things better. So input data. Okay. So this works. Let me just undo everything I've done. Okay. So if I should run this code again and I use small a, you can see all the a's there. All the a's there. So let me say no. Let me say Alabama. You can see all the a's there. They are gone. So this works. Now let's go on to the next one. Write a Python program to get a single string from two strings separated by a space and swap the first two characters of each of the strings. So let me say okay, good to go. Now write a program to get a single string from two different strings. So the user will be giving you two strings, but for this particular one, let us be the one to supply the two strings. So to save us time, or let's just do it the same way we've been doing it. Input data, copy. Let me say input data 1. Then the second one will be input data 2. Now, what do you want to do now? To get a single string from two different strings separated by a space. Now, the first thing you want to know is that you're going to be concatenating these two strings together, but there's a clause here. Swap the first two characters of each strings. So the first two characters of this will be going to this, then the first two characters of this will be going to this. So what does that tell us? Now let us first of all get the first two characters of this one. So to index the first two characters, you'll be doing input data 2, indexing everything column 2. So the zeroth and the first index, the element, plus input data 1. So for the input data 1, we are going to be indexing from the second till the end. So we just do the same thing for the other side. And no, we have to add a space character to it. A space character. So we have the plus over here. Plus again. Then don't forget you're going to be having the input data 1, the first two. So copy input data 1, then plus input data 2 to the end. 2 to the end. So this will be my output. Okay, then guess what? Print output. Okay, so we are good to go with this, I guess. Enter a string Lagos state. You can see st is going to GOS, then LA is coming to state. So you can see it works. It works. So um, on to the next one. Write a Python program to add ing at the end of a given string. So just ing. Don't forget you collect your input data first. Oh, let me copy the problem. So this is the problem over here, and input data. Okay, so that's my input data. To add ing at the end of a given string, all you want to do, you can just output equals to input data plus ing, and that is it. Now print output. Okay, so run the program once more. Let me say play. You can see playing. So that works as well. So I think I should leave the remaining ones to you guys. So write a Python script that take the input from the user, then displays the input back in lower and uppercase. I'll leave that to you. Write a Python function. We've not done function for now, so let's just be scripts. To get a string made of 4 copies of the last 2 characters of a specified string. So 4 copies of the last 2 characters of a specified string. So I'll leave these two to you guys. You can just, if you're having any issues with it, just speak up in the comment section and we'll sort it out. So that will be all for strings for now. I'll see you guys in the next video. Bye for now. Hello guys. So in this video we're going to be talking about integers. So about numbers rather. So in this video we're going to be talking about numbers, and it's the some few minutes back I explained the concept of the data types that we have available in Python. So I said we have the numeric data type and the non-numeric data type. So numbers are classified under the numeric data type basically, and I said we are going to be treating only 2 data types. We are going to be treating the integers and the floats. Now we also have the complex. If you want to work with complex numbers, but me, I've never had to use complex before. In fact, I run away from it. So I'm going to be. It's going to be a very short one actually. Let's go into it. So um, 7 numbers dot py. Okay, so numbers are, like I said, we have the integers, then the second one we have the floats, for the third one we have the complex, but we are not going to be working with the complex. We are just going to be working with the integers and the floats. Now quickly, integers are whole numbers and floats are decimal numbers. So a good example of an integer is maybe 6, no, 4, no, 4, 7, 25. 2 million and is this 2 million? Yes, 2 million and the likes. So a good example of a float is 3.142. So 2.5 and all that. Now integers, like I explained a few minutes back, I said integers are used for the type of data that can be counted, but floats are used for the kind of data that can only be measured. What kind of data can be counted? Number of things, number of people, how many people passed a particular place and all that. Then for float, if you can't count the metric, but you can measure the metric. Okay, for example, the your weight, your height, your body mass index, and all that. So let's just do one or two here. So let me say age equals to 25. Let me say student count equals to 15. So let me look for one more example. Let me say number, let me say index equals to 3. No, it should be index equals to 3. So it works. Let me say print type of age. If I should run this, you can see we have class int. If I type of index, if I should run this, you see I also have class integer. So these are integers basically. These are integers basically. So for float, let me give you examples of float. I love to use pi, which is 22/7, but I'll just say 3.142. Let me say height equals to say 6.25 feet. Wow, very tall. Let me say area equals to 154.0. Okay, so if I should look for the type of area, then I'm going to be having, you can see class floats. Then let me say pi. You can see it's also class float. So that is it basically. That is all we need to know about integers and floats for now. So I'll see you in the next video. Bye for now. Welcome back. So in this video we're going to be talking about booleans. Um, Sometimes in life, away from programming now, you might want to verify the authenticity of a statement without any form of ambiguity, no sitting on the fence. It might just be true or false. So in Python, we have this Boolean data type. It's a two-state data type that represents true or false, basically. So you have a statement or a condition, and you know that this condition, it will result to either true or false, no sitting on the fence. Let me show us how the Boolean data type works. So the py, close this. So the Boolean data type, we've done a bit of the Boolean operations when we were testing for equality. For example, I've done something like this before, sometime in this video. I said a equals to a to tell you that it is case this a is not the same thing as this a over here. So you can see I have false here. So but let me take this out. You can see, so for this, since this is a string and this is another string as well, both of them will result in the same thing, so it will give you true. So this is a good example of a Boolean operation. So this is a Boolean operator, and as you can see, it is returning either true or false. So let's get into it now. In mathematics, if you have say two numbers, the two possible you have three possible relationship between two numbers. It is either the numbers a is greater than b, numbers a is less than b. If both of them are false, then you know a is equal to b. So let's use that that scenario to explain what the way a boolean works. Now, if I have two numbers, say x equals to 3 and y equals to 5, so print x greater than, say, y. You can see it's giving me false. It's giving me false. Now, I'm going to be talking about operators sometime in this video, so you're going to be getting knowing how we come about this. This is a relational operator. You use it to look for the relationship between two values. So now you can see x is not greater than y, so it's returning false. Then we have x less than y. For x less than y, it's returning true, because if you take a good look at it, this is 3 over here and this is 5. So let's test for the third condition, equals to. Running it, you can see it's giving me false. So it's to tell you that x is not equal to y. What if I make this one 5? You can see it's giving me true. So obviously x is equal to y. So apart from just expression like this, there is this bool function that you can use to get the boolean value of a value. Don't forget, the boolean value of an expression is either true or false. You can also get the boolean value of a value, so which will be giving you true or false as well. So if the value that you want to look for the boolean value is not 0, it's not 0.00, it's not an empty list, an empty tuple, an empty list, and it is not an empty dictionary as well, and the value is not none, if the value is not false, all these values over here, let me comment this out. The value that you want to look for the boolean equivalent, if it is none of all these values over here, then you are going to be getting true. I will give you an expression. Let me say val equals to, let me say 8. So print bool val. Okay, so if I should run this, you can see it's giving me true. Let me change this to a list containing maybe Chris and Alex. If I should run this, you can see it's still giving me true because it is not an empty list. Now what if it were an empty list? Let's try. You see, I'm getting false over here. So if it were an empty dictionary, where my dictionary at? You see, I'm getting false because this is an empty dictionary. The boolean value of 0 is also 0. It's false rather. So you can see all these values that I have over here, all these values. If you want to look for the boolean value of any value and the value is not contained here, it's not a null value, then the value is going to be true. The boolean equivalent will be true. But if it is maybe, let me say Chris. Okay, I'm forgetting something here. Also, it must not be an empty string. Don't forget that it's the same thing as this. Or okay, so this is still the same thing as this, so please take notes. So if the value is Chris, for example, it's giving me true, but if it's an empty string, it's going to be giving me false. So that is all for boolean, all about booleans for now. I'll see you in the next video. Bye for now. You're welcome back to the course. So in this video I'm going to be I'm going to be taking us through all the major operators that we have in Python. So all these operators, they have their different uses, and operators are used to perform operations on variables and values. So variables, values, you manipulate or do your processing using operators basically. So getting back to it, we have different type of operators in Python, in programming generally actually. So The first set of operators that we are going to be looking into are the arithmetic operators. The arithmetic operators. So let me do some multi-line strings here. Okay. So these are the arithmetic operators that we have in Python. So you can see we have exponentiation, multiplication, division, floor division. We have the modulus. So this floor division can also be referred to as integer division. Then this can also be called modular division. Then we have addition and subtraction. So these are the arithmetic operators that we have in Python. So demonstrating them, let me say x equals to 5 and y equals to 3. So let me say output equals to x. Let me do the first one, y. So print the output. Okay. So if I should run this, you see what I have, 125, which is basically 5 raised to the power of 3. So that is 125. Now another, that is for exponentiation. For multiplication, you take one of these out, you run it again, you see I have 15, which is 5 times 3 basically. Then for the division, the normal division we have in mathematics, so you see you're having 1.6, which is correct, 5 divided by 3. Now we have floor division. Now floor division is going to be given, you're going to be using 2 slashes. If you should run this, you can see you have 1. Basically what is happening here is, if you want to do 5 divided by 3 the elementary school way, what you're going to be having is 1 remainder 2. No, 1 remainder 2. What does this mean? If you remove 5, if you try to divide 5 by 3, you're going to be getting 1. Then the decimal part, you're going to be having 2, that is not up to 3. So this is the whole number part. Then we have the remainder, the modulus rather. So this integer division is going to be taking this whole number part, it's going to be neglecting this one. But on the contrary, for modulus, which is the modular division, if you put modular division here, don't forget there's a print statement here that is going to be showing the output. So okay, so if I should run this, you see what I have 2. So that is how they work. So for the addition, plus, I should run this, you see I have 8. Then for subtraction, it works the same way in mathematics. So you can see I have 2. So these are the arithmetic operators that we have in Python. And another thing you should know is the precedence of these operators. So you can see that we have exponentiation on top, then we have multiplication, we have division. So what this implies is that, let me add another number here, z. Z equals to maybe 8. Now if I say let me say multiplied by z. Now according to mathematics, this operator over here, which is the multiplication operator that we have here, is higher in the level of precedence compared to the multiplication. So normally addition and subtraction, they have the same level of precedence. Multiplication and division also have the same level of precedence. Then this come under division. So that is the way they are arranged. So exponentiation is the top on the list. So if I have something like x, let me say 2. So normally Python is going to sort this one first, then it will sort this one after, then this is the one it's going to be sorting out the last. So let's try to solve it with our manually before we run the code. So what is x? X is 5. 5 raised to power 2 is what? 25. Now we are going to be having 25 here. So this is the next operator to tackle. So what is y? 3. 3 multiplied by z, which is 8, is 24. So we have 25 here, and then we have 24 here. So to tackle this subtraction operator, now we have 25 minus 24, which is going to be giving us 1. So let's run the code. You see we have 1 over here, which is it. So just note the level of precedence of all these operators. It is not complicated, trust me. It's something that if you are using it frequently, you get used to it. So that is all for arithmetic operators. We move on to the next set of operators that we have. We have the assignment operator. Now the assignment operator is just one. So the assignment operator is just equals to, and basically it's used to assign values, variables, values, or expressions to variables. Alt Z. Okay. So that is what you use the assignment operator for. For example, what is happening? What I'm doing for x now is I'm assigning a value to variable x. I'm assigning a value to variable y. What I'm doing here is that I'm assigning an expression. This expression needs to be evaluated. Anything that is the result of this expression will be assigned to output. That is how you assign an expression to output to a variable. What if it is just x that I'm assigning to output? Then it is just a variable I'm assigning to another variable. So any value contained will be transferred. So that is it basically. That is all about assignment operators. Now we also have augmented operators. Augmented operators. So these augmented operators sometimes are classified under arithmetic under the assignment operator. We have a lot of them, but I'm just going to be bringing up a few of them. So I'm going to be bring. You can see plus equals to. You can see minus equals to. Times equals to. Then you have a slash equals to. Now, so these augmented operators, you use them to. They are used in a special way. For example, if you say plus equals to, the way you will be using it is x plus equals to 3, and the meaning of this basically you are increasing the value of x by 3. So let me say print x. So I can take this one out for now. So if x equals to 5, let me take this one out, and I'm saying x plus equals to 4, this is going to be giving me 9. I'm increasing the value of x by 4. That is what is happening here. Then what if I make this one 6? It's going to be giving me 11 because I'm increasing the value of x by 11. And originally, this is still the same thing as equals to x plus. It's going to be giving me the same value exactly. You see 11. So both of them work the same way. What if I want to decrease the value of x by 5? By 6 is going to be giving me negative 1. It's going to be giving me negative 1, and this works. It's an integer data type. This is int, so please take notes. Then we have multiplication equals to. So normally this is going to be giving me 30 because x is 5, and if I multiply 5 by 6, I'm going to be getting 30, and I'm assigning 30 back to x. So if I should run this, guess what? I have 30. So for the divide equals to, let me use 8 here, then let me put 2 here, so we have whole numbers. So 8 divide equals to 2 should be giving me 4. To be giving me 4, you can see it's giving me 4.0 because I'm doing division here. So we have so many other augmented operators, but for now let's just go with this. So we have comparison or relational operators. They return Boolean values, and you use them to find the relationship between two values basically. So you use it to find the relationship between two values. You can see these are comparison or relational operators. We have the double equals to, like I've been doing since. You use it to test for equality. If it is not equals to, if it is greater than, less than, I've used some of these operators, greater than or equals to, then this. So let's just try it out. If x is 8 and y equals to maybe 10. Now let me say output equals to x to equals to y. So, or let me just print x equals to y directly, so I won't have to write this extra line of code. So if I should run this, you can see I'm having false here because x is not equal to y. What if I have 10 here? So you see I'm having true because x is equal to y. Now, another thing I can do to test for this one not equal to. So if I should run this, you can see I have false because um, x is 10, y is 10, x is not equal to y. Yes, 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 it's true exactly because um, obviously x not equal to y is false because both of them are equal. So I'm the one confusing myself. Okay, so you can see it's true, so it works just fine. So if I have maybe 7 here and I say greater than, I run this, you see I'm having true because x is 10 and y is 7, so the greater than amounts to true. What if I say less than? You see it's going to be giving me false because obviously x is not less than y. So what if I make y 17 and I run this code again? You see I'm having true because 17 is obviously greater than 10 is less than 17 rather. So now we have greater than or equals to, less than or equals to. If you take a good look at what we have over here, this is x 10, this is y 17. So if I have 10 and 10 and I say less than or equals to, it's going to be giving me true because one of the two of them is correct. If I also use greater than or equals to, it's still going to be giving me true because one of them is correct. So, but if I change this to 9, for example, you see I'm having false because both of them are wrong. It is not greater than and it is not equal to. So that is basically how comparison operators work. They return Boolean values and they come in handy when you want to write conditional statements, loops, and all that. So conditional statements in particular. So that is all about conditional operators. Then we have the logical operators. Logical operators are used to get truth values between two different values. So they return Boolean values as well. Use it to combine comparison statements. So okay, we have logical operators here. So we have the and, or, and not. These are all the logical operators that we have: and, or, and not. So if we have, say, let me say, um, statement 1 equal to false. So false is a value, and statement 2 now I'm going to be printing statement 1 and statement 2. Now according to logical operators, the rule, and a statement and another statement can only return true if both of them are true. If one of them is false or both of them are false, it's going to be returning false. You can see I'm having false here because both of them are false. If I should turn one of them to true, one thing is that the more you get to use these things, the better you are going to be. You comprehend them. So for now, just follow the flow, and we are going to be putting all these things to use in an exercise very soon. So you also have true here. Run. You can see I have true here because both statements are true. So to continue, if I should put or here, which is the second logical operator that we have, if I should run it, I'm having true because according to the rule, all you need for the or operator to return true is for one of the two statements to be true. If one of them is true and both of them are true, then obviously it's going to be returning true. So that is for or. Let me change one of them to false. You can see it's giving me true because one of them is true. And mind you, you don't necessarily have to assign an exact value to this one. You might assign an expression that is supposed to return Boolean value to statement 1. For example, 3 greater than 7, which is false. Then let me say um, 4 modulus 2 equals to 0. Now, if you take a good look at what I have over here, 3 greater than 7 is false. 4 modulus 2. This is how you test for even numbers, actually, numbers that can be divisible by 2. You look for the modulus of the number, modulus 2. If you divide the number by 2 and you're getting 0, then it's an even number. So if I should run this, one of them is true, so obviously I'm going to be getting true. So you don't necessarily have to assign the truth value directly. You might be getting this from an expression and also this from another expression. It doesn't really matter. So just make sure that this is returning true or false, or this is returning true or false. So, and if you have something like 0 here, 0 is going to be giving you false, obviously. Just like the bool, you can see what we have over here. It's not even. Let me try back. Okay, so let's just go with this for now. So that is all about the logical operators. Okay, the membership operators now. The membership operators are used to test for membership. For example, I can say name equals to Chris. So you can say, you can do something like um, C and name. You see, it's giving me true because C is one of the elements that make up the string name. So the string name is referencing. So this works. Then you have H as well. If you run this, you see I have true. But what if I bring in Z? You see I have false over here because Z is not contained in Chris. So what if I say not in? You see I have true. So because it is true that Z is not in name, then let me use capital C. It's giving me false because C is contained here. What if I use small c? You see, it's giving me true. So this works as well. So that is all about operators for now. I'll see us in the next lecture. Bye for now. Alright guys, you're welcome back. So in this video, we are going to be talking about conditional statements in Python. So Python has, even Python aside, in real life, at some point, you might have to make decision based on some certain conditions, based on some circumstances. You're supposed to. Life is not linear in any way. At some point, you might have to do some sort of control structure. That's what we call it in programming, control structures, by which you kind of give some path. Like if this happens, go. This should happen. If this happens, then this should happen. So that is what we are going to be talking about in this video. So talking about conditional statement. So let's see the conditional statement.py. Okay. So um well, we have three types of conditional statements. Okay, I won't say three types, but three ways to write a conditional statement in Python. You have the if statement. So the if statement is used to test for a single condition only. It's used to test for a single condition only. Then we have the if, then elif. So this if elif, you use it to test for a condition, and you use it to test for multiple conditions. In short, then we also have the if elif else. So the if elif else is after testing for the first condition and you have tested for other multiple conditions. If all the conditions have been exhausted, then the else will execute. Now, apart from these ones, we also have the if else. I guess we have four ways to write this statement then. So this if else is basically you testing for something, and You also, okay, if this condition is false, then do something else. I'm going to be illustrating everything for in this video. So we have the if statement, the single if used to test for just a single condition. If it doesn't work, nothing should happen. So for example, um, let me say the if statement. So no, 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 no. I have a typographic error here. So for the if statement, I can have something like let me say x equals to 20 and y equals to 25. I can have something like, if the way you write an if statement, if x is greater than y, then print, let me say x is greater than y. Okay, so if I should save this and I run my code, you can see nothing is happening here because obviously x is not greater than y. So you can see the way the if statement works. You test for one thing. If that thing is wrong, then just do nothing, just walk away. So what if I put a less than here, which is true? So x is lesser than y. So if I should save this and I run my code, you can see x is lesser than y. It is showing here because don't forget the if statement, the single if. You try to test for something. If that thing is true, you do this. If it is false, we are not testing for if it is false at all. So just look through if it works. If it is true, then do this. So for the if else, now I'll still use this example as well for the if else. So you can see what I have here. If x is less than y, then you say else. Print x is not less than y. Okay, so now if I have something like 25 25 here and I run this code, you can see what I have. X is not less than y because as you can see, x is 25 and also y is 25. So you can see x less than y, x is lesser than y. This is going to be false, so this will not be executed. This condition over here is going to be false, so this will not be executed. It comes directly to this one to execute this one because this is false. And don't forget, according to what I said, the if else is used to test for a condition, and if the condition is not true, then the else gives it something else to do. Unlike the if statement where you test for only one thing, if the condition is true, it will execute it. If it is not true, it will just walk away. So that is the if and the else for you. X less than y. Let me make this one 30. If I should run this again, you can see x is lesser than y. So if I should say equal to, and I run this, x is equal to y. X is equal to y, then x is not equal to y. Okay, so if I should run this code, you can see x is not equal to y. That is what I'm having here because obviously x is 25 and y is 30, so x is not equal to y. But if I have 30 30 here and I run this, you can see x is equal to y. So basically you can see how both of them are working hand in hand. So for the if elif, let me take this one out. For the if elif, let me say in mathematics, basically, if you have two numbers, the possible relationship between the two numbers is if, for example, x and y, x is either greater than y, x is either greater than y, lesser than y, or equal to y. Those are the three possible conditions you have for a number. So let me use it to explain this if elif. So let me say if x is greater than y, if x is greater than y, then print x is greater than y. So you can come and add your another condition, elif x equal to y, print x is equal to y. Elif x less than y, print x is less than y. Okay, so you can see what I have over here now. X is greater than y. Now if I should run this code, you can see I'm having x is equal to y, because if you can see here now, x is 30, y is 30 as well. So if I test for this first condition over here, is x greater than y? Obviously not. So this is already false. It will not be executing this. It will go to the next condition. What is the next condition? Is x equal to y? Print x is equal to y. Then it breaks out of all these conditions. Then let me say print finish. Now one thing you should know about the conditional statements in Python uses indentation to delimit code. This is what I mean. This is the header of this block, this is the body of the block. So to show that this body over here is under this header, you need to put a tab over here, just a tab spacing, like just this tab spacing over here now on your laptop, just the tab spacing to show that this is under this. So please take note, take note. So okay, let me make this one 25 to give clarity. So as you can see, x is 25 and this is 30, so obviously x is less than y. So and you can see x is less than y. Then after executing the whole of this one, it comes to say finished. Let me do 25 25. If I should run this, as you can see over here now, x is equal to y, because if you look at this now, it will come and test for this condition first. Testing for this condition, this is not going to be executed because this condition is wrong. Then it will go to the next line to test for the condition, and as you can see, this is also this is correct rather. So after executing this one, this is a complete if statement over here. So since this is correct, it will break out of the whole of this to jump to this particular line over here, to jump to line 19. So that is how the if elif works. One thing about programming is the more you do these things, the more you get used to them, and the more it becomes a part of you. So even if you don't comprehend everything now, just follow along, and after solving some problems with this if statement, you know what to use when you get to whatever use case you need them for. So the final one, the if, the elif, and the else. Like I said at the beginning of this lecture, I said if it's going to be, you are going to be supplying a condition to if, then you're going to be supplying multiple conditions to the elif. You write an elif block for each condition. Then for the else, if all the conditions are exhausted and you still can't find one that seems to be true, then you're going to be having the statement in the else executed. For example, let me say okay, x, let me say x equals to, if x percentage 2 equals to 0, you can say print x is even. So elif x percentage 2, no 3 equals to 0, print x is a multiple of 3, elif x percentage 4 equals to 0, print x is a multiple of 4. Then after this, else print x is neither a multiple of 2, 3 or 4. Okay, so we have this completed. Now you can see what I have over here. I'm trying to test if x is a multiple of 3. Okay, if x is not a multiple of 3, then if x is a multiple of 2, if x is not a multiple of 2, then come and check if it's a multiple of 3, then you check if it's a multiple of 4. Then if it's not a multiple of 2, 3 or 4, just come here to tell me that x is neither a multiple of 2, 3 or 4. Now x is 25 over here, and obviously x is not even, so it's not a multiple of 2, and x is not a multiple of 3, it is also not a multiple of 4. So normally, if by explanation everything goes as planned, then it is going to be executing this else statement over here, because x is neither a multiple of 2, 3 or 4. So let me run this. You can see x is neither a multiple of 2, 3 or 4. Let me use 24 here. If I use 24, guess what it's going to be giving me? It's going to be breaking the whole if statement from this point, even though x is a multiple of 4, because it's going to be executing this first statement. Then after executing this one, it will break out of the whole if statement, then jump to line 21. Let's run it. So you can see x is even. X is even. So basically that is how it works. Now let me look for um, if I say 27 for example, and I run this, you can see x is a multiple of 3. It will just come execute one, then break out of the whole loop to come to line 21. So basically that is how you go about the if else, the elif, and the if elif else. So another thing I want to show us is that you can combine multiple conditions in an if statement. It works. Multiple conditions within your logical operators. And don't forget, I said your logical operators in the logical operators video. I said the logical operators we have in Python. We have and, we have or, and we have not. I think this should be small. We have and or not. So you can combine multiple statements together. For example, let me say x is 24. So I can do something like if x percentage 2. Basically what I'm doing here is if you divide x by 2 and the remainder is 0, and if you divide x by 4 and what you're having is also 0, just to make it neat, I'll put this in a bracket. I'll also put this in a bracket. So print x is a multiple of 2 and 4. So let me run this statement. You can see x is a multiple of 2 and 4, then you have finished. You can see I'm combining two different statements over here. And don't forget, according to your logical operators, for the and, both this and this needs to return true. So this have to be true and this have to be true for the whole statement to be true. So if for example I'm using 26 here, 26 will be true for this, but 26 will not be true for this. So I don't expect anything here to execute. You can see it's just giving me finished, and finished is just line 15. So because this is returning false, only this is returning true, then you can see x is a multiple of 2 and 4. So that is how you combine multiple statements to use in your Python conditionals. You can also use the or here. So if I should run this, you can see x is a multiple of 2 and 4. Okay, this should be or. This is a logical error. So this should be or of 2 or 4, because obviously 26 he goes for this, but it doesn't go for this. So it should be 2 or 4. So that is all about you combining um, logical operators, combining your if, conditional statement with logical operators for your if statement. So your conditions rather. So lastly, one thing is that in Python, if you want to declare a block of statement, you cannot declare an empty block. For example, I cannot do something like this, just like this, and I'll run it. It's going to be giving me errors because it is expecting me to put something here. So if for one reason or the other you want to declare an empty block of conditional statement and you don't want to put anything at the body, just temporarily you can use the pass. You can use the pass. If I run this, it is not going to be giving me error. It's not going to be giving me error. So that is what you use the pass statement for. So it comes in handy sometimes, but you can always be avoided since you won't have to write the extra line of code. So that is all about conditional statements in Python. So I'm going to be giving us some work to do. So just let me comment this one out. Oh, okay. So these are what you have to do. Write a Python program to check if a number is even or odd. Then let us also write a Python program to check if a number is negative, positive, or zero. Okay. So then you write a Python program to check if a number is a multiple of 3 and a multiple of 5 or both. So you check if it's a multiple of 3, check if it's a multiple of 5, or you check if it's a multiple of 3 and 5. So just a hint, you can just check if it's a multiple of 15 for both. So write a Python to find the roots of a quadratic equation. I didn't know I had this. I would want to shield you from this one for now. So let me just take it out. I don't want something that will blow your mind. So write a Python program to accept the cost price, the selling price, and quantity sold. Tell the user if the transaction yielded a profit or a loss. Then you show the user the amount of profit or loss. So you write a Python program that will accept the scores of two teams in a debate, then show the user who won or if it's a tie. So the last one, you write a Python program that will accept a student's score, then show the student's grade using this reference below. Now, if the score entered is between 70 and 100, then the student is having the grade A, then and so on and so forth. So this will be all about Python conditional statements. Then I'll see you in the next tutorial where I'm going to be giving the solution to the exercises. So thank you and bye for now. All right, guys, you're welcome back. So let's get to it. So you write a Python program to check if a number is even or odd. Very simple. An even number is a number that if you divide it by 2, you're going to be getting 0. You're going to be getting the remainder is going to be 0. So that is going to be what we are testing for. So you can say x equals to, you can say input, or let me say input, enter a number, let me say t, then if x percentage 2 equals to 0, then print, you can even say f, then to format the string x is an even number. I believe we all know what I did here. I believe we all know what I did here. So I'm using formatted string here. So anything the user gives me as that is stored in X is what we'll be showing here. If you take a good look at all the exercises we did, it is just X is greater than or X is less than. But for this solution, it will give me the actual value of X. So it makes the program way more better. So then else, let me just say is an odd number. Is an odd number. Okay, so run this program, enter a number 7. You can see 7 is an odd number. If I should run it again, then 10 is an even number. So we move on to the next one. Write a Python program to check if a number is negative, positive, or 0. So let me comment the whole of this one out. Then, so a Python program to check if a number is positive, negative, or 0. Let me steal this one as usual. Then, so x equals to int input, enter a no, I'm making a mistake here. Number. Okay, a number. Oh, NAMBR. Okay. So to check if a number is negative, the number have to be less than 0. So if x is less than 0, print. Let me also use a formatted string again. No. I don't know why this thing is blocking. Okay. Is less than 0. Okay. It's negative rather. This should be it's negative. Okay, it's negative. So I'm going to be having x here. Then if x is less than 0, elif x equal to 0, print. Let me just copy the whole of this. Oh god, I'm feeling lazy to type this out. So f is equal to 0 is 0. Okay. Then else. I might decide to use elif here or to use else. Both of them will work. So let me go with else first. Print open and close is positive. So I'm having x here. Okay. Now what is happening here exactly? X equals to input enter a number. So the user will be giving me a number, then I'll convert the number to an integer, I'll store it in x, then I'll say if x is less than 0, then print f, then formatting the string x is less than, it's negative. What am I doing? Okay, it's negative. Then elif if x elif x equals to 0. This is testing if x is actually 0. Then print f is 0, x is 0, else print x is positive. So let me run this. If I should run this, I'm having enter a number, let me say -4. You can see -4 is negative. So if I should run this code again, let me say 0, you can see it's 0. So if I have 7 for example, you can see 7 is positive, so that works. Then if I say elif x greater than 0, it will also work as well, but I think the proper thing to use here is else. So if I should run this and I have maybe 8, you can see 8 is positive, it works as well. So I think we are good to go with that. Now we move on to the next one. Write a Python program to accept cost price, selling price, the quantity sold, and it will tell the user if the transaction yielded a profit or a loss. Let me copy this out. Okay. So now if you carry out a transaction and you have a cost price, you have a selling price, and you have the quantity sold, for you to check if you have a profit or a loss, the first thing you want to do is to check the difference between the cost price and the selling price. Now if your cost price is more than the selling price, you have a loss. If both of them are equal, you have neither a profit nor a loss. But if your cost price is less than your selling price, then obviously you have made profit. So that is the first thing we're going to be testing for. Then after that, we're going to be checking the quantity. We check the difference, then we know how to work our way up from there. So let's say um, I'm going to be working with float for this one. Let me say CP equals to, so enter cost price. Enter cost price. I want this one to be a float for now. No, 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 no. What am I doing? So this will be cost price. Then this will be selling price. Then um, selling price. Then we're going to be having the quantity sold. Copy. Let me say QTY. So let this one be an integer. Integer. So hopefully this product can be counted. So enter the quantity units sold. Okay. So now the first thing we want to do is to check for a profit or a loss. So don't forget, like I said, if you check if your cost price is more than the selling price. So if your CP is greater than your SP, then print um, um, you made a loss. Then you say elif CP equals to SP, which is the selling price, print no profits nor losses. Then you can say else, because don't forget, like I said in mathematics, if you have two numbers, the relationship between the two numbers is, for example, a and b, a can either be greater than b, equal to b, or less than b. So since I've tested for cost price greater than selling price, and as I've also tested for equality, then obviously the only condition left is less than, to check if it is lesser than. So that is what this else is going to be testing for. It's going to be working on. It's going to be representing, obviously. So it is not testing for anything, but since this and this are returning false, so obviously um, this is going to be giving me profits. You made profits. Okay, you made profits. So now I think the first part is done. Now let's calculate the profit or the losses that the trader or the user have incurred. So total CP equal to cost price multiplied by QTY. So this is the total cost price. Then total selling price equal to SP multiplied by QTY. Okay. So the next thing you want to do now is to check. I think we can. Let me just steal this. So if total CP is greater than total SP, you can say difference equals to total CP minus total SP. Another way to do this thing is to actually calculate this one in terms of profits. So profits equal to, let this one be total SP, then total CP. So what is happening over here is that I've gotten the total cost price, then I've gotten the total selling price as well. Now I want to calculate my profit, which is supposed to be the total selling price minus the total cost price. Now I have to check if my profit is greater than zero, meaning that if the difference between this and this is positive, then you made a profit of, then let me just profit. But don't forget, for that to be valid, you need to put your F here to show that it's a formatted string. So you've um, okay. So you've made a profit of profit. So if profit equal to zero, if the profit is equal to zero, then no profits nor losses. Else, meaning that the profit is less than zero. So let me say you've made a loss of profits. So this and then this, you made a loss of, don't forget your F here, to show that it's a formatted string. But one thing I want to do, let me run this code for the first time before I do it, so you see the actual reason I'm doing it. So running this code, the cost price is going to be what? Okay, let me say I bought something at the rate of $60, then I'm selling for $75. How many units did I sell? Let me say 35. You can see it is telling me that I made profit first. That is the whole essence of this calculation over here. Then you've made a promise, a profit of $525.0, then 0 cents. I didn't put the units there, so let me just put the units there. Okay, okay, so that's the units. Um, okay, the units sold. Let me enlarge this a bit. Okay, let me run this code again. Let me say the cost price is maybe 70 and the selling price is also 70, and I sold, let me say 10 units. So no profits or losses. So okay, it's just this printing and this printing again. So now let's calculate one that should yield a loss. Let me say the cost price is 60 and the selling price is maybe 55. How many units? Let me say 30. So it's telling me that I've made a loss of negative $150, then 0 cents. But I'm not comfortable with the fact that it is giving me this negative over here. I already know it's a loss. I'm not supposed to see a negative here. So you can actually do something like this. ABS. This ABS function in Python returns the absolute value of the number. So normally instead of giving me 150, it's going to be giving me just a negative 150. It's going to be giving me just 150. So 60, 55, 30. Let me run this code again. So let me say 60, 55, then 30. You see, you have made a loss of $150, then 0 cents. So this works as well. We can move on to the next one. Okay, so next one. Okay, let me leave this one. I'll be leaving this one. So you work on you work on that one. Then for this one, I'm going to be taking this one now. So this will be the last one. Okay, I think this one is a bit voluminous. Okay, so write a Python program that will accept a student's score, then show the student's grade. So based on all the specifications here. So the first thing we want to do is to accept the student's score, which I presume will be an integer, but just to be safe, let us look for a float. Okay, God, I'm just feeling lazy to type. So let me say score. So let's assume the score is a float. As per, you can have decimal, a decimal number. So enter, let me say, the student score. Okay, enter the student score. So now we start testing for the grade. Now, one thing you can do here is to say grade equals to, just initialize grade to be an empty string. Then the next thing you want to do is to do something like if score is greater than 70 and score is less than 100. What am I doing? Okay, this is a PHP syntax. I'm sorry about that. And okay, so you can say grade equal A. Actually, there are so many ways to present your if statement for this particular problem, but I'm looking for something that gives you directly this particular condition over here. So I just want to bring it down to our level. There are better ways to actually write this condition, but for now, let's just stick to this. So elif score greater, okay, this should be greater than or equal to, okay, score is greater than or equal to 60 and score is less than 70, then grade is going to be B. It's going to be B. So to keep the lecture short, I'm going to be copying this and I'm going to be pasting it 3 more times on, I think I have made a mistake somewhere. Okay, so copy, okay, so A, B, then if we have 5, then this will be 6, this will be C, then we have 45 to 50, we have D, then 40 to 45. I'm going to be having E, then else grade equal to F. Now to show the final output, you can print F formatted string, the grade, no, this should be capital letter, the grade of the score, bring in your curly braces, is, bring in another curly braces. So don't forget, this is the score over here, the score is this, and then you should have your grade here. Okay, so boom, I think this settles it. So with the score equal to float input, enter the student score. So I'm going to be accepting the student score first. Then after accepting the score, I'm going to be converting the score to a float. Then I'll be saving it using this variable. Then I'm initializing a variable grade to be an empty string. Then I now said, okay, if score is greater than or equal to 70 and the score is less than 100, meaning that it reads from 70 to 99. So here in Unilag, no student gets 100. So okay, I've heard of one before, but that's by the way. Now, if your score is within the boundaries of 70 and 100, your grade is going to be an A. If it is within 60 and 69, inclusive of both ends, you're going to be B. Then you can see exactly what we have in the condition over here is what I've represented using all this. Now, after this one over here, after testing for the score greater than 70, greater than 70, less than 100, greater than 60, less than 70. Now, if the program should run up to this point and all of them are returning false, 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 then obviously the person is getting an F, because come on, your score is not below, your grade cannot be found at A, cannot be found at B, cannot be found at C, up to E. Obviously, you got an F. So that is it basically. If I should run this, let me say 65, you can see the grade of the score 65 is B, which is exactly what we want. So if I should run this again, if let me say the student score is maybe 37, God forbid. So 37 is F. You can see it works fine. So that is it basically. So well, I left this to you already, so you go and deal with it. So thank you very much. I'll see you in the next video. Bye for now. Hello guys. Welcome back. So we'll be talking about lists. What we have been doing so far, it's you assigning a value to a variable. But what if you want to work with a collection of values, like not just one value? You want to work with multiple values at the same time. That is where the collections come in. So within the next 4 videos, we're going to be talking about Python collections. So we're going to be talking about the lists, the tuples, the set, and the dictionary as well. So in this video, we're going to be starting with the list. So what is the list? Now, the list is an ordered kind of data type. It is changeable and it allows duplicates. So let's create a new Python file. So this should be 11, it should be list.py. Okay. So now let me say friends. I want to give an example of a list. So you can see this kind of bracket. This is the kind of bracket with which you create a list. So I think this is called a block bracket also. So just this is the bracket with which you create a list. If you want to create a tuple, you use the braces. If you want to create a set, you use this. If you also want to create a dictionary, this is what you're going to be using. But there are so many differences between the set and the dictionaries, and both of them will be explained in as we go on. So a dictionary, a list now. Let me say list of friends I have. I know someone whose name is Samuel, and I have a sheriff somewhere. Then I have someone whose name is Currency. Then I have an Alexander somewhere. Okay, so okay. So these are the 4 friends I have. So you can see I've created a list of friends. I have Samuel, I have Sheriff. No, 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 this should be double R. Oh, this should be single R and double F. Yes. So Samuel, Sheriff, um, Currency, and Alexander. So you can see the list I just created. Now this is an example of a Python list. This is what a list would look like. And this list is ordered, meaning that this is taking the 0th index, this is taking the first index, just like the same way we index strings. The 0th index, the first, the second, and the third index, even though the amount of elements in the list is actually 4. So but indexing is starting from 0, so the last element, the index of the last element will be 4 minus 1, which is basically 3. Now if you want to look for the number of elements in a list, there's this len function we used when we wanted to check the length of a string. It works for lists as well, for all Python collections actually. So let me say um, when we used this function together with our Python strings, this is the way we used it. We said we can do something like, let me say name equals to Alexander. So you come to look for length of name, and the len function will tell you the number of characters that you have in Alexander. So No, no, no. I'm supposed to print it out. I'm supposed to print it. Okay. So run this function. You can see I'm having 9 here because the number of characters I have over here is 9. But that is for strings. But if I want to check the number of elements I have in friends, I'll just copy and paste it here. If I should run it, you see I'm having 4, which is actually the number of friends I have. 1, 2, 3, 4. I have more than 4 friends, by the way. But let's just use this ones for now. So it allows duplicates. For example, I might decide to put another Samuel here. So if I should run this, it works fine. It allows duplicates and it is changeable, it is ordered. So changeable means that, for example, I might decide that, okay, this sheriff, I don't want to see sheriff anymore in my life. So guess what happens? I might decide to do something like friends dot pop, and what is the index of sheriff? 1. So let me first of all print friends, then I'll check the length of friends. So if I should run this, you can see I have Samuel, I have currency, I have Alex, and I have Samuel again, but sheriff is no longer there because I've popped him. So that's it. You can change it. It allows duplicate values and it is ordered as well. So if you want to check the type of, if you want to use the type function to confirm the data type of a list, all you have to do is to print the type of friends, and it's going to be giving you the int type, the list type. This is the list type you're going to be having here. So to access the list items, as in this is the list itself, then these are the items contained in the list. So for you to access the list items, you have to access them by indexing them. For example, like I said, let me comment this out. So this is the zeroth index, index 0. So don't forget, this is a Python comment, so it has no effect. Okay, so this will be index 1, this will be index 2, this will be index 3, and this will also be index 4. So if I want to get Samuel, for example, I have to use the index 4 to get this Samuel over here. So I can say print, let me say person equal friend, then I'll index 4. So what do I have? Print person. Okay, if I should run this, you see I'm having Samuel over here because as you can see, this is the index 4 for Samuel. So if I want to get sheriff, for example, I'm going to be using the index 1. If I should run this, you see I'm having sheriff here. Works all fine and good. So that is how you access list items. Negative indexing also works here, just like we have in strings. For example, if you want to index Samuel, Samuel being the last element, you just have to use -1 to index it. If I should run this, you see I have Samuel over here. So it works fine and good. But if you want to index currency using negative indexing, this will be -1, -2, -3. So -3, -3 yields what? Currency. Okay. So that is all about indexing a list. Now another thing you might want to do while working with a list is list slicing, or to get a range of items in a list. Let me add more friends to this list. Let me add more friends to this list. Let me see. I know there's a Bulu somewhere. Then I have 2 Michaels actually. I have a Chinedu. I have a Samuel. Actually, I have so many Samuels. So then, who can I think of again? Who can I think of? Um, I have an Amina somewhere. Okay, this should be fine. This should be fine. So as you can see, I have so many friends now, a lot of them. This -3 is going to be giving me Chinedu if I should run it again. So you can see I'm having Chinedu. Now, if I want to get a range of items, like a sub list of this, the whole of this list now, and I want to get, for example, from Samuel to Samuel. Don't forget, this is the index 0 and this is the index 4. But the way slicing works in Python is the same way, the way it works in list is the same way it works in strings. So don't forget, you're going to be having your starting point and your ending point, but you're going to be adding one to show that you want to stop at that particular ending point. This is what I mean. If I have something like between 0 and 4, if I should say 4, and I print this. So you can see I have Samuel, Sheriff, Currency, and Alexander. It is not including this Samuel over here because the way it works in Python, it excludes this last number over here, the item at the last one. So what you want to do is to make this one 5. So if I should run this, you can see I'm having from Samuel to Samuel. So Samuel at the 0th index and Samuel at the 4th index. So that is it basically. That is it basically. Another thing you might want to do, okay, since I'm going to be starting at the beginning over here, so I don't have to put this one over here. It will work just fine. So automatically it is going to be taking it that I want to start from 0, so there's no point me putting it there. So as well, if I want to start from maybe somewhere in the middle all the way to the end, for example, if I want to start from Bolu is at the index, or let me start from Michael. Michael is at the index 6. Then I can just remove this and run the code, and guess what, I have Michael Chinedu. I mean, I just from the 6th index down all the way down. So that is how it works. That's how it works. But if I want to stop at some point, I can just put the stopping point here. You see, I have Michael and Chinedu. Works fine. So negative indexing also works with the slicing too. For example, I might want maybe from Samuel to Chinedu. For me to index using negative indexing, this will be -1, -2, -3, -4, -5, -6. So this will be -6 all the way to Chinedu. Will be -1, -2, -3. But I'm going to be stopping at -2, so Chinedu will be included. So this will be -2 over here. Run it, and boom, Chinedu is included, as you can see over here. So this works. Then if you want to change a list item, for example, God, I love Sheriff so much, but he's the one I'll be changing, obviously. So if I want to change Sheriff, for example, um, what I want to do is I can say friends, then indexing what? Sheriff's index is 1. So equal to, unfortunately, his name is Eniola as well. But I have another person whose name is Eniola. So I can take this one out and just print friends. So what I want to do basically here is to change this sheriff to this Eniola here. So if I should print friends, you can see what I have. It is no longer Samuel Sheriff Currency. It is now Samuel Eniola then Currency. So you can see what I have over here now. You can see what I have. Me just changing, like I said, it is mutable, it is changeable. That is one thing about the list. The list is very flexible. You can, majority of what you're going to be doing with Python collections most likely would be with using the Python lists. So let me say, okay, after the fight I have with Sheriff now, we've settled, and I want to bring Sheriff back to the list. So I might just want to insert Sheriff back into the list. Don't forget that at this particular point now, don't forget that at this particular point, Sheriff is no longer in this list. Don't forget, at this particular point, Sheriff is no longer in the list. But for one funny reason, I want to bring Sheriff back. I've forgotten Sheriff. So what I want to do is to say friends dot insert. This is one way to insert an item into a list. So I will add the index I want sheriff. You can see what VS Code is giving me over here. So I will look for the index where I want sheriff to be. If I want sheriff to be at index 4, I can just say for comma then the item I want, which is sheriff. No, it should be 1R. Okay. So if I should print friends again now, you see what I'll be having here. This is Samuel Eniola currency. Don't forget that you won't be having Samuel Sheriff because I've replaced Sheriff with Eniola at this point. So Samuel Eniola currency, Alexander, then Sheriff at the fourth index. Don't forget this is the zeroth index. This is the first index, the second, the third, and the fourth index, which is where I inserted Sheriff. So another way to insert Sheriff to this particular list is to use the append method. So you can say friends dot append. So I guess I'll be adding sheriff twice to my list. So as you can see here, I have sheriff over here and I also have sheriff at the end. So I can allow duplicate elements. So let me just leave the two sheriffs there. In case I fight with one, I can just pop one and I have one sheriff to myself. So if you want to remove an item from the list, so at this point, I have two sheriffs. Um, okay, then let me use sheriff. I've used sheriffs a lot. Let me use Alexander. So I have Alexander over here, and I want to remove Alexander. Apart from popping Alexander, I can just use the remove method of the list. For example, friends dot remove Alexander. Okay, so run this, and as you can see, I don't have Alexander here anymore. It should be currency Alexander then Samuel. You can see currency sheriff Samuel. I don't have Alexander anymore. You can see what I have over here. So this is one other way to remove items from a list. So if you want to clear all the elements in a list, you want to clear all the elements in a list, you can see that at this point now, this is the list I have at this particular point, but this thing is looking messy already. So let me take this one out. If I should run this, you can see I have all my friends back, the original friends I have. Okay. So if I want to clear the list, friends dot clear, you might be working on a program and at some point you have to clear your list. You can see I don't have any item in the list anymore, even though I have a list of friends initially, but for one funny reason I might have to clear my list. So I'll just clear the list. Then if you want to loop through a list, you want to traverse a list. That is the language to use. You want to traverse a list. Traversing a list means, for one reason, you might want to visit every element in the list. For you to visit all the elements in the list, you're going to be using a for loop. Now, um, a couple of videos from now, we are going to be talking about the for loop. So, but for now, just take this. You're going to be saying for item in your list, but in this case, my list is friends. So no, so can just print. No. Actually, it should be for person and friends. Depending on the list you're using, you might want to use item as well. You using item or person or X or Y at this point. It won't mean the program won't run, but I'm just trying to be realistic with my variable names. So print person. Okay, so if I should, let me take this one out. I'm trying to look through my list. So you can see what I have over here. Samuel, Sheriff, currency. I've visited all the elements in my list. So I might just also do something like might do something like this. So um, then I can say good morning person. So if I should run this list, you can see good morning Samuel, good morning, Sheriff, good morning, Currency, good morning, Alexander, and all that. So, within the body of this loop, for the first iteration, person is going to be taking whoever is at the first index. For the second iteration, is going to be taking the person at the second index, which is basically this one over here. So that is how it's going. The iteration will continue from the zero to the last, the element at the last index. So this is how you loop through a list. So now, if you want to sort a list, if you want to sort a list, let me take this one out. Let me use numbers to explain this one. So if you want to sort a list, say you have 3 1 7 4 8 0. Okay. If you have this list and you want to say you want to sort the list, all you have to do is to print num dot sort. So I think, oh sorry, um that should be a mistake on my part. Okay, so this should be it. Okay, you can see what I have over here now. The list is sorted. It's sorted. 0 1 3 4 7 8. Now, if you want to sort your friends, it's going to be arranging everything based on the alphabetically. So, for example, friends dot sort. Then after sorting the friends, if I should come here to print friends and I run this, guess what I'm going to be having? Alexander, Amina, Bull. You can see everything is sorted alphabetically. So, but if you want to sort in reverse, you can just say reverse equals true. So if I should run this, guess what? I'm having Sheriff first. So then Samuel, Samuel, Samuel. Oh, I have three Samuels here. That's true. So Michael, Currency, Bolu, and all that. So that is how you sort a list in reverse. Now, lastly, let me look through this list. So at least, um, if I want to print out the square of all the elements in this list, for example, all I have to do is to say for, I can just do something like for number num, for every number in num in the lists, you can see this list over here. So I can just print that number raised to the power of 2 to get the square of that number. So just print it. Or I can do something like to format the string. So I believe you know what I'm doing. The square of this. So I'll have number here. Okay, so if I should run this, you can see the square of 3 is 9, the square of 1 is 7, and all blah blah blah. Okay, I can also do num.sort to make it look better. Run this, and you can see the square of 0 is 1, is 0, the square of 1 is 1, the square of 3 is 9, and all that. So that is how you traverse your list of numbers. Another thing you should know is that a Python list can contain elements of different data type. For example, in a Python list, let me say my lists, I can be having maybe true, which is a boolean, then 7, which is a number, then I might have sheriff, a very good friend, then I might be having maybe 3.142 in the same list. All works just fine. So I might be having what other data type? Let me say D. So you can see I'm having all the examples have been given for lists so far. I've been using items with the same data type. For example, this is all strings. And for the list I used to demonstrate this, they are all numbers, but you can see I'm having different data types here. I'm having different data types here, and it works just fine. It works just fine. So this is allowed as well. So another thing you might want to know about a list is you might want to check if the an element is contained in the list. For example, this is my list of friends. This is my list of friends. I want to check, is Bolu my friend? How would you check? You can do something like Bolu. Um, okay, I'm using capital B because it is case sensitive. Bolu in friends. So this is a membership operator. We used to test for membership. So Bolu in friends is going to be returning a boolean true or false. So let me print whatever this is giving me. You see, it is true. If I used the small letter here, the small letter here is going to be giving me false because this is not equal to this. So let me check if Grace is my friend. Obviously not, because Grace is not part of this list over here. But what if I add Grace to the list? Use it to test for membership. True, you can see. So then another thing I might want to show you before we go into the exercises is we have what we call nested lists. A nested list is a list inside another list. So you can also have nested tuples, you can have nested dictionaries, you can also have a list inside a dictionary inside a list and all that. It depends on the complexity of the data you want to manage. For example, um, I might have something like this. I might have let me use numbers to explain this. No. Okay, so I might have something like 2, 4, 6, 8. Then another list. Let me say 1, 3, 5, 7. Then I might have another list. Maybe 1, 2, 3, 4, 5, 6, 7, and 8. So you can see the list of numbers I have. I have this, and I also have this. So, and I have this as well. So this is still a list over here, only that it is a nested list. So if I print my list of numbers and I run the code, you can see what I have over here. This is the outer list. Then you can see the element. The first element is a list. The second one is also a list. The third one is a list as well. So, well, that will be all for lists for now. So, guess what? We got work to do. They're fairly simple exercises, but we are going to be working on them. So, write a Python program to sum all the items in a list. Let's say all the items are numbers. So, this one too, we assume all the items are numbers. So, the smallest number from a list, let me say the smallest and the biggest, largest number from a list. So, write a Python program to check if a list is empty or not. Then write a Python program to print a specified list after removing the 0th, the 4th, and the 5th elements. Don't forget, you are removing the 0th, the 4th, and the 5th elements. So write a Python program to append the list to the second list. Like you have two lists together, and now we want to join the two of them. So this is it's the exercises are not complicated. So just work on them. Then you come for the next part of the lecture where we're going to be solving the problems. So thank you very much. I'll see you in the next one. Alright guys, welcome back. Let's set the ball rolling. So we write a program to sum all the items in a list. So you're going to be looping through all the items you have in a list, but there's a way you solve this kind of problem. Let's say my list of numbers. Let me say okay, nums equal, sorry, I have a list. Let me say 2, 3, 7, 23 7, no, I've used 7 5. Okay, so this is my list of numbers. So I want to sum all the items in this list. What would I do? I'm going to be using a for loop, and what will the for loop be doing for me? I'm going to be doing something like first, the first thing to do is to create a count variable. No, 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 I won't call it a count variable. A variable that is going to be collecting the sum. Like you will traverse the whole list for all the items in the list. You are going to be adding it to the value of sum. You are going to be increasing the value of sum by the value of the current item. This is what I mean. So you say sum equal to 0. So you now traverse the list for, let me say, x in nums. What is going to be happening? You will say sum plus equal to x, or to make it more beginner friendly, sum plus x. Sometime at the beginning part of the course, I explained what this is. So you are basically increasing the value of sum by x. So, but I don't want to do this. I don't want to do this. So it will be plus equal to. Both of them mean the same thing. So what will be happening here is that, don't forget, this for loop is going to be traversing the whole of this list. Now, for this first item over here, it's going to be increasing the value of sum by 2 for the first iteration. Now, the value of sum after the first iteration is successfully is going to be 2. So it will come for the second iteration on the second element. Don't forget, sum is 2. So after this one counts, the value of sum is going to be 2 plus 3, which is 5. So at the third iteration, it's going to be 5 plus 7, which is 12. Then coming to this 10, that will be 12 plus 10, which is going to be 22. So coming to 23, that will be 22 plus 23, that should be 45. Then 45 plus 5 is going to be 50. So if all goes well and good, if I should print sum and I run my code, what am I having? 50, you see. So it works fine. That is how you sum all the items in a list. So write a program to multiply all the items in a list. So this, no, what am I doing? Write a program to multiply all the items in a list. Okay, so the next thing you want to do is to, let me use this list as well. Now this is going to be a very large number. So now the same thing we did for sum is the same thing we are going to be doing for here, so for this one too. Total equal to maybe 1. Now the reason why I'm going to be using 1 here is that in mathematics there is this thing called the additive index and the the identity element, sorry. Now the identity element for addition is 0. The reason is because any number you add to 0 will return that particular number. So for multiplication, the identity element is 1. Now that's the reason why I'm using 1 here, because basically any number that you multiply by 1 is going to be returning that particular number. So that's why I'm using 1 here. So you traverse the list for, let me say, item nums. Guess what? Total item. So it is still the same thing as total equal to total multiplied by item. It's still the same thing. So you can see what I have over here. I'm multiplying the initial value of total by item, and then I'm assigning whatever I get here to total. It will work just fine. So if I should print the value of total and I run the code, you see, obviously it is correct. So this works. We move on to the next one. Okay, so this is the problem over here. So write a Python program to get the smallest and the largest number from a list. So I'm going to be using my mystery list. Now, so let me print to get the minimum value. Min boom nums. So there's this min value that Python has by default that will give you the minimum of all the items in the list, which is 2. And there's also this max function. No, no, no. This maximum function. Okay. So you see the maximum is 23. Now this is the easy way to do it, but the hard way to do it is to say, let me say the minimum equal to nums indexing the first element, so which is the element at the 0 index. Now, since the minimum, I've assigned this one to it temporarily. Now I will traverse the list for item in nums. Now if item is less than minimum, no, 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 no. Let me say min value. Okay. If item is less than min value, then min value equal to item. So let me add some more elements at the beginning to make this thing more okay. So you can see the minimum value is supposed to be 2. It's supposed to be 2. So what I'm doing here is I'm saying that for all the items that we have in this list over here, if that particular item is less than this min value over here, then we have to do some modifications to the value this variable is carrying. So I'm assigning that particular item to the variable. So the new minimum value is going to be changing. For example, at the first iteration, the minimum value is going to be 4. At the second iteration, the minimum value is still going to be 4 because obviously 5, which is the item, is not less than the minimum value, which is the current one, which is 4. But at the third iteration, I'm going to be having 2. So let me remove this 2 here. Let me put it somewhere here. So we have, okay, so at this point over here now, the minimum value is still 4, but it will come and after running this loop, testing with 3 with this item as 3. Now item is less than the minimum value, which is 4, so obviously I'm going to be saying this minimum value is not going to be having the value of 4 anymore because I've seen another number that is less than 4. So I'm going to be assigning 4, which is this, 3, which is this, to minimum value, and the list goes on and on and on till it gets to 2. So if I should print the value of my if I should print min value and I run this, you see I'm having 2. It works just fine. So if it is the maximum value that you're looking for, so just change this to greater than, okay. So if it is the maximum value that you're looking for, just for temporary whatsoever, assign the first item to be the maximum value. Now traverse the list. If the current item is larger than the current maximum value that I have, then that maximum value, we need to modify it. The maximum value will be taking the value of the current item, then at the end you print your maximum value. If I should run this, I have 23. Let me put 50 somewhere here. You see, I have 50. It works just fine. So we move on to the next one. Write a Python program to check if a list is empty or not. That should be typo. Okay, so come here. Now, how do I know if a list is empty or not? I'll check the length. If the length of the list is 0, then obviously the list is empty. If it is not 0, then the list is not empty. So let me have a list of numbers. Then if the length of my nums is equal to 0, then print the list is empty. Okay. Else, I might even print the number of elements the list has. The list, no. Print the list has, um, oh my god, I love formatted strings. Copy. Okay, so if I should run this, you can see the list has 9 elements. Let me add one more, maybe 49. I should run this, the list has 10 elements. What if I do nums dot clear and I run this? You can see the list is empty because of this nums dot clear that I put over here. Don't forget I said you can use the dot clear to clear the list. All the items in the list will be cleared. So I believe we are done with that. Then write a Python program to print a specified list after removing the 0th, the 4th, and the 5th index. Now, this is a technical kind of problem. Well, not a technical, but a Python program to print a specified list after removing the 0th, the 4th, and the 5th element. Now, let me come back to my list over here. Now, if I should start removing the items from the first to the second, then to the third element I'm supposed to remove. If I remove the 0th index, then obviously this 5 will be assuming the 0th index. And if I should remove the 4th index, 0, 1, 2, 3, 4. 10 is supposed to be the 4th index, but because I removed 0 first, 2 is going to be the element at the 4th index. So 22 is supposed to be the element at the 5th index, but because I removed the 0th element first, then I removed the 4th element, then I'll be having 5 as the element at the 5th index, which is not what I want. So the wise thing to do here is to remove it from the back. I'll remove the 5th element first. If I remove the 5th element, the 4th won't be affected and the 0th won't be affected. The order will not be affected. So that is the way I'm going to be doing it. So just say nums dot pop, start with 5, then nums dot pop 4, then nums dot pop 0, and that is all. Print nums. You see what I have over here? 537. You can see, but this will be giving me a different result. 0, 4, then 5. You can see it's giving me a different result here. 5, 3, 7, 10. You can see it's giving me a different result, which is not exactly what I want. So you can see. So Z. Okay. So this is the correct. This is the correct answer. So the last one, to append a list to the second list. Okay. Do I have any list here? Okay. Let me use this one over here. Okay. What am I doing? To append the list to the second list. Let me say x, then y. Let me take this. Okay. So one way to do this is to say x, dot extend y, and that settles it. To be honest, print x. So there's this extends function you can use to bring in another collection into a list, a tuple and a set into a list. So all the items you bring it into a list. So you run this code, you can see I have 2, 4, 6, 8, 1, 3, 5, 7. What if I want to sort my final list? Say x dot sort. Then if I should run this, you can see I have 1, 2, 3, 4, 5, 6, 7, and 8. So these are the two lists I have. These are the two lists I have. So I think that is the last one. All right. So thank you very much. I'll see you in the next video where we'll talk about tuples. Bye for now. All right, guys. Welcome back. So we are going to be talking about tuples. So tuples has a lot of similarities with lists. So for that reason, I'm not going to be spending much time. I think it should be tuples dot py. I'm not going to be spending much time talking about tuples. So tuples are written with round brackets. For example, let me say my friends equal to, so written with round brackets. So this is the tuple. Let me think of my female friends for now. Amina, then I've got Grace, then okay, so these are my three female friends. They are my enemies as well. So you can see this is a tuple over here. If I want to get the type of data type that friends is having, so I'll just print the type of friends, and if I should run this code, you see I'm having the class tuple. You can see I'm having tuple here, so it works just fine. So they are unchangeable, they are ordered, and they allow duplicate values as well. For example, I'm having Amina here, Alt Z. Okay, so I'm having two Aminas here. If I should run this code, let me just print my friends. Okay, if I should run this code, you see it's working perfectly. But one bad thing about tuples is that you can't change you can't change the tuple. You can't modify a tuple basically. For example, unlike what we did in list, saying friends equal to maybe no friends indexing 0 equal to maybe Henrietta. If I should run this, you see I'm getting, it does not support item assignment. You can see I can't modify a tuple basically. That's what I'm trying to say here. So but there's actually a way around it. You convert the tuple to a list, you do all your modifications in list, then you bring it back to a tuple. That is the way around it. So if you want to get the length of a tuple, you use the len function together with your tuple, and the len function is going to be giving you the length of the tuple. Then, if you want to access tuples, the same way you access list items, you access your tuple items as well. So this is going to be taking index of 0, 1, 2, and 3, but the length of the tuple is 4 because you have 4 items here. So obviously the index of this last one is going to be 4 minus 1, which is 3, and also negative indexing works here as well. For example, let me say friends indexing maybe 2, it should be giving me Chioma. So you see I'm having Chioma here. So if I should index negative 2, it should be giving me Chioma as well. You can see because obviously negative 1 then negative 2. So getting a range of like a sub tuple of a tuple slicing, it works as well. For example, if I want to get Grace and Chioma, I'm going to be starting from Grace and I'm going to be ending at Amina. So so I'm going to be starting at 1 and I'm going to be ending it at 3 because obviously it's not going to be including the item at the third index. So if I should run this, you can see I'm having Grace and Chioma. So getting slicing the tuple, it works as well, just the same way we do in the list. So you can also use the in operator to test for membership for items in a tuple. For example, Henrietta in friends. So normally, let me say value equal to. So let me print value. I should run this. You can see I'm having false here because there's no Henrietta in this. But let me just bring Henrietta and paste it somewhere here. I should run this. You see, I'm having true because Henrietta is a member, is an item contained in this list. So obviously, this is going to be giving me true. So if you want to update tuples, the way around it is for you to convert it to a list. Now, how do you convert a tuple to a list? You can say friends list equal to lists. So you can use the list constructor friends. So friends list friends. Then you do whatever modifications you want to do. For example, I might want to say friends lists indexing maybe 0 is what other female friends do I have? Let me say dollar. Okay, so well, friends list 0. I'm having dollar per here, so the next thing I want to do is to, since I've made my modification now, I'm going to be taking it back to a tuple. How do you do that? I'm gonna bring my friends back equal to tuple. Then I'm going to be using the tuple constructor here now. Friends list. So if I print my friends now, if I should run this code, I'm not getting any errors anywhere. As you can see, it started as Amina, Grace, Chioma, Amina again, then Henrietta. But because this is a duplicate, so I might just want to change one of the aminas. So that's why I'm having the lapo here. You can see I have the lapo here. So this is what I can't do directly in a tuple, but the way around it is to convert the tuple to a list. Then you do whatever you want to do as a list. Then you take it back to tuple. So um, in a tuple, if you want to loop through the items in a tuple, just the same way we do it in the list. You can just use the for loop. For example, let me loop through friends. Let me say for person in friends um, print person. So this works as well. So you see, it works. So, well, like I said, the list and the tuple have a lot of things in common, but the major difference is just that your tuples cannot be modified. Basically, that is it. So that will be all for this particular lecture. So I'll see you in the next one. Thank you very much, and bye for now. Hello, guys. You're welcome back. So in this lecture, we're going to be talking about sets. So set is another collection in Python used to manipulate not just single data but multiple data at the same time. So how does a set work? A set has so many similarities with the list as well, but it has more differences compared to tuples. Now, for a set, let me say set. No, no, no. Let me use my friends again, or let me use cars. Car models equal to. Let me say. No, 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 no. So you're going to be using, yes, Toyota Chevrolet. Then let me see, Honda Alt Z. Okay. So this is a set of car models. I'm having Toyota, I'm having Chevrolet, and I'm having Honda over here. So you can see that I'm declaring it using the coily braces. So a tuple is unordered, meaning that it doesn't follow any special order, like the way we have this one to be 0, this one to be 1, this one to be 2. It doesn't respect the order. It is unchangeable, just like the tuple, and also it is unindexed. So it doesn't have any order, and it is not indexed as well. So for you to output the data contained in your tuple, just as usual, we have car models. I should run this. You see, I'm having Chevrolet first. I'm having Honda, then I'm having Toyota. What is happening here? This is Toyota, this is Chevrolet, this is Honda. But for one funny reason, Chevrolet is coming first, Honda is coming second, then I have Toyota. If I should run it again, you can see that Toyota is coming first, Honda is coming second, Chevrolet is coming third. Now, this is just because I'm having three items here. What if I'm having more than three? That is to tell you that it is unordered, it is unchangeable, and also unindexed. So just like every other collection, if you want to get the number of elements you have, you use the len function. So you close this, then you run. You run it. You can see I'm having three because that is the number of items I have in my tuple. So you can't change the tuple items, and just like your list and your tuple, if you want to look through all the items, you can just say for model car models, print the model. No. So if I should run this, you see, I'm having Honda first, I'm having Toyota, then I'm having Chevrolet. If I should run it again, I'm having Chevrolet first, Toyota, and Honda. You can see the order, it doesn't respect the order, and it is unindexed as well. So if I want to add an item to a set, I can use the add function. For example, let me add Tesla. So car models dot add, let me say, hopefully I know how to spell it, Tesla. So if I should come and print my car model, run it, you see I'm having Tesla as the second element. But if this were to be a list or a tuple, if I'm using the append function over here, then I'm going to be having Tesla to be the last element. But here now you can see Tesla is coming second. Like I said, it is unordered and it is unindexed. So if I want to remove a particular element, let me remove Toyota. You're going to be having car models dot remove, then your element Toyota. If I should print my car models, guess what? I'm not having Toyota here anymore because I've removed it using this function over here. Then, if you want to remove just a random item in the set, just a random item, you can just use pop. So it will just remove a random item. So let me run this. You can see it's removed um, Toyota. It removed Toyota for now. If I should run it again, I think he removed Toyota again. So I should run it. Okay, I have Toyota this time. I have Chevrolet. I have Tesla, but I think he removed Honda. So it is just you randomly removing elements in the set. Then, if I want to clear the items in the set, I can just say car models dot clear. And guess what? Boom, the set is empty. I have an empty set. So that will be all about sets for now. I rarely have to use them, but it is good to know that they exist. So thank you very much. I'll see you in the next video. Bye. Alright guys, welcome back. So in this video we're going to be talking about dictionaries. So the last um iterable or Python collection that we're going to be talking about is the dictionary. Now the dictionary is a bit different from the list as well, but just like the list, it is ordered, it is changeable, but it does not allow duplicates. Now, the item in the list are just single values. For example, the names of my friends that I am used to explain. But for a dictionary, the items in a dictionary is a key value pair, like a key and a value. That makes up an item in a dictionary. And you cannot have duplicate keys in your dictionary. So duplicate items are not allowed. So let me give you an example of a dictionary. So 14 dictionary.py. So to explain the dictionaries now, let me say profile equal to my dictionary. I can say name, then Chris. So um, Nick, I can say halogen. I say friends. And guess what? I can have a list here, a list of friends. So let me say Amina, Grace, and Henrietta. This is supposed to be so Alt Z. Okay. So comma. Let me add one more. Then let me say um. Let me say I don't know. What can I use? Height. Let me say I don't know what my height is. Let me say 6 comma 4. I don't know. I don't know how tall that is. Okay, let me use 6 comma 2. So you can see this is the dictionary over here. So this is a dictionary item. This is another dictionary item. This is a dictionary item. Then I have another one over here. So you can see I've just used a profile to represent a dictionary to show an example of a dictionary. So now duplicates are not allowed here. Let me print the profile. Please, it's not by force that you have a Python collection here. So I'm just showing you that this Python collections can be nested. This can be a singular value. This can also be a collection. It depends on the complexity of the data you want to manage. So if I should run this, you can see what I have over here now. This is the dictionary. Name, Chris, Nick, halogen. Let me say nickname. Okay. So if I should run this, see, I'm having nickname now instead of just Nick. So that is the profile over there. So duplicate elements are not allowed. For example, I can say nickname halogenius. Now, if I should run this, you can see what I have here. Nickname is showing as halogenius. So it means that it's basically overriding this one, taking this one out of the picture completely. So that is what is happening. Just to be safe, make sure that you have only one. So that is all about that. Now, if you want to access the an item in a dictionary, for example, for this particular person whose profile is represented using a dictionary, if you want to get the person's name, all you have to do is to say profile, then you index using the key. You understand? For other Python collections like the list and the tuple, you index using their index 0, 1, 2, or 3. But this will be the index that you're going to be using. What you're going to be, the key you're going to be using to index for the person's name. So you can just come here and say name, then you run it, you see what I'm having, Chris. Another way to get that particular value is to say dot get. Then, but nobody does this. I just want to show you it exists. So nobody does this. You can see I'm having Chris, but this is nobody does this. So let me just stick to this. So if I want to index for Chris's friends, I can just say friends. Then I'll run it. You can see I'm having a list of Chris's friends over here. So that is how you get the values of a dictionary. Now another thing you might want to get is like all the keys in the dictionary. Don't forget these are keys. These are the keys, and while this is a value, this is a value, this is a value, this is one value, then this is another value over here. So if I want to get all the keys, I can just say profile dot keys. Then if I should run this, you can see I'm having a dict keys data type, name, nickname, friends, then height. If I want to get the values, and this will give me all the values. You can see I'm in Chris, halogen, then a list of my friends, then 6,2, which is my height. I don't know if that's correct. So to check if a key exists, for example, to check if there is an item that is duly represented here, for example, let me say weight. You can have something like weight in profile. So if I should run this, I'm going to be getting false because weight is not represented here. But if I should come here and add my weight, I don't know how much I weigh. Let me say 80 kilograms. I don't know how heavy that is. So you can see I'm having true here now because weight is duly represented in the dictionary. So we move on. To update a particular to update one of these values over here, for example, I might want to update the name over there. Let me say profile. To update the name, so this is going to be equal to, let me say Christian. So if I should print profile and I run this, you see the name is now Christian. The name is Christian. So that is how you modify a particular key in to modify the dictionary. But what if you want to add a new key value pair to this particular dictionary that I have over here? So you want to add a new key value pair. Very simple. Let me say profile, then school equal to unilag. If you run this, you can see school have been added now. It used to be just name, nickname, friends, weight, height, but now I have school unilag. So that is how to add another key value pair to the dictionary. What if you want to remove a key value pair? You can use the pop method file. So dot pop. What are we popping? Let me say friends. I don't need any friends anymore. I want to be on my own. So if I should run this, you can see I don't have any friends anymore. All my friends are gone. So that is how you pop a key value pair from the dictionary. So if you want to print all the keys that you have in the dictionary, you can use a for loop to print all the keys that you have. For example, for let me say key in profile dot keys, you can say no, print key. Okay, so run this. You can see this is a list of all my keys. Now what if I want to print the values? So So you can see profile of values. It's going to be giving me all my values. So I'll just, for value in profile of values, print that particular value. So you can see these are all my values. You don't understand how for loops work yet, so just don't worry. When just know that this is how you do the iteration. When we work on for loops, you understand all these things better. So that is how you iterate over your keys and your values. What if you want to iterate over the items themselves? So a collection of the keys and the values. So what you might want to do is to say for let me say key comma value in profile dot items. So print, let me see, okay, let me use formatted string to make it clearer. The key, no, key has the value. Okay, so run this and let me expand this to make it clearer. So the key name has the value Christian, the key nickname has the value halogen, the key height has the value of this, and you can see. So that is how you iterate over your dictionary. So we are going to be stopping here for now. I'll see us in the next video where we're going to be talking about loops basically. So hopefully we are going to be starting with the while loop, with the for loop, then we'll go to the while loop. So thank you and bye for now. Hello guys, you're welcome back to the video. So we're going to be talking about loops. So for this first video, I'm going to be talking about for loops. Then in the next one, I'll talk about while loops. So a for loop is basically the tool in Python programming that gives you the opportunity to iterate, to traverse an iterable or a collection, to traverse it might be a string, it might be a list, it might be a set, it might be a tuple. You can also use it to traverse a dictionary. Traversing an iterable or a collection means visiting all the items in the collection. So for every item you have in the collection, you're going to be carrying out a certain number of tasks, or you're going to be like running some kind of code or something. So the for loop allows you to visit all the items you have in a list or a collection, then perform certain tasks depending on the element that you have. So um yeah, that is just it for loops. Okay, so now getting into it. uh, 15. Okay, so getting started, for loops.py. Now, loops are used for iterating over a sequence, like I said, a collection of values. For example, let me say I have a list of numbers. Let me say num equals to a list of 5 to 77, 44, 32, 65, 89, 10, and let me put one more, maybe 24. Okay, so these are the list of items I have. So the for loops, if the for loop will give me the opportunity to traverse my list, meaning to iterate over the list. Then I'll perform whatever action I want to perform, iterating all the items. For example, if I want to visit all the items in the list, I might just say, for the way you write a for loop, you put a count variable here for maybe elements in the list that you want to traverse num. This variable over here, I'm just using element. You might use item, you might use value, you might use whatever you want to use. Just make sure that you have any valid variable here, a valid Python variable here. Then this num that is going to be here now will be the iterable or the list, the tuple, the set, or the dictionary. So no. So for element, you can just print the element. Then you run the code. You see, I'm getting 527744. So this is me iterating over this particular list using a for loop. So if I want to get the double of all the elements in this number over here now, all I have to do is just do something like times 2. So if I should run this, I'm going to be getting something different. So you see, I can have 10 for 154.88 because basically I'm looking for the double. What if I want to get the square of all the items over there? You can see I have the square over here. So that is working fine. You can use it to loop through a list. Also, there is a particular problem that we solved that we got the sum of all the the numbers contained in a list. So getting it back, you're going to be having total. Your total is going to be equal to 0. Don't forget, 0 is the identity element for addition. So, and the reason is because any number you add to 0 is going to be returning that same number back. So since I have my total to be 0, for every element in number, all I have to do is to increase the value of total by that element. So total plus equal to elements. So you come down here, you print your total, and boom. That is one of those things that the for loop can do for you. So you see what I have over here, 348 is the sum of all these elements that we have over here. It's the sum of all the elements we have there. So that is it. Now we have some keywords that you can use together with a for loop depending on the problem you are trying to solve. So we have the break statement and we have the continue statement. So um, the break statement is used to break out of the whole loop. Like if you want to terminate the loop, for example, you can see what I have over here now, 5227744. For one reason, you might want this loop to break out at any point in this running this particular iteration now for any reason. That is what the break statement is used for. For example, I might say if the element is equal to 65, then break. So obviously, if I should run this code now, it is going to be giving me the sum of all these ones excluding 65, 89, 10, and 24, because at this point I'm breaking out of the whole loop. That is what this break statement is used for. For one reason, you might want to break out of the loop. That is what it is being used for. So if I should run this, it's going to be giving me 160, which is the sum of all this. You can use your calculator to confirm that. So that is what the break statement is used for. But the continue statement is used to break out of the current iteration. So the break statement will break out of the whole loop, but the continue statement will break out of the current iteration. So if I should use continue here instead of break, then it is going to be getting me the sum of all the items you have here excluding 65, because when it gets to 65 it will just break out of that current iteration. That is what continue does. But break will break out of the whole loop, continue will break out of the current iteration. So running this code again, you see I'm having 283. So I guess if you should do 348 minus 65, you should get 283. So that is all about that. Then we have the range function. Now this range function returns an iterable, returns a sequence. Now the range function is designed in such a way that you can you can give the range function one parameter, two parameters, or three parameters. So let me use the word arguments. So the way the range function is designed, you have the start, you have the stop, and you also have the step. So for example, if I have range 6, for example, range 6 is going to be giving me 0, because it will assume that start is 0, and it will also assume that step is 1. So but it will take your stop as 6. So my iterable will be 0, comma 1, comma 2, comma 3, comma 4, comma 5, but it will not include 6, so it will stop at 6. Now that is if you are working on that is if you are using if you are using only one argument here. But if you are using two arguments, for example range, let me say 2 comma 6, so this is going to be giving me starting from 2, 3, 4, 5, but it is not going to be doing 6 because the stop is 6 and the start is 2. So if you have two arguments to the range function, this is what you're going to be getting. Now, what if you want to use all three arguments? For example, range 2, comma maybe 20, comma 3. So start is going to be taking the position of 2, stop is going to be taking 20, step is going to be taking that of 3. So what iterable are we to expect? Now you are going to be expecting 2, but the step is 3, so the next element will be 2 plus 3, which is 5, plus 3, which is 8, plus 3, which is 11, plus 3, which is 14, plus 3 is 17. Then normally another plus 3 is supposed to be 20, but because the stop is 20, we are going to be excluding 20, so we are not doing anything there. So let's confirm all we've said so far. Don't forget the range returns an iterable, so obviously we can use our for loop to traverse it. So let me get this one out of the way. So for 6 no, for number in range 6, print number. Okay, so running this code, you see what I have? 0 to 5, just like I predicted. 0 to 5. What if I had 2 to 6 and I run this? You see I'm having 2, 3, 4, 5. What if I do 2 comma 20 comma 3? So you can see what I have now: 2, 5, 8, 11, 14, and 17. So that is how the range function works. So you can use it to do a lot, not just printing the number. You can get the square, you can use it in a different computation and all that. It depends on whatever your use case is. So um, another thing I would like to show us is the for else. The for else. So the for else basically executes when the loop is done executing. When the loop is done executing, that is when the else executes. For example, print loop has finished executing. So this else over here, if you remember the if else, it is if the condition on the if is wrong, then the else kicks in. But for for loops, when you create the count variable and the iterable, after the whole of this are finished executing successfully, the else kicks in. So for example, if I should, you can see it is printing all these numbers, then after it finished execution, the else kicked in. So that is how you use the for else. But that one apart, one thing you should know is that this loop over here, let me use this one. Let me use this one. Copy and paste. Okay. So let me use this one. If I should say break here, the else will not work because I'm using break over here. The loop. I'm breaking out of the loop using a break statement. So the else will not work. It will not work. For example, if I should run this, you can see it is not printing anything out. Let me just say print total. Print total. So run this. You can see I'm having 443 here. I'm having 443 here. So the loop has finished executing, but because I used the break statement over here, it is not going to be executing this one. So please take note. Now, another thing I would like to show us is the nested loop. Is the nested loop. For one reason or the other, you might have to put a loop inside another loop. I do it all the time actually. You put a loop inside another loop. So let me say you want to get all the two combinations between 1 and 10. Like if you have or should I use okay, 1 and 10, I think 1 and 1 to 0 to 9, 0 to 9 is better. So I can have something like for x in a list of 0, or let me say range 10. Then for y in the same range 10. What you want to do is to print x comma y. No. X comma y. Okay. So if I should run this, you see what I'm having over here now. This is 00, 01, 02, 03. So what is happening here basically is that for x in range 10, don't forget that this particular loop is within the confinements of this loop. So for x in range 10, don't forget 10 is going to be giving me range 0 to 9. So 9 inclusive, 0 also inclusive. So for the first iteration, x is going to be 0. So it will pause first. Then it will enter y, range 1, comma 10. So at point 0, you are going to be having 00. At point 1, you're going to be having 01. At point 2, you're going to be having 02. But at some point, we get to 9, which is the last bus stop of this particular loop over here. So when 9 executes and there's no that thing to execute, it goes up to increment this x to be 1. So it goes on and on like that, and that is how we come about that. So finally, before I drop exercises, for this particular for for loops, you cannot declare an empty for loop. This is what I mean. Imagine having something like this. You cannot declare an empty for loop. If I should run this code, I'll get error. So, but to avoid errors, you can use the pass statement to make sure that you're not running into errors. You can see you can't declare an empty loop. But if for one reason or the other the loop has to be empty, then you can just go ahead and use the pass statement to just hold it down there. So that is it. Back to the exercises. Back to the exercises that we have. Um, okay, so these are the exercises available to see. So take your time to work on them, and in the next video, I'll show us how to solve all of them. Thank you very much. I'll see you in the next one. So hello guys, you're welcome back. So let's get into solving the assignment problems. So write a Python program to find those numbers that are divisible by 7 and it is a multiple of 5 between 1500 and 2700. Now we need to apply wisdom here. It is very necessary to make our life easier. So a Python program to find those numbers that are divisible by 7 and a multiple of 5. Divisible by 7 and basically divisible by 5 as well. So I don't know. Um, the way to solve this is to multiply 7 by 5. Then you look for those numbers that can be divisible by 35, and that is it. So to solve this problem, I'm going to be saying for I in range, let me say 1500 comma 2701. Yes, because if I use 2700, it will not be 2700 will not be tested. So print, no. So if I percentage 35 is equal to 0, print that number. So you can see I have all the numbers here. I have all the numbers here. So that is that about that. I'm not going to be working on all this because I believe that they're fairly simple. I'll just take two more and I'll leave it to the rest. So write a Python program that accepts a word from the user then reverses it. Very simple. So copy this and bring it here. Okay. You write a Python program that accepts a word from the user then reverses it. So let me say word equal to maybe or let me say university. Okay. So if word is university and I want to reverse university, I might say output equal to an empty string. Now don't forget that output being an empty string means that basically I'm trying to use output as an identity element here, meaning that any character that you append to output will return that particular character again. So that is just the logic behind what I'm doing here. So you can say character in character in range, let me use range, length of word comma -1 comma -1. Yes, this works. So then the next thing you want to do is to say, let me say index. Okay. So what is university? Output is an empty string. What you want to do is output plus equal to word indexing the index. Okay. So next thing you want to do is to print your output. So run the program and I'm getting an error here. Index out of range. Okay, this should be length of word -1 because the index of the last element obviously will be the length of word -1, the length of the particular string -1. So if I should run this program, okay, it's working fine. You can see university reversed. So that is that about that. Then let me take one more. So write the Python program that prints all the numbers from 0 to 6 except 3 and 6. So okay, so now this is a very simple one for I in range, for I in range for I in range 6. What you want to do for me is if word no, if I is not equal to 3 and I is not equal to 6, guess what, print I. You can see what I have over here now. 0, 1, 2. It is excluding 3, 4, and 5, and it's excluding 6. So that is all about what I'm going to be doing for loops. So you can see we have other ones over there. Feel free to ask your questions in the comment section. I would love to hear them, and I would love to assist you with them. So thank you very much. I'll see you in the next video. Bye for now. Peace. Alright guys, you're welcome back. So we'll be talking about while loops in this video. While loop, a while loop is a condition-based loop such that something keeps happening if a condition is true. When the condition turns false, it will break out of the loop basically. So in programming generally we have two type of loops. We have the conditional and non-conditional loops. Now the for loop is an unconditional loop, as in you just program the number of times the loop is supposed to run and the loop will just run that number of times. But for the while loop, sometimes it might not be certain how many times the loop is supposed to run, but there is a release clause. Yes, let me use that statement. There's a release clause, or there is this condition that if it becomes true, if it becomes true, then you want to keep running the loop. But as soon as the condition turns false, you want the loop to terminate, depending on what kind of problem you are trying to solve. So that is what the while loop is being used for. Um, well, depending on who is at the wheel, any problem you can solve with your for loop, you should be able to solve with your while loop as well. So for the while loop, let's get into how it's been done. So we have 16 while loop. Okay. Dot py. Okay. So the way you write the while loop is very simple. All you have to do is to start with your index variable, which can be I. Let me say, let me use index equal to 0, for example. Then now you write your while loop while your index variable or your count variable is less than 10, for example. Print I index. So save this and run it. You can see I'm running into an infinite loop now. An infinite loop is a kind of loop that you run into that it keeps on running unless you terminate the program. It will keep on running. So I have to first terminate this program over here because it is running into an infinite loop. As you can see, it is giving me 0 0 0 0 0 0 0. It's giving me all zeros. This is an example of an infinite loop, and it can crash your laptop or the device you are working with. So now the reason why this is giving me 0 0 0 running into an infinite loop is because let us try to analyze the program now. I'm saying index equals to 0, which is fine. Now, while index is less than 10, what? Print index. Okay. So now this condition is true for the first iteration. Print index. It will execute print index, and don't forget index is 0. So it will go back again and check. Index is still 0. So index less than 10, it is true again. It will print the index again. Then there's no other thing to execute here. It will still go back to check if index is less than 10. It will keep printing 0 0 0 0 0 because index is always 0. But there's something we can do here to ensure that index is not always 0. You come and increment. Now if I should run this, it will just give me 0 to 9 because this is index as is 0. Index less than 10. This is the condition for my while loop. If this condition is true, keep executing. When the condition becomes false, then you stop executing. So this is print index over here. For the first iteration, index is 0. After printing this 0, I'm incrementing index by 1. So index will be 0 plus 1, which is 1. So it will go back, index less than 10, yes. 1 is less than 10. You print the index, which is 1. You increment the index. The new index becomes 2. So that is how you keep incrementing. So this is to say that with what you have here over here now, There's rarely any problem you can solve with your for loop that you can't solve with your while loop. Because don't forget, if you want to use the range function, for example, you're going to be having your start, your stop, and your step. You can use this index over here, this line over here, to set up your step. For example, I might decide to put 2 here. I might decide to put 2 here. You can see it is going from 0 to 4. You can see the step like that. So the same way continue works in the for loop is the same way continue works in the while loop. The same way break works in the for loop is the same way break works in the while loop. So the continue is used to, like, the continue is used to break out of the current iteration, while break is used to break out of the whole loop. Let me give you an example. So let me return this step to 1. So if I should print this, you can see I'm having 0 to 9. So I can say if index is equal to maybe 5, for example, continue. Then let me come to print my index. If I should run this, you can see it's not even going at all. So if you want to use the break to, like, break out of the whole loop, so you might want to use the break statement to break out of the whole loop. For example, if let me run this, you see I'm having 0 to 9. If you want to break out of the loop, if you encounter a 6, you can do something like if index equal to 6, then do what? Break. So run it. You see, when it gets to 6, it breaks out of the whole loop. So the same way the break statement works in for loop is the same way it works here as well. So then we also have the while else, the while else. The else kicks in when the loop is done executing and there's no other thing to execute. For example, when this particular condition over here is not true anymore, then the else kicks in. You can print um, index is no longer less than 10 or z. So you can just print index is no longer less than 10. If I should run this, um, okay, it is breaking out of, I don't need this, I don't need this. Okay, you can see the condition is for index to be less than 10. So for the first iteration, index is still less than 10 up to the ninth no, up to the 10th iteration, which is when index is 9. So actually the first iteration will be at index 1. So this will be the ninth iteration. So at the ninth iteration, index is still less than 10. So the 10th iteration where index becomes 10, you can see that this condition is no longer true. As soon as it encounters that this condition is no longer true, the else kicks in. The else clause kicks in. So that is it basically. Like I said, majority of the problem you can solve with your for loop, you can solve with your while loop as well. So I'm not going to be waste much time explaining the while loop. So let's get into exercises. I've got just 3 of them here. So these are the exercises for while loop. You take your time to work on them. Then in the next video, I'll drop the solution to all of them. So thank you very much. I'll see you in the next one. Bye. Alright guys, you're welcome back. Um let's start solving them. So for the first one, write a Python program to find the numbers between 10 and 100, both included, where each digit of a number is an even number. Okay. I feel like we should do this one first. Let's do this one last because these ones are easier. So let's do this ones first. They are easier. Write a while loop that adds all the numbers up to 100 inclusive. Now we'll start with our identity element, which is zero, like I solved a few lectures back. So total equals to zero. This will be what I'm going to be using to count the sum, to accumulate the sum. So now since I have my total now, I can say index. You can use any variable you want, please. It's not by force you use index. You can use any variable you want at all. Any variable at all. It will work fine. So my index is zero. Now while index is less than 101. The reason why I'm using 101 is because if I use 100, it will not include 100. Don't forget. Okay, I can actually say less than or equal to 100. Less than or equal to 100. This works too. So let me go with less than or equal to 100. Okay. So while index is less than or equal to 100, what do you want to do? Um, Add up all the numbers between 0 and 100, I guess. So total plus equal to index, and I think that will be all. Just print total, then run it. Mm, oh, sorry, this program up here is still running. Oh, okay. Mm, you can see the reason why my program is hanging over here. The reason why my program is hanging over here is because it is running into an infinite loop, because I'm not incrementing index here. So please don't make mistakes like me. I actually forgot to do that, to increment. So this should be index plus equal to 1. So you can see 50-50. So 5050. So I don't know if this is correct, but it's Python, so it's correct obviously. So moving on to the next one, write a while loop to generate a list of perfect squares between 10 and 5000. Okay, oh, let me, to avoid having too many while loops in the program, write a while loop to generate a list of perfect squares. Okay, what is a perfect square? A perfect square is a, for example, if you have 2 square, 4 is a perfect square because you just multiply an integer by itself to get the number. Okay, so write a while loop to generate a list of perfect squares between 10 and 5000. Okay, the first thing you want to do is to create an empty loop, an empty list rather. Now, why are you creating the empty list? The empty list is like, I don't want to call it the identity element here because anything you append to an empty list will return a list containing that thing. So this is what I'm going to be using to collect the final output. So I can say output equal to an empty list. So don't forget, I'm using my index. Please, it's not by force you use index. Anything you want to use is totally fine. So I'll say while index square is less than 5000, because obviously, okay, let me make this 5001, or less than or equal to, I think this should work. So as you can see, what we are trying to generate is a list of perfect squares, and a perfect square is just a number, an integer multiplying itself. The result is the perfect square. So I'm trying to like while index square is less than or equal to 5,000. So um, let me say the perfect, or let me say PS, perfect square. Let me just write it in full. Perfect square equal to um index multiply raised to power 2. Okay, so now don't forget I have to add it to this list over here, so I'm going to be using the append function. So I'll say output dot append. Append is going to be adding it to the end of the list. So as it is empty now, the first one will be added to the list, then the second one will be added in front, the third one will be added in front, and it goes on and on. So perfect square. Don't forget to increment. This is a while loop. You need to increment index plus equal to 1, so your device won't run into an infinite loop. So what do you want to do to show your output? So you print output, so you run it. You can see, so these are the perfect squares that we have. Don't forget you have 1, 4, 9, 16, 25, 36, 49. You can see, and the list goes on and on and on. So a list generates all the perfect squares between 0 and 5,000. So this is also something you can do with a for loop using the range function. If you want to do this using a for loop, let me, all you have to do is just for I in range. So I is my index variable over here now. I will be my index variable. So let me use index in range. Let me say 1 comma 5,001. The step is going to be 1, so I can just say perfect square equals to index raised to power 2, then output dot append perfect square. So I don't have to increment since this is a for loop. Since it's a for loop, but I need to put a clause somewhere here that if index raised to the power of 2 becomes greater than 5,000, break. Okay. Actually, for this loop to work properly, I might actually decide to cut this down to 500 and it will still do the job I want it to do. I might decide to cut this down to 200 and I think it will still do the job I want it to do perfectly. But just to avoid confusion, let's leave it at this. So if I should run this, you can see the same thing I printed here is the same thing I printed here. Both of them are working just fine. So like I said, any problem you solve with a for loop, you can also solve with a while loop in most cases. In most cases. So going to the last one, write a Python program to find numbers between 100 and 400 where each digit of a number is an even number. This is very easy. Um, so write a Python program to find the numbers between 100 and 400. So our loop is going to be running from 100 to 400. So that's to tell you that the index, just to be safe, is going to be starting at 100. Then while index is less than or equal to 400, because don't forget 400 is included, you come down index plus equal to 1. Yes, we are safe. Now the Python program to find the numbers between where each digit of a number is an even number. So they've made our life easier by giving us numbers between 100 and 400. So You know that numbers between 100 and 400 all have 3 digits each. 3 digits. So how can you filter out individual digits? What can you do? Before recording this video, I didn't solve this problem. So I guess everybody will have to put their head into it. But trust me, it's not a difficult one. So for me to filter out the last digit, well, what do I want to do? There are so many ways to solve this problem, but let me convert it to a string. I can say num str equal to str, convert it to a string, then index. Yes, convert index to a string. So after converting index to a string, then um, this will be the long route I want to take. But I feel like it will be easier because um, I feel like it will be easier. Okay, let me just take this long route. So num str equals to str index. Now, basically, if I have 355, for example, I've converted it to 355. That is what I did over here now. So I want to look for a way to filter out all these ones. The first, the second, and the third digit. So I can say d1 equal to num str indexing 0. So I've indexed this one as d1. So d2 equal to num str indexing 1. So d3 equal to num str indexing 2. Okay. So now, since I've been able to filter out each individual digit, now let me start checking. So my conditional statement now, if int d1 or I can actually use a for loop here instead of having to write the condition. But please, I don't want to make this more complicated than it should. So if int d1 percentage or modulus 2 equal to 0, what I'm trying to do here is to say if you convert d1, which is the first digit, to an integer, and you divide that integer by 2 and the remainder is 0, and no, I'm writing PHP syntax, and you do the same thing for d2, then and you do the same thing for d3. Print index. To make my work neater, let me close this and close this, then close this in a bracket. I want to make my work neater. Yes. So I have 3 conditions. This is the first one, the second one, then the third one. So if all 3 conditions are met, then why not print the index? So okay, I'm having 200. An even number is a number that if you divide it by 2, you are going to be getting 0. Have we? So I guess we are correct here. I guess we are correct. So you can see all the numbers we have over here now. It works. So that will be all for while loops for now. I'll see us in the next video. I hope you are able to solve the problems on your own. So thank you very much. I'll see you in the next one. Bye for now. Hello guys, you're welcome back. In this video, we're going to be talking about exceptions. Exceptions. So, for one reason or the other, your program might not behave the way you want it to behave. It might be, let me say, misbehaving. So, or it might just be you trying to take precaution as well. So, exceptions help you to look out for these misbehaviors and tackle them, or you raise exceptions by yourself. So, let me show you how it works. 16, so this will be 17 exceptions dot py. Okay, so now exceptions. I will give you an instance where we actually need an exception. In mathematics, you can't divide a number by zero. In Python, if you try to do it, you are going to be getting what we call a zero division error. So let me say number equal to maybe 35. Now print 35. No, let me use num divided by 0. If I should run this, you see I'm getting a zero division error over here. Zero division error over here. So, and the error is division by 0. Let me give you another instance where you might need an exception. So some videos back I said you use the plus sign for addition and concatenation. Addition is when you are trying to, when your operands are numbers. Concatenation is when your numbers are strings. When your operands are numbers, then you are doing addition. When your operands are not numbers, for example, strings, actually it has to be strings, both of them, then you're doing concatenation. But if you try to add a number to a string, you can't do that unless you convert the number to a string. So you are going to be getting a type error. A type error. Let's try to do it. Print maybe num plus, I should run this. You see, you're getting a type error here. You're getting a type error here. You understand? So another type of error that you might get is a name error. I think a name error is if you are trying to use a variable you have not declared, or that is not declared within the scope of what you are working on. For example, name. I've not declared name. Or if I should try to run this, you can see I'm getting a name error. So you can see all these different kind of errors that you can encounter for one reason or the other. We have a long list of them. You can just check Google for them. So now, how does the try except work? You first of all use the try to try the code. Trying the code, you can say, let me use this one for example. So you want to use try to try the code. Now, trying the code, you have num. Let me take this one out of the way. So the reason why it's giving me this error message is because I must have an except somewhere. So except. I won't go into much detail with this. I just want to show us the basics of try except. It goes a long way. So you can accept and say maybe print error encountered. So save this and run it. So instead of your program crashing as it would normally, you can see you have handled the error encountered. So I think you can accept the exception as E, error encountered. So I can have a formatted string here and say error encountered E. Yes. You can see error encountered division by 0. So, and if you check it very well, that is exactly what we got when we had the zero. You can see the zero division error here. What is the error? Division by 0. So you can see what I have over here, division by 0. So let's try to do for this name. Let's try to do for this one. Okay, that will be plus name. So if I should run this, you can see error encountered is what? Name. is not defined. Let me say age. So you won't be saying name. Okay, so this variable name age is not defined, but you are trying to use it. So that is how you handle exceptions basically. So another thing you might do is you might want to raise an exception by yourself, like you as the programmer, if the user should perform some kind of maybe mistakes in the input that they are giving you, you want to be the one to raise the exception by yourself. How do you do that? So you can say, let me take this one out of the way. Okay, so you can do something like input enter, what am I doing, a number. Okay, so but I won't be converting anything here. I won't be converting anything here. Let me just use a var. Okay, let me use a var. I can say user input equal to, okay, so a var input. So if the type, no, if type of user input is not equal to int, um, then raise exception wrong inputs, else, okay, you can just print correct inputs supplied. Okay, so if I should run this, enter a number, let me say 35. You see correct input supplied, but let me put this here, or z. Okay, so if I should run this, enter a number, maybe you can see I'm supposed to enter a number, but I'm entering something else. You can see name error. Okay, it's actually raising the exception. I didn't know. It's actually raising the exception. Thank you very much, and bye for now. What's up, guys? We are back to another tutorial in this course. So for this one, we are going to be talking about functions. We're going to be talking about functions. So a function normally as a programmer is something you write to do something specific. It might be to generate a QR code. It might be to print out, to generate a receipt. It might be to send out emails. It might be to do so many cool stuff. So for this particular lecture, we are going to be talking about functions. Now, a function is a block of code that will not run unless you call it. The function is there, available for you to use, but if you don't call the function, it will not be executed. Nothing happens. So you can pass data or parameters into a function. You can, you might decide to pass parameters into it or not. There are some functions that will require you to pass parameters into them. Some functions won't require you. Some functions won't be it won't be needed at all. Like you pass parameters into the functions won't be needed at all. So then another thing you should know about a function is that a function has the ability to return a value. What do I mean by the ability to return a value? A function can return data as value. It can return data as value. For example, you might write a function that is supposed to say look for the square of a number or the square root of a number. So normally the function will go do the whatever computation it has to do, then it will return the value. So that's what I'm trying to say. Now let's get into it. So new file. What's the biggest one? 17. So this should be 18 functions.py. Okay, so close this. So okay, going into it, for you to be able to use a function, you have to do two things. You will create the function, then you will call the function. So creating the function is what you call function definition, then calling the function is what you call function call. So let's create a function. Now for you to create a function, you are going to be needing the keyword def. This is the function used to create. This is the keyword used to create a function. So def your function name, for example, sqrt, or let me use something more. Let me say greet. So def greet. Then this is how you write the header of a function. The header of a function. So basically, what you are trying to do here is function definition. So you come and start writing the body of the function. For example, this person might just say good morning. So that is what the function is doing. So you can see I've written Python code here and they are not commented. So if I should try to run this, you will see that nothing happens here. Absolutely nothing happens here. The reason is because I only define the function. For me to be able to get access to the function or make use of the function, I need to call the function. So the next thing for me to do after defining the function is to call the function. So that is the function call. So how do you do function call in Python? Basically, all you have to do is just say greet. No. So if I should run this, you see I'm having good morning here. So I've successfully written a function over here. I wrote a function here, then I called the function here. This is function definition over here, and this is function call. So that is how you create and make use of a function, and your function must not be a one line. It must not be a one line function. Let me give you an example. Let me say for example, I might say name equals Chris, then good morning, comma, name. Okay. If I should run this, you can see I'm having good morning Chris here. So it must not be a one line function. You might decide to write as many lines as possible there. But if your functions start getting too long, you might want to partition them into two. Partition the function into two to make your code look neater. So moving on, argument and parameters. Now, this is a function over here. This is a function. You have so many functions in mathematics. You have the function for square root. You have the absolute value. You have the sine, the cosine, and a lot of them. But these functions, for them to work, you need to supply it with data. You need to like make data available for it to be able to use for its computation to serve as input. So likewise here, like I said, it is not by force that you must supply inputs to your functions, but some functions require inputs to work. That is where arguments and parameters come in. So basically both of them, it's a misconception, but some people said you can use them interchangeably. That is very wrong. So let me give you an example. I might say def let me say add, then, or let me say square, then I have maybe num, then I can say print num raised to power 2. So you can see what I have over here now. The name of my function is square, then the parameter required for square to run is num. I believe you understand you understood what I just said. The parameters required, those data that you will need to run this square function successfully, is the number you want to square. If it were add now, for example, let me write another function. If it were add, def add, let me say x and y, then I'll return x plus y. Okay, so you can see that the for me to be able to add is a binary operator. What I mean by binary operator means for each addition operator, you need two operands. The operands that are going to be required are the two numbers you want to add together. Since it is addition, the order of the operands doesn't matter. But what matters is the fact that you need two operands to be able to run the add function. That's what I'm trying to say. So that is where parameters come in. For you to be able to, like my one of my secondary school teachers used to say, high school, would say that for you to solve a mathematics problem properly, you need to first of all write out your parameters. These are the data that will be required for you to be able to solve the problem at hand. That is where parameters come in here. So the parameters required to run the add function are the numbers x and y. X and y are representing the numbers. Now, for you to call this add function, for example, don't let me use the return statement here. I don't want to make it complicated yet. Let me just print. I'll talk about return later. Okay, so this should be x and this should be y. Okay, so let me, you're done greeting me. So the next thing I want to do is to add, let me say 7 comma 4. Okay, if I should run this, you see I'm having 11 over here. So these are the arguments of the function add. I'm using 7 and 4 as arguments to pass, like these are the arguments of this function. Add has two arguments, x and y. 7 and 4 are the arguments here. But don't forget that 7 is going to be taking, x is going to be taking the position of the value of 7, and y is going to be taking the value of 4. So x and y are parameters, 7 and 4 are arguments. So arguments are used at function call. Don't forget, this is the function call. This is where you are calling the function. While parameters are used at function definition. So you need to take note of that. So by default in Python, for you to use parameters and arguments, the number of your arguments must be equal to the number of your parameters. For example, I have x and y over here, and for at the function call, I have 7 and 4. If I come and have something like x, y, and maybe z here, running this, guess what? I'll run into errors because you can see type error. I'm missing one required positional argument. So what if I take this one out and I use only x? You can see. So your number of arguments must be equal to your number of parameters. So if I should run this, it will be working fine once more. So another thing you should know of is keyword arguments. Keyword arguments. Let me say I have comma z. I want this to be, so let me say multiplied by z. I want it to be very visible. Okay, so you can see that I have x, y, and z now. If I want to pass in this argument using keyword arguments now, Python permits me to do something like this: z equal to 10, x equal to maybe 5, then maybe y equal to maybe 3. So if I should run this, I'm getting 35. Let's try to calculate it if it's correct. So this is x, which is 5, plus 9, which is 3, plus multiplied by z. So by precedence, this will be coming before the plus sign. So what is y times z? Y is 3, z is 10, that is 30, plus x, that is 35. So this is very, very much correct. So you can see the way I scattered it, yet it worked fine because I can pull the data in as positional arguments. But let us remove this our positional argument first. You see that you are going to be getting a different result. You can see you're getting 25 now, which is a different result. So the keyword argument works. It works. So we also have default parameter values. We also have default parameter values. For example, you might decide to do something like z equal to 1. Then if you run this, normally you're having 25 now. So x is taking 10, y is taking 5, and z will be taking 3 if you run it the way it is like this. So guess what? 3 is going to be this is going to be y, which is 5 times 3, 15 plus 10, that is 25. But x, okay, so if I should take away this one and I run it again, I'm having 15 now because the z is what? 1. So what is x? 10. Y 15. 15 times 1, because z is already taking 1. You can see that is 15 as well. So it depends on whatever use case that you have. Just know that keyword arguments, positional arguments, they can be used interchangeably. So lastly, in functions, a function can return a value. It can return data as value. It is more like you telling your a younger sibling to go and get you something. So the person will go and come back with information or come back with an item to give to you, that to show you that it is done executing whatever commands or whatever statement that you have commanded them to do. So that is another thing that occurs in programming. So a function can return a value. So how do we work on that? Now, you can see that what I have here is add. Add will just print x plus y plus z. You can see. So I'll be having 15 here. I'm having 15 here. So if I have something like this, we return x, y, and z. If I should run this, you can see it is not printing anything here because it is only returning x, y, and z. So what I have to do now, I have to print. So we have to run this. You can see now it's working fine. I have 15 again. So that is how you return a value from a function. So let's use this square num. If I should say num, and I have like something like 3 here, I should run it. Um, no, 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 square. You can see I have 9 here. So that is all about. You can see how function works. That's all about functions for now. So before we call it a day, here are some exercises for you to work on. The next video I'll pick some of them up, I'll solve them, and you do the rest. So these are the exercises you have. In the next video I'll work on some of them, then I'll leave the rest to you. So you can see, just try to get the problems and solve them. Don't forget that the comment section is open to you. If you have any questions or if you get stuck at any point, try to navigate the course. Okay guys, we are back. So let's go to solve some of these problems. Write a Python program to find the maximum of three numbers. Let's work on that. So to find the maximum of three numbers, this is fairly easy. So def. Oh, okay. The problem first. So def max three numbers. So Okay, let me say x comma y comma z. Okay, so x will be the first number, y will be the second number, then z is going to be the last number. So how do we get the maximum of the three of them? So let me say, well, there are so many ways to solve this kind of problem, but I'm going to assume that x is the maximum value. So just for now, I will declare a variable and say, maybe let me say answer. No, okay. Let me just use answer for now, equal to x. So answer equal to x. Now that I've taken x to be my, I just assumed that will be my maximum value. The next thing I want to do is to say if y is greater than x, then I want answer to be equal to y. That's what I'm trying to say. Then I'll now say again that if z is greater than answer equal to z. Or let me use answer here since both of them are having. Okay, and I think that settles it. So what do I want to do? I want to return whatever is the answer. And boom, case is closed. So let's go to test it. You can say max 3 numbers. Open and close. Let me say 4, 1, 3. But don't forget you have to print it. Okay. Wait. I'm having something here. So answer is x. If y is greater than the answer, let's answer equal to y. If z is greater than the answer, let's answer equal to z. Okay, yes. This is correct. The maximum of three numbers is the first one. So what if I swap I and 4? You can see I still have my 4. So I still have 4. So that is it. So moving on to the next one. Sum up all the numbers in a list. This is fairly simple. To sum up all the numbers in a list, the list let me see. So to sum all the numbers in a list. Now, how do we pass in the list into the function? You might decide to pass it directly. So let me say nums. So nums is going to be the function. Then you just return the sum of nums. So sum is an inbuilt function in Python. So that settles it basically, but it's a ridiculous way to solve the question, but it works. So def no some lists, then you pass in the argument. Let me say 4, 5, 2, 3, 1, 6, 3, 4. So okay, I only returned it. I didn't print it. So print. Okay, so Run this and I have 28, which is fine and good. But then let us do it this way. Let's write a for loop. So for, let me say, item in nums. Don't forget, nums is going to be a list. So you can say, let's say total equal to 0. Don't forget your identity element for addition and subtraction is 0. So meaning that any item you add or subtract, it will still remain the item. Okay, so that would be total plus equal to item, and boom, you return total. So moving on. Okay, so total, let's run this again. I have 28 here. I should run it. You see, I'm having 28 again, so that works. Let me do two more. Let me do two more. Okay, let me do this one. Write a function that accepts a string and calculates the number of uppercase letters and lowercase letters. Okay, so take away the function call. So, well, there are so many ways to do this one as well, but well, let's do it this way. So we have a function that says accept a string and calculates, let me say ul calc. So let me say word. No. God, PHP syntax. I'm sorry about that. So it should be def. So ul calc. Then let me say upper. Okay, calculate the number of uppercase letters and lowercase letters. Okay, let me say upper count equal to, maybe upper count will be 0, then lower count will be equal to 0. Now for character in word, if that character dot is upper, then upper count plus equal to 1. Else, if it's not uppercase, then obviously it's lowercase. Or just to be safe, if character dot is lower, so that should be elif. Don't know why PHP syntax is not wanting to leave me. So lower count plus equal to 1, and yeah, return the list of numbers, which is going to be the upper count, comma the lower count. So let's go and test the function. Ul calc, let me say university, let me print the response. Okay, I think we are good to go. You can see I have 3,7, so the upper count is 1, 2, and 3. Yes, so let me explain the algorithm I'm using here. So basically, I'm writing a function. The name of the function is ulcalc. So don't forget, we will accept a string, which is this word over here, and we'll calculate the number of uppercase letters and lowercase letters as well. So what I'm doing here is that I initialize a count for uppercase letters and also a count for lowercase letters. Now, I'm using the for loop to iterate, to traverse the string. So traversing the string now, I'm saying if the character that you are on at the moment, if the character is an uppercase character, then increment your upper count. Else, if it is a lowercase, increment your lower count. Then after the whole loop, is done executing, return a list where the first item is the upper count while the second item is the lower count. Now, this should tell you something, that in Python you can only return a single data. You can only return a single data, but if you want to return multiple data, so return it as a single collection. So you can see I'm returning upper count and lower count from the same function, but I'm putting everything in a list. So that way you can return multiple data from a function. So basically that's everything I'm doing here. So let me take one more. That takes a number as a parameter and check whether it's a prime number or not. Okay, let me take this one and delete the function call. So okay, write a function that takes a number as a parameter and check the number if it is prime or not. Now, a prime number is a number that if that can only be divisible by one and itself. So basically, a suitable algorithm for this is to first of all partition the number into two. You might be getting a decimal number, so just for safety, you seal the number, meaning that you use math.seal or like round it up to the nearest whole number. So you'll now check from 2 to that particular number. If there's any number that can divide the mystery number successfully without leaving any remainders, then obviously it is not a prime number. So let's implement it. You see what I'm talking about. So def is prime. So I'll have the number num. So I'll say half equals to, okay, there's a way to do it. There's a way to do it. So let me show you something. If I have Python, okay, int 3.5. You see, it's giving me 3. Int 3 plus 6. You see, it's also giving me 3. So basically, when we have the number, just to be safe, we are going to be adding 1 to it. So at least it should be giving me the upper bound whole number. So exit. Okay, so come back here. So just say int num over 2, then plus 1. So for I in range 2 comma half. Now if I if num modulus I equal to 0, then break. Then break. But if after running the whole of this and else, for else, okay, so if after running the whole of this and still you can't find a number between 2 and the half of that number that can divide that number, then obviously it's a prime number. So else return false. Okay, so here we go. Let's test it out. So print is prime. Let's say 3 for example. 3 won't work here because if you divide 3, oh, let's try. Okay, yeah, 3 is a prime number. Then if I say 5, you can see 5 is true. If I say 6, 6 is not true because 2 and 3 can already divide. You can see it's not a prime number. So if you can even take it a step further, if you want to find out the prime numbers, say between 10 and 1000, you can do something like for I in range 10 comma 1001, if is prime I prints I. So what is happening here is this is going to be returning the boolean, which is either true or false. So if it is returning true, then why not print it? So running it, you see we have 997, 991, 983, and so on and so forth. So you can see all the prime numbers we have here: 11, 13, 17, 19, 23, 29, 31, 37, 41, and all of that. So I think I'm interested in the last one. Okay, write a function that checks whether a string is a palindrome or not. A palindrome is a word that reads the same way forward, the same way backward. For example, lawal, Lawal. I can't think of another one, unfortunately. So basically, let me take this one out. Let me copy the question, the problem rather. So copy, then um, okay. So write a Python function that checks whether a passed string is a palindrome or not. So def is palindrome. So let me say word. Then let me say reversed word equal to an empty string. So I want to initialize the reversed word as an empty string. So I will now say for I in range. Basically, what I want to do here now is to traverse the any word that the user should supply to my function. I want that particular word to be traversed, but instead of from the beginning to the end, I want to traverse it from the end to the beginning. So on every character, you append it to the reversed word variable. So you see what I want to do now. So the last index of the word is obviously going to be something like the length of word minus 1. So this will be the element at the last index. Now, the element at the first index will be having index 0, but because of the for loop, I have to stop at minus 1. So because if I stop at 0, then it's not going to be doing for 0. So if I say minus 1, it is going to be stopping at 0, just like the way for loop works. So negative 1, then my step is going to be negative 1 because I want it to be counting backwards. Don't forget, I said if you are giving your for loop 3 arguments, it's going to be start, stop, and step. So for this one, I want it to be counting backwards. So instead of the default one, it will be negative 1. So if, for example, the length of the word is 9, it will be counting 9, 8, 7. You understand? So just say no, minus 1, then reversed word plus equal to word indexing I. Okay, so now at this point the word is reversed. So if reversed word is equal to the word, then return true. So you can just come here and say return false. Okay, so one thing you should know, I did it here as well. Anytime a function should hit a return statement, it is going to terminate that function. So for this one, for example, now for I in range whatsoever, as soon as the function reaches this particular line of code, if for any reason, don't forget I said if a for loop is terminated using the break statement, then it will not execute this else over here. it will not execute the else. It is breaking out of the whole loop, so you should be expecting the next line of code to be 80. So as soon as it hits a return statement, that return is going to terminate the whole loop, then continue execution. So if coming here now, if the reversed word is equal to the original word, then it is going to be returning true, so it will not be returning false. So you cannot have more than okay, you can have multiple return statements in a function, but executing it will not execute more than one of them. So as soon as it hits the first one, that whichever one it hits, it might be the first, the second, and the third, for depending on the complexity of the function. As soon as it hits one of the return statement you have, it terminates the loop. So that is what I'm doing here. Let's go and test the function. No, print um no, yes, palindrome. Well, I should run this. You see, I'm getting through because it works. So that'll be all for functions for now. Try to finish up the remaining ones. I didn't do this, and I didn't do this. So try to. Okay, I didn't do this. Did I? Okay, I didn't. So try to finish those ones. Don't forget, the comment section is open for you to ask whatever questions you have. So thank you. I'll see you in the next one. Bye. All right, guys. We are back to the course. So okay, I'm going to be talking shortly about lambda functions. Lambda functions is a small function. I want to call it a small function. We call it, it's an anonymous function. It can take any number of arguments, but can have only one expression. If you take a good look at the if you rewind the video a few minutes back, you will see that the functions that we wrote, those functions, they have multiple lines within them. But this kind of function, the lambda function, it is going to be taking only one argument. Oh, sorry, it is going to be having only one line in the for execution, but it's going to be having, it might have multiple arguments. So that's what I'm trying to say. Okay, let's get into it. It's going to be a very quick one. So lambda, where are we at? 18, 19. Lambda. Lambda. Okay, so for lambda, take for example, if you want to write a function that will say add 10 to a particular number, so what you're going to be having might be something like y lamb, oh no, y equal to lambda, and the lambda is going to be taking x, and anything it has as x, you add 10 to it. So trying out the lambda, you print y of say 3. If I should run this, boom, I have 13. So basically what is happening, y is a function of x here. So I'm having y equals to lambda x. So lambda x is already telling Python that this is a small anonymous function I want to create, and the parameter required for you to run the function is x. So that x now, anything I have as x, add 10 to it, and you can see what I'm supplying here is just 3. So it will be 3 plus 10, which is going to be 13, which is what I have here. So let's say you want to write a lambda function that will add two numbers, for example, that is going to be accepting that will require two parameters. You can say y equals to lambda, no, lambda, let me say a comma b, so return a plus b. So print y of maybe 20 comma minus 4. This should be giving me 16. You can see I have 16 because 20 plus minus 4 is going to be giving me 16. So Well, it's not going to be a long one. This will be it for lambda functions. The more you use them, the more complex problem you solve with them, the deeper you go in lambda functions. But originally, they are no more than this. So thank you very much. We'll see you in the next video where we'll talk about recursion. Bye for now. Alright guys, we are back to the course. So in this video I'm going to be talking about recursion. So Python supports recursion, which means a defined function can be made to call itself. Don't forget when we did functions last two lectures. So I explained that we have the function call and the function definitions. So you define a function, then for you to have access to the function, you call the function. But recursion is basically you calling the function as a body of the function, like within the scope of the function. So it's a very powerful programming tool, and if used wrongly, it can make your device run into an infinite loop, which can crash your system. So you need to be careful about using recursions. And yeah, let's get into it. So recursion. I think this should be 20. Okay. Dot py. Am I having R here? Okay. So this is recursion over here. We're going to be taking one example, then we go straight into working on three exercises. So let's say we want to write a program that will add up all the numbers from say 0 to a number n. So for example, if n is 5, for example, you'll be having something like 0 plus 1 plus 2 plus 3 plus 4 plus 5. So if n is 10 plus 5 plus 6 plus 7 plus 8 plus 9 plus 10, all the way from 0. So now for you to write that kind of function, let me say um, def, you say count, um, let me say add num. So you can say this one can be x, for example. Now, while writing recursion, your recursion also always have two cases at least. Although I okay, let me say two cases at least. Now, the first case will be the base case. Then we have the recursive case. Now, the recursive case is the case that triggers the recursion. The base case is the case that terminates the recursion. So, while writing recursive functions, I like to write the base case first. But if you write the recursive case first, there's no problem about it. Just know what you are doing. So, def add num x. Now, for me to write the base case, if x equal to 0, I want you to return 0. But if x is not equal to 0, or let me use if x is equal to 0, it's fine. It will never go below 0 for any reason. So s, you will say return x plus add num x minus 1. Let's test the function first. So if I want to add the numbers from 0 to 4, 0 plus 1 is 1, plus 2, 3, plus 3, 6, plus 4, 10. So print add num 4. Run this, and boom, I have 10, so it works. So this is my base case, and this is my recursive case over here. So what I'm doing basically is if x is equal to 0, return 0. But if x is not equal to 0, then I want you to return the sum of x and call the function again. But this time you are going to be reducing value of x by 1. So if x used to be 3, when you call it again, x by 1, it will be 2. If it is 2, when you call it again, it will be 1 till it gets to 0. So the concept of backward substitution in mathematics, it works here as well, where you are trying to solve a problem, but it is not in a standard form. So you try to do some sort of manipulation to get it to its standard form. I don't want to go too deep into that now. So just get the gist here. Recursion is you making a function to call itself. Now, for you to write a recursive function, you need to have a base case and you need to have a recursive case. Your base case is the case where that terminates the loop. The recursive case is the case that keeps triggering the recursion. So let's get into the exercises I have. The exercises I have. So when we do more work on it, I believe it will be better understood. Alt Z. Okay. So to calculate the sum of a list of numbers, the sum of a list of numbers, okay, is almost similar to this one. So the sum of a list of numbers. No. Okay. So let me say the sum list. Okay, the sum of a list of numbers. So let me say numbers. So now my base case. What will be the base case here now? Since we are not calculating just from within a range of numbers, we are calculating a list of numbers. When do I want the recursion to stop? Normally, what I want to do is that I will keep adding all the numbers from the front to the back, or from the back to the front, like from the beginning of the list to the end of the list, or from the end of the list to the beginning of the list. Both of them will work, but I think I would want to do from the beginning of the list to the end of the list. So when the function, when the list gets to the end of the list, then I want it to terminate. And at the beginning of the list, the index is going to be -1, and the length of the list is going to be 0. So the length of the list just returns 0. Okay, I would say if the length of numbers is equal to 0, so return 0, no, 0, else return. Now you have to apply wisdom here. Numbers, indexing the last item, then plus, you call sum list again. Now indexing everything up to the last one. What am I doing? Numbers. Okay, this should be it. So I have sum of list, then it's going to be accepting numbers. Now my base case is what? If the length of the numbers equal to 0, then return 0. But my recursive case is going to be the sum of numbers plus the last item plus sum list, which is me calling the function again. Then I'll now pass in numbers. Then, but this time I'm going to be slicing numbers. I'm going to be slicing all the elements excluding the last item. So let's test it out. Print sum. I know that sum is an inbuilt function, so let's just pass in a list. 4, 5, 5, 2, 3, 1. I'm just trying to generate some few random numbers, and 33. Okay, so let's go with this. So save this. So if I should run this, I'm getting 391. So let me use my recursive function underscore list. So sum is an inbuilt function, but the one I wrote now, let me call it and use it. You see, I'm having 391, so it works. So we move to the next one. Write a Python program to get the factorial of a non-negative integer. Very simple. So the same way, all the problems we have, all the exercises, it's almost the same way we're going to be solving them. So write a Python program to get the factorial of a non-negative integer. So how do you do that? Write a Python program to get the factorial of a non-negative integer. So we start def factorial Then let me say num. Now my base case first. If num equal to 0, then return 1, because it has been proven mathematically that the factorial of 0 is 1. So just return 1. And don't, please, factorial is basically, if you have something like 6 factorial, to be 6 times 5 times 4 times 3 times 2 times 1. So it's not you're not going to be multiplying 0. You stop at 1. So if num equals to if num equals to 0, we return 1, else return num multiplied by factorial of num minus 1. So in mathematics too, 9 is still the same thing as 9, 9 factorial is still the same thing as 9 times 8 factorial. That is exactly what I'm doing here. So if I have 9 over here, for example, though this is not going to be executing, it will just come straight to this one and say 9 multiplied by 8 factorial. Now what is 8 factorial? This will be 8 times 7 factorial. What is 7 factorial? 7 times 6 factorial. So that is how it's going to be working everything down till it gets to 0. Then when it gets to 0, it is getting 1. So it will come back like backward substitution. 1 times 1 times 2 times 3 times 4 times 5 till it gets back to 9. Then you get your result. So that is factorial for you. To reverse a string, yes, this will be the last one. To reverse a string, to reverse a string, so def, let me say rev word. Okay, don't forget, I'm going to be writing my base case first. So if now, when do I want the loop to terminate? When do I want the loop to terminate? Normally, if I have a string and I'm trying to use recursion, don't forget it can damage my system, so I have to be very careful. When do I want recursion to terminate? If the length of my string is 0, there's nothing to do. If the length of my string is 0, because normally I want to be returning everything from the end to the beginning, which is basically traversing it from the end to the beginning. So while I'm traversing, I'm returning it. So that's what I want to do. So if the length of word is equal to 0, what do I want to do? Return an empty string. Else, what do I want to do? Return return word, indexing the last element, plus, this is concatenation I'm doing here, rev word, then rev word, taking word, then indexing everything in word except the last one, and we are good to go. So testing it out, print rev word, then let me say now the university. Okay, you can see Lawal is a palindrome, that's why it is returning it like this. Let me use university or hello juniors. Let me see how weird this will look pronouncing it from the back. Now this sounds Japanese. So I can't even pronounce this, so don't let me try. So well, that is recursion for you. So I hope you didn't just jump into watching me doing it. I hope you try to do it yourself before before coming to look at the solutions. So basically, these are the recursive functions here. Thank you, and yeah, see you in the next one. Bye. Alright, guys, welcome back. So, one of those things you can do with Python comes in very handy actually is scientific programming. So, in this part of the course, I'm going to be introducing us to some inbuilt math functions that we have in Python to make your computation work easier. Even though most of these functions you can write them by yourself, we've actually written some of them, but I still want to introduce us to how to import libraries and also the math functions that are inbuilt in Python. So, getting into it, we are going to be creating 21 math.py. Okay, so I'm going to be starting with we have some functions that are built into Python primarily. Some of the most of the other functions we are going to have to import a library to access them. So the ones that are inbuilt into Python that we are going to be working on, we have the mean, we have the max, we have the ABS, which is the absolute value, and we have the POW. So I don't know if there are any other ones, but these are the ones I know of. So okay, so the mean, so you use it to get the minimum value of a collection. So for the second one, you use it to get the maximum value of a collection. For the absolute value, returns the absolute value. So for this POW, it's going to be taking two numbers, maybe x and y. So returns x raised to the power of y. So no, should be small y. So let's quickly do a demonstration of this thing. So I can say output equals to the minimum value. Let me give it a list. So start typing some numbers. 3, -4, and okay, so my output is supposed to be -4. So print output, and running this for the first time. Okay, so you see I'm having -4, so it works. What if I change this to what is wrong with VS Code? Max. I change this to max and I run it. You see I'm having 5. It works fine. So for the absolute value, I'm not going to be needing this anymore. What is wrong with VS Code? So for the absolute value, I can just say ABS. So the absolute value of a positive or a negative number is just you basically taking away the sign. So it always gives a number greater than 0, greater than or equal to 0. So if the absolute value of -4 will give me 4, and the absolute value of 4 will also return 4. So the people that do computations and all that, you will enjoy using this library a lot. So this is absolute value. Then the last one we are going to be talking about is the POW. So POW is used to raise x to the power of y. So for example, 4, 2. So if I run this, you see I'm having 16. So it's raising 4 to the power of 2. That's 16. So these ones that we have spoken of, these four, they are inbuilt in Python such that you don't have to import a library to access them. But for the next ones that we're going to be talking about, you need to import the math library to be able to use them. So this is me officially introducing us to how to import libraries in Python. Now, what is a library? A library is a collection of Python code that have been written for you. All you have to do is to just bring them into your code and use them. They have been pre-written for you. Just call the functions and use the functions and go your way. You don't have to write them from scratch. Just they've done the function definition for you. So what you're just doing is a function call. Let me put it that way. Even though it is method definition, but just for now, In the next couple of videos we'll be talking about objects, so you understand what objects are. So for now, let me call them pre-written functions that are there just for you to import into this particular Python file. You use them and you are good to go. So we are going to be importing math. So we have math over here now. Since I've import math, what I'm doing basically is that the Python file where all the math functions I want to use, the Python file is available to me now. So I can just go to that Python file. All the functions that are written in that Python file, I can access them from here. That is what I'm doing basically. So if I want to look for, okay, I'm going to be starting with the constants. There are some constants that are pre-written into the math module. So let me print, or let me use the output I've been using, equal to, let me start with math dot, you can see we have so many functions here: sine, cos, tan, even VS Code is giving us. We have the CU, we have the degrees, exponents. You can just play with them, the log 10, log to the base of p, and a lot of them, the prod, the radians, the remainder, sqrt, a lot of them. You can just ignore all these ones for now. Ignore all these ones. The ones you are interested in are this ones over here. So this one is signifying that this is a constant, but these are functions. So let's get back here. So the first one, we are going to be talking about constants. So let's start with pi. I think pi is the ratio of the diameter to the area of a circle. I can't remember, but the value is 22/7, which is 3.142, and the other and the other um, floating point part. So let me print output. Let me print output. Oh, and I forgot something. We also have round here. Round. So you can use it if you have. You can give it one argument or two arguments. If you're giving it one argument, it will assume that the second argument is maybe 0 or 1. I can't remember, but basically you're rounding up to the nearest whole number. So let me do a demo before I start working on math. So if I have something like round 3.142 and I print, okay, for this one, if you put in only one argument, it is assuming that you want it in 0 decimal place, so obviously you're rounding to the nearest whole number. If I should round this, you can see I'm rounding it to the nearest whole number. So now this is because I'm giving it only one value. So if I should give it two value, which is supposed to be an integer, so I'm going to be having, for example, 2. Then perhaps I want it to be in 2 decimal places. So I'm going to be having 3.14. So by default, this second value over here is giving me 0. So that is it basically. That is another one. So let's go back to what we were doing initially. So import math, output equals to math pi. If I should run this, you see I have 3.14159 and all the rest. So that is pi for you. Then we also have math.e. So run this. You see I have my e. Then we also have tau math.down. So run this. Okay. So those are the constants I'm going to be talking about. Then so now going to the functions themselves. Actually they should be methods, but let's just call them functions for now. So if you want to find the square root of a number, you can use the sqrt. So this is a program you can write by yourself. For example, if you want to find the square root of 9, you come here, you can see I'm having 3.0 here. But if you don't want to use the math module, normally how you want to do this is to say 9 raised to the power of 1/2. If you should run this, you you have the same thing. So well, whichever one works for you, but I'll rather I'll rather use this. The reason is because I won't have to do an extra import over here. So sometimes I like to, it's good to actually write some of these functions yourself, so you won't your project won't be too large, like the weight. You have to keep it as light as possible. So sometimes you want to write all these functions from scratch without having to import math, because it's a lot you are importing now. Okay, so um okay, let's go to CO. So this is going to be rounding down to the nearest whole number, point 123 for example. No, I think it will be rounding up to the nearest whole number. Yes, yes, rounding up. The opposite is floor. Floor. It will be rounding down. You see, I have 9 to the nearest whole number. So we also have sine, cos, tan, we have degrees, we have radians and all that. I don't want to spend too much time on this. We also have combination. So if you want to see, for example, say 10 combination 3. So um, so you're going to be having your 10, yeah, I'm going to be having comma 3. So I should run this. You see, you have your 120, nice and smooth. So this ABS over here, we also have one in the math module. We call it FABS. Works exactly like the absolute value. So I can't, I won't be doing that. Then we have F mod as well. F mod. So F mod is going to be giving you the a modular division. For example, 10 modulus 3 is going to be giving me 1. 1. So F mod, but I'm not comfortable with the way it is returning it in a float. I'm not comfortable, so normally I would want to convert it to an integer when I'm done. Int, yes, exactly. So that's better, but let me just take it out. So apart from F mode, there's also there's also one other one I forgot here, sum. So you can use the sum to look for the to add up all the numbers in an iterable in a collection. Let me tell you what I mean. So if I say sum and I have a list, say 1 2 3 and 4, if I should run this, I'm getting 10. So also in math, we also have this math dot f sum that is also going to do the same thing exactly. So I should run this. You see, I'm having 10.0. I think the math module converts everything to a float, calibrates everything in a float. But I wonder why they did that. I'm not comfortable with them leaving everything as a float, but who am I? So, well, that will be all for this particular part of the course. So you can just take a do a bit of research and you get some other modules that are available, other functions that are available. For example, we have the arc cos, the arc cosh, the arc sine, the arc sine. We have a lot of them here, them here. So we have the ISQRT. I think this ISQRT, if in case you look for a number and the square root of the number isn't a whole number, it will round it down to the nearest whole number. Let's try looking for the square root of 10. So the square root of 9 is 3. So 10 should be somewhere around 3 point something something something, but it should round it down to 3. So you can see what I have here. It is rounding it down to 3. So there are a lot you can do with the math module, but like I said, sometimes it is good to hard code these functions yourself so that the weight of your program won't be too much. Won't be too much. So that will be all for this part of the course. I'll see you in the next one. Bye for now. Hello guys, welcome back. So in this video we're going to be talking about classes, objects. So Python is an object-oriented programming language. So being called an object-oriented programming language, it means that it gives room for encapsulation, inheritance, and polymorphism. Now, what is encapsulation? Like the name sounds, to encapsulate something, to give restricted access to something, to hoard. Okay, let me use the word hoard. So to give some sort of requirement for you to gain access to something, that is encapsulation. Then inheritance is you having a parent and a child. For example, you that you're watching this video now, you have parents, and to some extent there are some of their properties that you have. It might be skin color, it might be height, it might be hair, it might be even the facial looks as well. So that is inheritance. Basically, you having children, child objects and parent objects, and the child objects have some functions, methods, properties that is being inherited from the parent. So that is inheritance. Then we have polymorphism as well. Polymorphism is basically when an object has the ability to exist in different forms. For example, you can have a shape object. A shape object can exist as a circle, as a rectangle, as a triangle, as a lot of things. So let's see the person object for an example. The person can exist as a footballer, it can exist as a student, can exist as a lecturer, can exist as a businessman, can exist as a trader, can exist as so many things. Existence in different forms, basically. That is what polymorphism is. I want to keep this course as basic as I can, so I won't be going into this three. I'll be showing us the basics of object oriented programming, and as usual, we're going to be working on some exercises. So, now, getting into it, object-oriented programming. What is an object? What is an object? Now, an object is an object. Everything in Python is an object, basically. Your strings, your integers, your booleans, and all that. They are all objects. So this is supposed to be 22 objects. So okay, so now, take you as a human being for an instance. Now, you can be referred to as an object. It's not an insult. I'm only trying to to explain a concept. So, you have attributes: your name, your date of birth, your last name, your email address, your phone number, and things that are pertaining to you. Those are your properties, your attributes. Then behavior can be, let's say, things that you can do or things that you can achieve. You can refer those ones as behaviors, as methods. Okay, so objects have attributes and they have behaviors. So what are the attributes? Attributes are the properties of the object. For example, as a human, your attributes are going to be your name, your phone number, your email, your address, your level of education, your a lot your bank account balance and all those things. So yeah, those will naturally be your attributes and all that. But your, let me say, behaviors or methods. Now we have functions. All the functions that we have done up to this point, you are writing it outside of the scope of a class. So when you are writing a function within the scope of a class, it becomes a method. So a method is basically a method or behaviors in an object. When referring to an object, are those things that the object can do, or those things, those actions the object can carry out. Basically, for example, as an electrical engineer, you can fix electric problems. As a fashion designer, you can create designs, you can sew them. I'm a programmer, I can code. So you can see behaviors different from behaviors is one of those things that differentiates everybody. So that is basically it for introducing objects. So let's take an object for instance. Let's say class triangle. Also, before I proceed, please, um, classes and objects, people confuse them. So a class is the blueprint of an object. A class is like the architecture of a building. But you know that that same architecture that you have of a building can be built in South Africa, in any part of the world, in Nigeria, in the US, in the UK, in Australia, any part of the world, just that same blueprint. So, what I'm trying to say is that your class is like that blueprint, the architecture of the object. Your class is created only once, but your object can be created multiple times. The class is the definition of the object. Yes, that's how to say it. The class is the definition of the object. The class is the blueprint of the object, but the object itself is going to be the byproduct of a class. Like when you call the object, you get a class. Like functions, you have function call and function definition. So the class is like the definition, while the object is like when you call the class, what it returns is an object. Okay, I think it's safe to say it that way. So class triangle. What are the properties a triangle will have? A triangle will have a base and it will have a height. Then if you combine the base and the height together, you're going to be getting area or perimeter. So that is for a triangle. So how do you define the properties of a class? After writing class triangle, how you define the properties? Base equal to what am I doing? Base equal to maybe 4, then height equal to maybe 7. Okay, so you can see now that our class have been defined and we have the properties base and height. Now let us create an instance of this class, which is an object. Basically, I can say t equal to triangle. Now that t equals to triangle, if I want to know the base of my triangle, I will just print t dot base. So you can see even the code editor is giving me the suggestion. So if I should run this, you see I'm getting 4 because that is the base of the triangle. If I want to get the height of the triangle, I'll just say t dot height. Yes, you see I'm having the height of the triangle. But don't forget, like I said, classes and objects. A class is the blueprint, the architecture of an object, and that architecture can be implemented in so many places, can be called from anywhere. The class is the blueprint, the object is the byproduct of the blueprint of the class. So now, um this particular class triangle that I have over here now, if I should call it 100 different times, by default the triangle is going to be having a base of 4 and a height of 7. For example, if I should say let me say t2 equal to triangle. If I say t2 dot height and I run it, you see it is also giving me 7. So this is like a static way to define a class. I don't know, I've never seen that anywhere. I'm just like trying to explain the concept here. This is like the static way to define a class, because by default the base is going to be having a base of 4 and the height of 7. But one good thing about the class is that you can always modify the values. For example, you can say t dot base equal to 10 and t dot base. If I should run this, you see I've normally don't forget that t is triangle, and the base of the triangle by default is 4. Now I've changed the base to 10 from here, so printing the base again I'm getting what, 10. If I should print t2 dot base, it's going to be giving me 4 because I have not modified the value of t2. So you can see what I'm doing over here. So that is that about that. But nobody defines a class like this, or let me say most people don't let me use nobody is a strong word. So now, a more dynamic way to define a class, which is what most people do, is if I want to define a class with properties of base and height, I'm going to be using the init method. Init, we have so many class methods. Then I'll say self, then base, then height. I might decide to use bh here. So I can say self dot base equal to base, then self dot height equal to height. So bringing my T1 equal to triangle. Now, if I want to, you can see that I've not made any default definition here, any default arrangement. I've not made any default settings here. So what I did is that I only defined a class. This self over here is standing for an instance of the current class. Like this, an instance of itself is this self over here. You can use any variable you want at all. You might decide to say, to use maybe var, it will work. You might decide to use maybe um, tri, whatever you want to use, it will work. It just has to be uniform. But in the Python community, what everybody is using is self. So that is what we are going to be using. So we have self, we have base, then we have height. So T1 dot triangle. For me to create a new triangle now, I have to come here and say my base equal to maybe 7, then my height equal to maybe 9. Now what I'm doing here, if you check this in very well, I'm saying def init. This self over here, I'm having 3 parameters here, but over here I'm supplying 2 arguments. By default, when you call your object like your class like this, calling the class is going to be returning an object. Now when you call your class, this 7 over here by default goes to base, while 9 goes to height. That is what happens by default. So self.base is going to be returning 7, self.height is going to be returning 9. So let me say print t1 dot height. So run this. You see, I'm getting 9 over here. I'm getting 9 over here. If I want to define another triangle, I might decide to say t2 equal to triangle. Then I can say 4 comma 9. No, don't let me use 9. Maybe 5. 4 comma 5. So for t2, the height of t2 is going to be 5 t2. So if I should run this, you can see I have 2 different classes now behaving 2 different ways. So having 2 different properties now. They have the same properties but different values. So this is how you define a class and you define the properties. Now, how do you define the methods that are supported by a class? So don't forget, this is the init method. It is inbuilt into Python. So now for us to write our own method, if you want to write a method, for example, what method do you think we will have in a triangle? We can say maybe calculate area, and the area of a triangle is what? Half base times height. So let us write a function that will calculate the area. So you can say def calculate area. So don't forget, you're going to be passing in self. Now the reason why you must pass in self here is because all the methods that you want to write for this class, there must be this self parameter over here that will stand in as a representation of the current class. So you are going to be returning, no, what am I doing? Returning, you will return 1 over 2. What am I doing? Okay, so let me just times self dot base times self dot height. Okay, so now if I should come here, now that I have calculate area, I can just say t2 dot calculate area. Don't forget, this is a method. So don't as you can see here, I have 1 parameter over here, but since it is only self, I must not pass anything into here, because if I had something like maybe base now or any other parameter, then I must pass in the parameter here. But since it is only self that I have, then I mustn't pass anything. So calculate area. If I should run this, you see I'm having 10. How do we calculate it? This is 4 times 5. It should be 20. Multiplied by half is what? 10. So if I want to calculate the area of T1, for example, and I run this, I'm having 31.5. 7 times 9 should be 63. Then half of 63, that would be 30, 31.5. Yes. So you can see both of them, they are working just fine. Now, another thing you want to know about that we need to know about a class is that sometimes you might want to print a class. You might want to show the string representation of a class. For example, if I should print T1 over here, if I should print T1 over here, if I should run this, you can see what it is returning over here. This is the string representation of T1 for now. But if we want to write our own string representation of T1 of the triangle class, we might say def underscore str. So well, it is VS Code that did the autocomplete for me. So what this is saying basically is that this function returns a string. So, but I'm not passing. I can say return, so a formatted string saying that this is a triangle with a base of this and the height of this or z. Yes. So what would be my base? Since I've brought in self here, so I can just say self dot base, then a height of self dot height. Okay. So save this. If I should run this code again now, printing T1, don't forget T1 is having, what is T1? T1 is having 7 and 9 over here. So, and don't forget self.base is going to be having 7 and 9. And if you check this with a base of 7 and a height of 9, so it is working just fine. If I should print T2 over here and I run this, guess what? It works. It works. So, well, um, one other thing that you will want to know about an object is that well, that we have so many standards of how you write a very good object, but I learned from one of my lecturers in school that in while writing your objects, it is always good to have the constructor at the beginning. Then you have setters, you have getters, then you have the actual methods of the function. All of them, on the long run, they are methods, but it's a better way for you to structure your class. For example, now that I have the string representation, let me try to write a bit of comment here. So this is the constructor, class constructor. So this is going to be the behaviors or class operations. Okay, class operations. Now, one of the reasons why my lecturer introduced us to having getters and setters is because of data encapsulation. Like I said, I'm not going to be going deep into all these things, but I'll try to like brush off on it while trying to explain the basics. So, take a good look. Take an example. You have a school, then a company from a mystery company come and they said they want to be giving all the first class students scholarship. Okay, how do you know the first class students? Now the school is going to be deploying an API. Okay, a form of information system to the company, sharing the students' information with the company. Now, the school is not going to be sharing all the student information with the company. All the company needs to see is the semester grade point average or the current grade point average that the students have. They don't have to share the parents' contact details. They don't have to share the religion, the state of origin, and all those. No, what the company needs is what they are going to see. That is data encapsulation. You're trying to shield data from being too exposed. So for that reason, my lecturer said it is good for you to have the. I'm forgetting a comment here. Representation Okay, so my lecturer said you should have setters. So def get base base. So get base self, then it will return self dot base, then def get height self to return self dot height. Then now, no, these are the getters. So now the setters. So def set base. So you're going to be saying self, having self, then you have value. So you set the base. So self dot base equal to value. You're not returning anything from here. Def set height self comma value self dot height equal to value. Okay, so if you take a good look at what I've done so far now, I have a class constructor, I have getters, I have setters. Now explaining them. The class constructor is going to be triggered when you first create the class. When you create the class constructor is going to be triggered. So now I have all this self.base and self.height here. I need to restrict this data from getting into the wrong hands. So for one reason or the other, I'm shielding this data from the user. So now I have to, but if I'm shielding the data, I have to provide some sort of alternative route to get access to the data. Now, disclaimer: this is not me teaching just the basics of Python. I'm only telling you, giving you a way you can structure your code to look better. You understand? To look more readable and more professional. So we have the getters and we have the setters. The getters are used to get data, while the setters are used to set data, to set the attributes. But your getters will get the attributes. So let me give you what I'm trying to do. So now that now I have my setters and my getters. So normally, if I want to set the height of t1, I will say t1 dot height equal to, maybe, what is the height? Maybe 10. So if I come here to print t1 dot height, normally it's supposed to be giving me 10. Now I have 10 here. Quite alright. So, but instead of saying t1 dot height, this is me exposing data to the user. So one thing I can do is I can use data encapsulation to hide this particular property and make the user unable to change this. So, but me hiding the data, the user might actually have a good reason to change it. So that is why I'm having this setters over here. So instead of me having t1 dot height, I can say t1 dot set height. And guess what? I'll just pass in 10. Now that I've used t1.setHeight to set the value of height, don't forget, set height is going to be assigning whatever value I pass into it to height. Set height. Now I want to return t1.height. If I should run this, you see, I'm still getting the same 10, but normally I'm not supposed to call height directly like this. I'm supposed to use get height. Because set height is going to be setting the value of height, then get height is going to be getting the value of height. So if I should run this, you see both of them are working just fine. So like I said, this is like a more professional way to structure your objects. So we have the constructor, we have the getters, we have the setters, and we have the class operations. Then don't forget your string representation as well. So That is all about objects we're going to be talking about for now. But don't forget, we like I said, object-oriented programming. Three main pillars of object-oriented programming. We have encapsulation, which is the way you shield data from, or you kind of give some access requirements to access data. Okay, yeah. So to gain access to data, then we have the polymorphism, which is an object existing in different forms. Then we have inheritance, which is we having the parent and the child classes. So I won't be going beyond this for objects for now. So I want us to work on the following exercise. I want us to work on the following exercise. With what we've learned so far in classes, we should be able to tackle all this. So you are going to be writing a Python class to implement power where you are raising x to the power of n. You are going to be writing a Python class to reverse a string word by word. Now you are not reversing the string. You are reversing like a sentence. I am a boy. It will be you are going to be printing the word from the back. So write a Python class that has two methods, get string and print string. Get string accept a string from the user, and print string we print the string in uppercase, don't forget. So you write a Python class named triangle constructed by a length and a width, and a method which will compute the area of a triangle. It is very very similar to what we have done here so far, but this is just for a triangle. Okay, what? Oh, but okay, they are asking us to do for a rectangle. So then you write a Python class named circle constructed by a radius and two methods. One will compute the area, the other will compute the perimeter, just not too far from what we have done over here. So, guys, get to work, and I'll see you in the next video where we solve the problems. Bye. Alright, guys, we are back. So, we are going to be working on all this. Well, I won't be doing these last two because these last two are the examples exactly. Just know how to maneuver your way around this and you get this last two. So I'll be doing this top three and we are good. So write a Python class to implement POW, X and N. Now this class, obviously, as you can see, I have X and I have N, so those are going to be my attributes. So the behavior is going to be to calculate the POW. So, or let me say, okay, I can use the string representation. No, 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 they just said a method, so I can just do calculate. Okay, copy this and bring it here. I have, okay, so my class, class POW. Let me just put it in capital letter. So don't forget your def init, which is the class constructor. So I'm going to be having VS Code is just doing the autocomplete. This is one other way to write your function header. So this arrow key over here is telling you that this particular function is going to be returning nothing, so none. So I'm going to be having x and n. So let me just have my x and my n. So self dot x equal to x, then self dot n will equal n. Okay, so what else to implement POW? So the I can say POW self, don't forget self, then return self dot x multiply by self dot n. Now, normally what I want to do is to use setters and getters here, but I don't want this video to be too long, so I'm going to be skipping that. But in your own, please add the setters and the getters to make your classes look more professional. So self.x equals to x, then self.n equals to n. What I want you to do on your end is def, you create your setters and you create your setters and your getters. So you use them here instead of using this directly. So def POW self return this. Now let's test it out. I can say p equal to POW. Then let me say 4 raised to the power of 3. That should be 16 times 4, which is 64. So p, let me print p.pow. Okay, so if I should run this, you see I'm having 64. Something is outputting something here. So running this, I'm having 64. Okay, so well, the first one is sorted out. Then the second one, write a Python class to reverse a string word by word. Okay, reverse a string word by word. um, Comment this out. Reverse a string word by word. So let me say class revstr. So let me say, okay, class, no, def underscore underscore init underscore underscore. So I can say, because it's going to be accepting self dot, let me say, word equal to an empty string. Okay, but it's not going to be accepting anything. So by default, when you call this revstr, normally it's supposed to trigger this function over here, but you are not going to be calling it with any attributes. So by default, the word is going to be an empty string. So normally I will want, okay, no, that should be the way we solve this one. So for this one, to reverse a string, let the user just give me the word directly. Word. I was thinking about the second one, so let this one be word. Okay, so it will reverse a string word by word. No, reverse, this should be sentence. Area, this should be sentence. So def, please add your setters and getters. I don't want to make this video too long, that's why I'll be skipping them. Add your setters and your getters to make your functions look more professional. So def reverse, let me say reverse, then self. Okay, so now if we have a sentence that reads something like I am a boy, basically what this wants us to do is to change the sentence to boy a I. So that is what it wants us to do. Now there are so many ways you can do this. You can do this using a for loop, you can do it using a for loop, you can do it using a, okay, yes, let's use the for loop. Let's use the for loop. Or there's a straightforward way to do this actually. The straightforward way is, since this is going to be a string, I can split it using the space as a delimiter, then I reverse the list. This is what I mean over here. So I can say str lists equal to self dot word dot split. If I split it, using space as a delimiter. This is a string function you can use to convert a string to a list. So I think I explained this when I explained string functions. So now that I've split it using space as a delimiter, the next thing I want to do is to say str underscore list equals to reversed, then str underscore list. Now join it back together. So str let me say self dot word equal to str delist dot join dot space. So basically what I did was that this I converted it to a list. I converted it to a list that is having something like I am a boy. That is what I did with that is what I did here basically. Then what I did here basically is to reverse the whole string. So boy will be taking this, a will be taking the second, am will be coming here, then I will be coming to the last one. So what I did was that after I did the whole of this one, then the next thing I did is to join back the list, like join everything back. That's what I did. So then I'm arriving at this. Let's go and test it out and be sure that it works. So I'm having let me say word. I don't know what sentence. I don't know what to use as a variable name there. REVSCN. Then let me say I am a boy. So print sentence dot reverse. And guess what? Boom. Okay. I'm having an issue here. Okay, reversed, yes. Then we have to do this manually then. Okay, so let's use the for loop for let me say list temp equal to an empty list. So this empty list for I in the length of str, or I have to say range, starting from the length of str list, and you reduce it by 1 comma minus 1 comma minus 1. I'm very sure that you guys understand what I'm doing here because I used this to reverse a string some couple of lectures back. So for I in range length of this, just list temp dot append str lists indexing I. So take this one out, so this should be list temp. Okay, so let me run this again. List temp dot join list temp dot join. Okay, this is where the mistake is coming from. So this should be with the space dot join open, then close the whole of this. Yes. So this is how it's supposed to be. So if I should run this, um, so I will return. No, actually, I'm supposed to return this, not to assign it to self. The word return. Yes. Yes. So you can see, boy, am I. So you can see I'm going to school. Normally, the reverse is going to be school is going to me, but let's run it. So school to going, am I off? Yeah, that is correct, obviously. So well, Python is more correct than I am rather. So we move on to the next one. So I'll be doing this get string and print string in uppercase. So this is fairly simple. So you do the last two. Okay, let me take this one out. Okay. Okay. So class. Don't forget class. Let me say string. So don't forget your constructor def underscore underscore init. So self dot word equal to an empty string. So because don't forget we have a getter. You can see that the question is asking you to actually to explicitly create a setter, and print string is going to be used as the class operation. So you can see what I have over here now. I'm not going to be setting the attribute word directly. So I'm going to be using my setter to set it. So now to create my setter, def set string get string rather. So self comma value. Okay. So don't forget this will accept a string from the user. So self dot word equal to what value. So print string is going to be printing the string in uppercase. Note, you are not to return the string, you are just printing it directly from here in uppercase. Don't forget, please. So, no, what am I doing? Um, def print string, no, string, okay, self, and return self dot word dot upper. Okay, so self dot word is dot word is the string itself. Then self then dot upper is going to convert it to uppercase. So let's test it out. Let me say word equal to string. Then don't forget string is not having anything. So word dot get string. Let me say university. Then word dot print string. Now if you notice very well, okay, print string, I'm not supposed to return. Good. uh, Print, I'm not supposed to return it, so I made a mistake here. So if you look at the question very well, get accept the string, then from the user, then print the string. Print is going to print the string. So note, I don't have to use the print function here anymore because there's nothing to return here. This is printing the string already. So if I should run this, you see what I have. It is having everything in uppercase. So this works as well. So you have these two to work on. Don't forget the two they look very similar to what we did here. So all you have to do is to create your class constructor, your getter, your setters, then the class operations. And don't forget to create the string representation as well. So the comment section is there for you to ask any questions, to seek for help, and we'll be happy to reach out to help as soon as possible. So thank you very much. I'll see you in the next video. Bye. All right, guys. Now that we've gone through the basics of Python, so this will be like the bonus session, the bonus part of the course. So it's time for us to do something real with all we've learned so far. Like, I want us to do something real life with all the knowledge of Python we've gained so far in this course. So now, for this particular lecture, we are going to be talking about Faker library. So for one reason or the other, you might need a ton of dummy data to work on your project, for production services, for testing services rather. I don't know, for production services, you might need it as well. You might need it for your school project, your testing whatsoever. For one reason or the other, you might need a lot of dummy data to survive the day. Let me put it that way. So in this part of the course, I'm going to be showing us how we can generate a ton of fake data in multiple languages, not just English. And I'll also show us how we can save the data as a JSON file or as a CSV. Now, a JSON file is we call it JavaScript object notation. It is recognized across the web. Anybody that does web development will understand what I mean by JSON. But CSV, everybody understands CSV, comma separated values. You can use it in your Excel environment and all that. So let's get into it. Faker. So talking about the Faker library. So 22, 23. Okay. So talking about Faker, the first thing you want to do is to install Faker. And how do you install Faker? You can install it using the pip, using pip. So pip install Faker. So that is how you install packages basically. Any Python package you want to install at all, this is how you install it. So I'm on Linux. So but on Windows too, just open your terminal and you pip install Faker and it will install Faker for you. So you can see it's downloading it. So let me expand my terminal so you see what is going on here. So it is installing all the packages now. You can see I've installed Faker on my device. So basically what I did over here, let me clear my terminal. Okay. Basically what I did over here now is that this Faker library, it is one Python file that is written for me already. It is on the web. It is hosted somewhere on pypi.org. So I need the Python file in this my project. So the first thing I want to do is to install it on my device. Now the Python file used to be hosted online. Now I have a version of what is hosted online on my device. So it is now available for me to use. That is what I've done now. So the first thing you want to do is to import Faker into this particular Python file, like we import math a few lectures back. So the same way you have to import. No, what am I doing? Okay. So you have to import math. So that you can, let me just print, no, 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 no. Math.sqrt for example, and you bring a line here. Running this code now, what are you going to be getting? You'll be getting 3.0. So the reason why I can use this sqrt function is because I've imported math already, and as you can see, sqrt is a method in the math. So if I want to convert this to an integer, I can just and int, because why should square root be a decimal? Well, you might have its use case too, but I'd rather leave it as an integer. So you can see what I have to do here. I have to import math. So The same thing is what we are going to be doing. You have to import faker. So import, um, no, you're going to go from, don't forget that the library we installed is faker. So this is the faker. So from that library that I installed, there is a class there that I want to import faker. Okay, so this faker class is exactly what I need. From faker, import faker. Um, okay, it haven't recognized this. Faker, import faker. Um, fake equal to faker. Then print fake dot name. If I should run this, it's telling me it has not found faker. Let me pause the video. So if you want to create a fake name, this is how you go about it. From faker you import faker. We just installed faker. So from faker you import faker, then fake will be equal to the class faker. So faker is the module. So in this module, like in this library, you have a file, a class inside that is faker. So you can see the class over here now. I'm creating an object for the class, the fake object. Now inside the fake object, there are some methods inside, a lot of methods by which you can generate different kind of fake data. So we have, if you want to generate a fake name, you can go with fake dot name, then it will give you, if I run this now, you can see an Nugent. So the first one was Joseph Nugent. If I should run again, you can see it's giving me Curtis Smith. If I should run again, it's giving me Melanie Stark. Running it again, you see I'm getting Brian Roberts. So that is, you can see that all these names are English names, but if I want to generate, for example, in Italian, let me see, you have to, while creating the faker object, you can optionally add the language you want to initialize the faker object in. Don't forget your constructor, your class constructor. So by default it is going to be in English language, but you might decide to optionally initialize it in a particular language. So if you want to initialize it in Italian, for example, you just say it underscore it. So anything this faker library is giving you at this moment is going to be Italian, strictly Italian. So let's generate 10 Italian names real quick for I, and for I in range 10. Just give me 10 Italian names. So let me just use this. So run this. So you can see what I have over here. I have Binlo Barres. I can't even pronounce all these names over here. So Gabriela Soprano, and you can see these are all 10 Italian names. What if you want it to be in Japanese? You might be having say, I think it's JA underscore JP, yes, in Japanese. So run this and you can see I can't pronounce this. I cannot pronounce this. So if you want Spanish names, I think it is supposed to be es dot es. I can't remember. Dot es. I can't remember. Let me try to run it. Okay, yes. Es dot es. So you can see Kuro Prado and Jose Luis Ayala. I don't know. Angelita. I can't pronounce some of the. I know this is Esteban. I watch a lot of Spanish movies. So you can see what I have over here now. I'm having faker in different languages. So you can just go to Google and look for whatever language you're looking for data for. But if it is English language you want, so you can just leave it like this, and if you run it, it will give you 10 names. If you run it again, you can see it's giving me another set of 10 names. So these are just this is a way you can easily generate fake data for whatever project that you are working on. So if you want to generate fake address, for example, just bring it here, address, then run it. You can see it's giving me fake addresses. You can see. I have all fake addresses over here. If I want to generate, say, fake email addresses, just fake.email, and you see I have fake emails over here. So if I want to generate a fake phone number, I think it should be phone underscore number. Nice. Yes, you can see I have fake phone numbers here. So that is that about that. I don't know where these other ones are coming from. They can just use dot split with, so because I don't like this other part. I don't like this other part. Okay, let me split it. Let me just say phone equal to this, then phone equal to phone dot split the phone using x as a delimiter, then take the first one, so print phone now. Okay, so run this. Okay, you can see, so I'm not having that x part anymore. I'm not having this x part anymore, so I think this should work. So you can see this is how you can generate random data. Let's try to generate the profile of a person, just the profile of a person. I know the person we have the person we have a name, person we have an email, person we have a phone number, person we have an address. Okay, so name, email, phone number, address. Then what else can we generate about the person? Okay, let's just keep it simple to this four for now. And well, let us generate the data in maybe, well, English is fine. English is fine to just keep it simple, but you have the option to fill in whatever language you want it to be. So okay, let me say for this mystery guy, name will be equal to fake the name. Then for this same mystery guy, email will be equal to fake dot email. Then phone number, okay, I've done phone already. Then address will be equal to fake dot address. So the address will be fake dot address, and I think we are good to go. So now to print let's first of all print let's print some sort of demarcation. Let me multiply this by maybe 15. Then print name equal to comma name. Then print email equal to comma email. Then phone equal to comma phone. Then after this address, no, we should print, what am I doing? Then print address equal to address. Okay, So I think with this we have done profile details. Okay, you can see. So let's go through the profiles now. You can see for this guy, the name is Derek Kelly. So I have a fake email, I have a phone number, then I have the mystery guy's address. You can see I have name Kelvin Briggs and all that. So this is like a good example of the fake data that you can use in your projects and whatsoever. But having an idea of how to generate the data is not enough, because you might be working in a PHP application, for example. You might be working in a C# application. All you need is a JSON file, or an Excel file, or a CSV file. So I'm going to be showing you how you can generate this data and also save it in CSV format and JSON format. So we're going to be starting with the JSON format now. So let me use this for example. Let me use this one over here for example. Say I want to generate like say 100 people's data. So that will be for I in range 1, 100, and I want to save it in a JSON format. So the first thing I want to do is to import JSON. Okay, so now that I have JSON imported, um, let's assume that um, I want to generate the data in maybe Hindi underscore in. Yes, this should be for India. Let me run this code first and be sure. Okay, you can see they are all India. They are all India. Okay, so um, well, let me just leave it as English. A good dancer knows when not to spoil it. So um, okay, so we've imported JSON now. Now for you to be able to save your data as JSON, it will be in form of a nested dictionary, like a dictionary inside another dictionary. I will explain. So the first thing you want to do is to do something like this. You will first of all create an empty dictionary. Say maybe all data equal to an empty dictionary. So this is an empty dictionary now. Then the next thing you want to do is for I in range, whatever range of number that you want to generate, you will say all data indexing I equal to an empty dictionary. So if you take a good look at this now, this is the outer dictionary, this is the inner dictionary. So this dictionary will be created 100 times. And now to start creating the data, let's have something like all data indexing I. So indexing name will be equal to fake.name. Okay, so let me just copy this 4 times. So I know that email, then for this one it's going to be phone number, then okay, to make my life easier, let me bring this one after this phone over here. So this one will just be phone, since I've done the calculation here already. So phone. Okay, so the last thing I want to do, okay, let me just bring in the address here. Okay, so I think we are good to go. So I have my name, email, address. Then I have phone equal to fake dot phone number. So phone equals to splitting everything. Take the first part, then now add it to this dictionary. So at this point now, I have an empty dictionary. At this point, this dictionary at this point um, is a dictionary containing 100 other dictionaries. So if it were 1000 here, it would be 1000 other dictionaries. So let's print that dictionary so you see what I'm talking about. Um, Let me do a bit of demarcation here. Print. So let me just print 10 so that my terminal will not be too coagulated. Okay, I'm not even printing the dictionary. Print all data indexing I. Okay, so run this. Okay, you can see what I'm printing currently is only the inner dictionary, the inner dictionary. So you can see what I have over here. You can see what I have over here. So this is the inner dictionary. So if I make this 100, my console will be filled up. So let me just leave it. So all these dictionaries are dictionaries present on the inside of all data. Let me print all data. Let me reduce this to 10, and instead of printing this one, let me print all data so we see exactly, we can picture how it looks. All data, print all data. Okay, so save this and run it. So you can see what it looks like now. You can see in the zeroth index, the zeroth key, you see what I have. The first key, you see what I have. Then I have the second key here, 0, 1, 2. That is how it continues. So now that I've generated my nested dictionary, the next thing I want to do now is to write that dictionary to a JSON file. How do you write it to a JSON file? With open, you can say fake data dot json, the name of the JSON file that you want to create. So, and you're going to be opening it in write mode. You can open it in read mode, write mode. So you can just say maybe as file, then as fp, then you say json dot dump, then you dump the data of the, say all data, comma, what you are opening the file as. So if I should run this, let me just print done at the end. No, it should be a string done. Okay, so run this. You can see it is telling me that it is done. So this fake data.json is going to be created in the same folder where I have this Python file. So this is the same folder over here. You can see fake data.json. If I should open fake data.json, you can see you can see everything is opened like in one line. Like if I should, this is the zeroth index over here. The JSON file is opened in just one. You can see the first index over there, and that is how it continues till it gets to 100. Till it gets to 100. So you can see the third one. Okay, no. I think this one is 10. Okay, I'm still using 10 here. So if I should change this to 100, let me see JSON 1. So it won't overwrite that first one. So it is done. Come here, fake data.json 1. So okay, so you can see the data over here. You can see everything. So you can see the zeroth index, this second index. Where is the first index? Okay, this is it over here. So this thing continues. You can see how the wealth of fake data that we have just now. So you can see this is saving the fake data to JSON. Saving the fake data to JSON. This is it. So that is how to save your whatever data you want to generate. This is how to save it to JSON. You can easily bring JSON into a web project. So that is one. Now to save to a CSV, a comma separated, to save it to comma separated value, um, what you're going to be doing is to create two different lists. One of them will be nested, one of them will not be nested. So I'll be using this same example. So what you want to do is to say maybe fields equal to your first list. So we have name, email, address, and phone number. So name, email, address, then phone number. Okay, so let me just close the whole of this one. So I know that. Okay, then now I'm going to be having rows, but for me to be able to write to CSV, I need to import CSV. So I need to import CSV. So my rows will be equal to an empty list first. To be equal to an empty list. Now it's time for me to go and generate fake data. I can just copy that bit from here. Okay, let me just write it again. So for I in range, let me say 100. Okay. So what do I want to do? The first thing I want to do is to create a name. I can say name equal to fake dot name. Then email equal to fake dot email. Then address equal to fake dot address. Then the thing I did for phone number here, let me just copy it. Phone number, then okay. So next thing I want to do is to say rows dot append. I'm going to be appending a list, and the list will contain name, just like my fields, name, email, address comes before phone, then phone. Okay, so let me use 10 for now, then let me print rows. So we'll see what rows look like. So save this and run it. You can see what rows look like. You can see that rows is a nested list. This is the outer list, so this is the inner list. So Pamela Kane, it's fixed. So let me take it back to 100. So now writing the data to CSV, what do you want to do? You say with open. So you can say fake data, fake data 2, and you're opening in write mode. Don't forget, as let me say FP. Then the next thing you want to do, you can say write equal to CSV dot writer. there's this writer class inside the CSV. So you bring in your FP. Then the next thing you want to do is to write dot write row. The first row you're going to be writing is going to be the fields that will be appearing at the top of the CSV file, the first row. So you're writing row and the row is fields. Then the next thing you want to do is to write rows and no rows. So don't forget, you first of all write your fields, which are the columns, the header, like the first row. Then after writing your fields, you now come and write the data in the row itself. So if I should save this and I run it, it's not showing me anything because obviously I didn't ask it to do anything after that. So come here and you can see I have fake data over here. If I should, you can see these are my comma separated values. You can see the comma separated values I have here, which are in CSV. So you can see the comma separated values I have. You can see them, and everything is line by line. Everything is line by line. So well, name, email, address, and phone number. Okay, so everything is working fine. Fake data too. I think this should be .csv. I think I made a mistake there. So it should be .csv. I think so. Let me try that. Then I'll print done when I'm done. Done. Okay. So run this and okay, done. We're going back to check fake data.csv. Yes. Well, this is how to generate your CSV file. So, well, if you have any questions, comments, you get stuck anywhere, please, the comment section is available for you to get help. So, thank you very much. I'll see you in the next video, which is most likely going to be the last for this course. Thank you for watching up to this moment. I'll see you in the next one. Bye. Alright guys, so we're welcome back. So I'm going to be showing you how to do create, read, update, delete in database using Python. So we are going to be using a simple database engine, which is SQLite. So SQLite is beginner friendly. You can use it to store small data, a small amount of data. So for VS Code, if you want to view your SQLite database, there is an extension I have here, SQLite Viewer by Florian Klampfer. So you can install this extension, and you'll be able to view your database from VS Code, which is what I'm going to be doing. So the first thing you want to do is to install SQLite 3. Then you're going to be installing Faker. So importing your SQLite 3, you say import SQLite 3. So I believe you know what I mean by importing a library. So SQLite 3 is inbuilt into Python by default, so you don't have to install it using pip or something. So another thing you want to install is Faker. Import Faker. Um, okay. Okay, from Faker import Faker, then from random we're going to be using this random we're going to be using this rand int. So a quick one on random, if you want to generate random numbers, that is where this random comes in Python. For example, you can say let me print your random integer between maybe 10 comma 20. So if I should run this, it's running it for the first time. Okay, so it's giving me 10. But if I should run it again, it's giving me 12. So you can see just a random number between 10 and 20. You see, it's giving me 13. So it is how to generate random numbers basically. So the next thing we want to do is to create a database file. Then we create a connection to it. That's what we want to do now. We create a database file, then we create a connection to it. So that is where this comes in. So I've pre-written the code before to, because I don't want to keep this video very long. So to connect to our database, you are going to be needing the SQLite class that we created. The SQLite class has a connect method. So the connect method will be accepting the name of the database file that you want to create. Let me say data Python. Okay, I think this one is better. So data python.dp. So this will be our database file. Like this database file I have over here. If you open it on your end, the same data that it will show here is the same thing it will show there because it's the same database file. And don't forget, you are going to be using this SQLite viewer to view the database. So close this. Now, if I should run this line of code down, let me put print done somewhere here. Okay. So you can see now I'm having done over here data python. Um, you can see data python.dp over here. So if I should try to open it, Python will tell me that I'm unable to open it. I think it's most likely it's because I don't have any data in it yet. So let me close this. So the next thing I want to do is to create a database table. A database table is the table containing the data, just like your Excel sheet, where you have rows and columns. So basically, the database table is going to be having the fields, which are the columns. Then it will be having different entries, which every row is going to be representing. So the next thing I want to do right now is to create a database table. So creating a database table, I'm going to be needing an SQL query. Now, what do I mean by an SQL query? SQL is a language for database management. So SQL itself is a database engine. So MySQL is a database engine rather. So SQL is a language for database manipulation basically. We call it structured query language. Now, for you to, this is the connection that I have to data python.dp. So for me to run any queries against this Python, this data file over here, I have to use an SQL query to run whatever commands I want to run. So for me to create a table, this is what I'm going to be needing to create a table. So I'll say query. I'm going to be using multi-line string here. So let me I'm going to be using a multi-line string here to make it look neater. Okay, so this is my query over here. You create table persons, then now this person is going to be having an ID. They'll be having a name, an email, a phone number. They will also have a score. So I'm trying to create a table of persons basically. And the meaning of what I have over here is that this ID over here will be the unique identifier. It will be an integer and it will be the unique identifier and it will auto increment. What I mean by auto increment over here is that I will not be supplying any data to this particular field. These are the fields where I'm going to be supplying data. Now for every data that I supply to this database, I'm starting from 1, it will auto increment to 2. The next entry I will be supplying to the database will be 3, like that, like that, like that. So that is how I want it to behave. So this is my query now. Now, how do I execute this query? How do I execute this query? All I have to do basically is connection.execute. Then I'll pass in my query, and that is it. So if I should run this one, you see it has finished executing the query. Now I will go back Python dp. Okay, so the file is not displayable in the editor. So but because I have this extension over here, this SQLite viewer, I can open it anyway using my SQLite viewer. So you can see now I have okay, I think this one comes by default. So this is the persons table. You can see this ID over here. You can see the key, and this hash over here shows that it is an integer. This is also an integer. So name, email, phone number, they are all text fields. So that is that. It's a basic database table that we are creating. So you can see the fields over here. We have ID, we have name, we have email, we have the phone number and the score. So it's not a database table that is very complicated. I just want to use this one to explain to us. So now that I've successfully created my table now, the next thing I want to do is to add my first entry. Add the first entry over there. So this query over here now, I'm not going to be using it anymore. So I can just do away with it. Now, how do I add my first input? How do I add my first input? For you to add your first input, this is what you have to do. You create your query this way. Query equal to this alt z. Okay. Now, let me take this one out for now. Take this one out. Take this out and take this out for now. So now, don't forget that this query here, the reason why I had to take it out is because I've created the table already. I won't want the query to run again, so that's why I'm commenting it out. Now, the next thing I want to do is to insert a particular entry into my database table. So, for you to insert entries into this database table, if you should insert it directly, you are going to be having errors. The reason is because we have this ID field over here that auto increments. So because of this ID field over here, you have to specify which table, which columns you want to send data to. This assumes that you want to create an entry. You want to create a new entry. Don't forget what we want to do is CRUD. CRUD. C stands for create. R stands for read. U stands for update. Then this stands for delete. So that is what we want to do. Now let me say this person over here, you can see I'm saying insert into persons. This is the SQL query you can use to create a new entry for an SQL database engine. So I'm inserting into persons, which is my table name. Don't forget the name of my table is persons. If you come here, you see the name of the table is persons. So insert into persons database table. Go to the name field of person, then insert this particular first value over here. For the email, anything I put here. For the phone number, anything I put here. Then for the score, anything I put here. Now let me say name equal to Chris, no, 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 Chris Eugene. Then let me say email equal to Chris at admin.com. Then phone number equal to, I know my country code is +234, just something over there. Then score, obviously my score is going to be 2 million, but let me just restrict it to 78 for now. So for the values, let me say name, then email, then phone number, then score. I believe that we all understand what I'm doing over here with this formatted string. This is just a multi-line string, but I'm formatting it anyway. So we have name, email, the phone number, then the score. Now I want to execute this query over here. If I should click on this, you can see he executed the query. Now it is telling me done. If I come back to Python DP over here, I'll click on this refresh icon over here. You can see that I'm not getting anything, and the reason is because after executing this particular query over here, any query that has to do with database modification, you must commit your query. Connection dot commit. You must commit your query. If you don't commit it, it will not reflect. So now that I've committed it, You can see it done. If I should come back here and I click on reload, you can see I have this ID field over here as one. I have Chris Halogen. I have Chris at, oh, okay, at that.com. Then I have my phone number. Then I have my score over here. So that is how you create an entry. But now, with the knowledge of Faker that we have, let us do a bit of just, let us create more entries. So for us to create more entries, I'm going to be using a for loop. I'm going to be using a for loop. So um, let me just comment all these ones out. I'm going to be using a for loop. What's a for loop over here? Okay. So okay, this has to be a comment. Did I comment out my faker? No. Okay. Fake equal to faker. Okay. So just to space it out. So okay, we are good to go. So for I in range, don't forget I have just one entry for now. I want to go and create more entries. So name equals to fake.name, then email will be fake.email. I have my phone number. Then I believe you know what I'm doing over here. I believe you understand what is here. So at the beginning of this, I demonstrated what rounding is being used for. So I believe you understand what is happening over here. So this query over here, insert into persons, the name, the email, the phone number, and the score. Then the values are going to be taking this obviously. So now, for every query that you create, execute the query. Then after executing the whole query, then you just commit at once. That is what I want to do now. Once again, the fake.name is going to be giving me a new name. Fake.email will give me a new email. What I'm doing over here is just me trying to get a phone number, a random score, then I have the query. Then oh, after building my query, I execute the query. Now I'm executing multiple queries, but I'm committing only once. I don't have to commit every time I execute a query. So um, what next? I will run my. You can see it's telling me, it's giving me the done over here. Come here and reload this. You can see I have all the queries now. I have over 100 over here. You can see, let me close this. Let me close this. So I have over 100 here, 100 records. So as you can see, I have all the records over here. I have all the records over here. So that is how you create entries. You can see I even created multiple entries now. So how do you read entries from a database? Very, very simple. How you read entries from the database. You don't have to commit anything. You don't have to commit anything. So for you to read entries from a database, all we have been doing since is that we have been committing to the database. Now, how do we read from the database? So how you read from the database is that you can do something like results, because when you read data you're going to be getting results equal to connection dot execute. So what do you want to execute? We have to go and build the query first. Now what will the query be? The query is going to be, don't forget, multi-line string select all from persons and query. Okay, then now that I have my results, let me loop through all the persons. I'll be having 100 persons obviously. So for entry person, what do I want to do? Print. Fine girl, what up, how are you? Actually when you came boys were still sleeping. What's up? Please sit down here, I'm recording. Don't worry, they will on the AC very soon. So and I know this place is hot. still come back. If you want to go now, you have to go. No problem, no problem. I just want to record. No problem. You had classes today. Cancel, cancel. So for entry in results, print entry. Okay, so I want to run this code. You can see, okay, what am I doing? I'm print. You can see that it's giving me all the results as a tuple. This is a tuple over here. This is another tuple. This is another tuple, and you can see it goes on and on. I have It's giving me every entry as a tuple basically. So how do I print only their names? As you can see, the name is the second element in the tuple. So I can just entry one, okay, because this will be the zeroth index, the first index, and all that. So run this, and you can see it's giving me only the name now. It's giving me only the name now. Chris Alogene, Amanda Santos, Brandon Allen, Jose Farewell, and you can see everything is working fine. Now, another thing you can do while selecting your data from the database is that you can filter your results using SQL gives you the opportunity to filter your results. What do I mean by filtering your results? You don't want all the entries in the database. You only want the one that meets certain conditions. You don't want all the entries that you have in the database, just some that meet certain conditions. For example, I want to have all the scores of people that scored above 70. So normally I'll just say I'll add a clause to this where don't forget that the fields that we are having here now that we created, we have the name, the email, the phone number, and the score. So where the score is greater than or equal to 70, where score is greater than or equal to 70, run this, and okay, select all from persons where score is greater than or equal to 70. So these are the names of the guys that scored above 70. Now, how do we check their scores? I think the scores is going to be the element in the last index of the tuple that is representing it. So what I want to do, I can just say comma entry indexing -1. So if I should run this, you can see it's giving me their names and their scores now. So and everything I've been having it have been from all this data that I have here. So I'm getting the data. So I'm getting all the table. The only thing I'm just interested in is just the name and the score. So that is everything I'm having over. You can see for everybody I have here, the score is greater than 75. What if I wanted people with scores less than 30? I can just say less than or equal to. If it's less than 30, strictly less than 30, I'll just say less than 30. If I should run this again, you can see this guy had 21, 29, 20, 29, 27, 24, and so on and so forth. So this is how you filter your results. But what if I want to get just one entry? If I want to get one entry, for example, this Jonathan Lewis, if I'm very sure that there are no other Jonathan Lewis on my database records, I can just use this as my search query. You can just say where name equal to, don't forget you have to add this, okay, Jonathan Lewis. But one problem you're going to be having here, I don't know if this will work. Okay. You can see Jonathan Lewis 21. So this is being treated as a string. So you need to add the apostrophe at the beginning and at the end to signify that this is a string. To tell the database this is a string. But if you take a good look at the database table that we created from the onset, you will see that the primary ID, the primary key that we used is the ID. So the ID is a more absolute way, is a more proper way to gets a single database record because that is what is representing every record in the database. For example, in a university, the ID that we have for every student is their matric number. No two students have the same matric number, so it is better we search using um, the ID over here. So if I want to get the person with the ID of 85 or maybe 74, for example, I can just come here where ID equals to 77 or something. Run this, you can see it is giving me Casey Dixon. Let me just print the whole entry so I'll have more information to think about. So you can see I'm having the old tuple here. Her ID is 77, she scored 84, this is her phone number, this is her name, and this is her email address as well. So you can see how you can extract data from the database. Now, how do you update data? Let me use this woman as an example. How do you update data? If I want to update her score to maybe 84, now for me to update her score to 84, all I have to do is to select. I'll first of all I'll be using a different query. So let me just. So what will be the query? Query equal to update, then the name of the table persons, then you set score as let me change her score to maybe 52. Changing her score to 52 where ID equal to what? 77. Okay, so now that I've updated her score. Now I have to execute and commit. So connection dot execute. I'm executing the query. Don't forget. Then after executing the query, connection dot commit. After committing the query, now I want to retrieve the data. How do I retrieve the data? I'll build another query. So after building the query, I'll now say result equals to connection dot execute because I want to be sure that after updating, executing, and committing, if I should retrieve the data back, I'm getting the new score that I gave, which is 77. Initially, the score is 84, but I'm changing it to 77, then print results. Okay, I'm supposed to say for entry in results print entry. Okay, so run this. You can see I set the score to be what? I set the score to be 52, and as you can see, initially it used to be 84. Now it is 52. So that is how you set the database record, right? So if you want to change her name, you can just say set name as, don't forget it will be treating name as a string. So let me say as Emmanuel Chris or something. So where ID equals to 77, you set the name. After setting the name, you execute your query, you commit it, then you select all from presence where ID equals to 77. It will give you a result. Then you try to execute the query. Then after executing the query, it will return the database entries. So those entries, I iterate over them. It's just one entry anyway. So you run this, and as you can see, the name is now Emmanuel Chris. It is no longer Casey Dixon. If you come here and 77, 77, okay, you can see Casey Dixon. If I should, you can see it is now Emmanuel Chris. So that is how you update the records in a database table. So using SQL. So how do you delete entries from your database table? How do you delete entries? Very easy. So the query for you to delete will be equal to delete, no, from person where, let me say I want to delete this, let me say I want to delete this, the person with the ID of maybe 16. I want to delete this Eric Wise. So delete from person where ID equal to 16. Guess what? If I should, let me just commit and execute, then we check directly from the database. Okay. So delete from person where ID equals to 16. You execute the query, you commit it, and you run this. Um, okay, should be persons. Persons. So run this. You can see I'm having done over here. So the ID of 16. Come back here. You can see that the ID still exists. If I should run this, if I should reload, you can see that the ID doesn't exist anymore. I've deleted it. If I want to delete everybody whose, let me say, whose ID is between maybe 1 and 10, like from 1 to 10, if I want to delete them, I can just say from persons where ID is less than 11. And if I should run this, boom, everybody here whose ID is less than 11 is out of the database. So you can see how this works. So at the beginning of this lecture, I said we are going to be doing database manipulation, a bit of it. We are going to be doing create, read, update, and delete. And I've shown how you can create your database table, create entries, you update your entry, you read your entries, then you delete your entries. So thank you very much. I'll see you guys in the next video. Bye for now. Wow, it's been a long walk. But I'm very glad that at least you watching this course, you following the course up to this point means that you've learned a lot. You've learned a lot. You've learned about loops. You've learned about conditional statements, object-oriented programming, and you've done database management a bit. You've learned to create entries, update, delete entries, and read your entries. So now, where do you go from here? That's the question many people are going to be asking. Where do you go from here? So um, well, there are so many areas you can work as a Python developer or as someone who has gained the kind of information they've gained from this course. You might decide to be a backend developer using Python. For you to be a backend developer, you need to know how front end works. You need to know about HTML, CSS, and JavaScript. Then, apart from that, if you want to work in the field of data, if you want to work in the field of data, you're going to be learning a bit of, not a bit, you're going to be learning NumPy, Pandas, Matplotlib, and ways to get meaningful inference out of data. You might also work in the machine learning field. You might decide to work in AI, natural language processing, web scraping, and all those. You can even do audio processing with Python as well. So your possibilities are endless. Trust me. You can do whatever you want with Python. But thanks for watching up to this point, and don't forget to subscribe, and don't forget to like the video so that when we release courses like this, you get notification when we drop them. So thank you very much. Bye.